Ja, je moet ze alle twee hebben.
Oh, but for... Okay. This doesn't need to be recorded, and doesn't really matter.
Yes, you can never have too many mics.
Yeah, so, good morning. We're doing something new this year. I've never seen the deck that Toshaan has prepared, so I have no clue what I'm going to talk about. Apparently this is config management camp. Who's here for YAML camp? That's tomorrow. So we have 3 days of conference prepared again. There's obviously going to be a bunch of schedule changes because people didn't survive FOSDEM or didn't get here or whatever. But is that on the next slide, schedule? No? What's on the next slide?
You'll see in a minute. Well, we need to make announcements about workshops first. So
I was about to talk about schedule and
okay.
Yeah, cool.
You do it. So yeah, we have 3 days, as you know, but our third day, Wednesday, which is the workshop day, has exploded. So please, if you registered for a workshop, make sure you select a workshop that you want to go to. That is not because we want to know where you're going, but we need to do sizing. So it's not the meaning that if someone has 100 people in the registered, that they actually show up, because we give you a hall of 100 people. If there's only 2 people, we can give you a smaller room. And we have an announcement that the SC Linux one has been canceled. We just got the message this morning. We haven't updated it on the registration, but on the schedule it's already there. During the morning I will disable it in the schedule also. So
You do not disable as a Linux?
No, I don't disable as a Linux, only the workshop. Oh yes, Wi-Fi.
Yeah, we probably can replace the whole workshop with one slide, 740. If you're not already on the Wi-Fi, this is the Wi-Fi. If you're here for the second year, it's the same Wi-Fi as last year. So that brings me to a question. For who is this the first year? Whoa. Who's been coming here since the very first year? That's a fun mix. Okay, no, Stefan, we're not going to list all the conferences you should have been to, and not the ones you should be organizing. But nice attempt, because, yeah. Yeah, that's for you.
Yeah, so we have socials, so #config management camp. We don't have vowels because they were expensive. We were able to buy one. The second one is a matrix space. We also have the URL chat.configmanagementcamp.org if you just want to see the general and attendee. And then we have a Mastodon instance, and we also have an Android app since this morning. Which is, yeah, it got approved this morning. I've been waiting like a week for a Google approval. So it's Event Plan, an open source application that we basically put the logos of Config Management Camp, linked it to the schedule, so that should be working. And it's also, like I said, only for Android for now. And then the schedule. So we have 2 talks before the break. Then we have another another talk, and then we have a whole bunch of ignites. I think we had 1 ignite cancellation. So if you want to do an ignite, there's still a slot available.
You know what an ignite is?
It's a 5 minutes presentation, not very long, not very difficult. Slides just auto-forward. And then our sponsors. So Buytaert, it's a German consultancy company, primarily doing Puppet and now most probably other things also. They have a booth there. Please go visit them. We have Ansible, Flux, Pulumi, Isinga, AT Computing System Initiative, and Trilent. These are platinum sponsors. We have Red Hat, Double Verify, QLabs, Kangaroot, and Overlook infrastructure. These ones also have a boot. For the boot, I'll come back to that later. We have SVA, who has swag at the entrance. And then we have Vox Populi, which is a bronze sponsor, which is the open source Puppet modules. Then we have a social event. So this evening at 6 o'clock, you go out from this building and you walk towards the street. You take care when you cross the street, and opposite is directly the zone. And then we have free drinks. To get free drinks, you need a wristband. For those people that have been here before, you know how this works. You go to the sponsors, they give you a wristband. If you don't have a wristband, you find one of us organizers and you'll get one also. But we're trying to encourage you to go and talk to those sponsors so that they keep on sponsoring. And that's it, unless we have any other announcements. No. Like I said, for the schedule, please make sure that you update your registration for the workshop. Again, this is for us to be able to do sizing. Tomorrow afternoon, we will be doing the sizing so that on Wednesday, you actually get a room that you will fit in. So please make sure that you update that. I will update the changes to the registration page shortly. And Michael, who will be talking about predictable workloads we didn't care about. Yeah, I'll take that in a minute. You need both of them.
I need both of them.
Yeah, that's for the stream. So that one you can put. And this one, 1 minute.
Oh, I can hold it. I'd rather hold it.
Okay.
I like to move around when I talk.
Okay.
There are definitely chairs and stuff and places to sit if you squeeze, if you believe.
Are you wired?
I have this, I have this. I don't have that. So. Like, that's the same cable? All right. Seems important.
The light's still on, huh?
Yeah.
Red one, yeah. Okay. If the battery fails, then I will come running down and...
All right.
because
So if I see you running at me,
Yeah,
it's not a crime. All right.
it's difficult to see inside those things.
Yeah.
Yeah, different questions. First, we need to get video working. Okay. Ja, een ander HDMI-kabel?
Dat banana.
Ja. Ah, ja. You see? Waarom die werkt? Nothing working.
Everyone, if there's a seat next to you, please move in. So there's a few extra spots for everyone else. So just please do the Stahnke question. D.AUD, whatever you want to call it. Does anyone have a spot next to them?
Can you go to the Apple setting
Thank
thingy?
you.
I mean, it doesn't see it at all.
Nee. Ah, okay. We'll switch it out.
Well,
This is going to be a short talk.
No signal.
I probably have an adapter. Let me try. We'll just try that and see if that does anything.
So while we wait for Michael to set up, people sitting on site, please start your seat, please start your work, and please be seated on a seat.
It's really more crowded. The beacon is a live stream. And Mark is really lonely here right now.
I don't know what's going on here at all.
Can you try maybe this?
I can absolutely try that.
When you put it in, let me know.
All right. Getting somewhere, maybe. Or do I? Why does this not work at all?
Well, it's telling you to choose something, so. Yeah, with the USB-C.
Yeah, we've been trying things, but I still don't know what I'm doing now because apparently. Is it? No. Like usually there's a thing like extend to this thing, and it doesn't show that there's a display. That's the part that I'm very confused about. Let me try.
I don't know how Macs work, sorry.
I barely know how Macs work clearly, so.
I can do this on a Linux machine, that's about it. I wouldn't even know how to do this on
It
Windows.
says mirror or extend. No, I got it. I got it. I got it. I got it. All right. Sorry, I was used to having to modify an xrnr.conf and then having to rebuild x11, and this was just too simple. I didn't know what I was doing. So, yeah. Anyway, I still have 5 seconds until it's actually time to start anyway, so everything's fine. So, welcome to Config Management Camp. My name is Mike Stahnke. I work at Phlox. We are a sponsor. I did not pay for this talk by being part of Phlox. I've actually been in the configuration management space for a very long time and care deeply about it, which is why I keep working at companies that are adjacently related to it. So I just wanted to put that out there. I'm the VP of Stuff, and Stuff is changing ever presently, so that's why I decided that titling it was just unimportant, and I do stuff for Phlox. So over my career, I spent time at a few different places, but from big enterprise to smaller shops that are more startup-y, and did all sorts of stuff along the way. And most of that is just kind of to think about the arc of my career and what I had done and why I had done it. And as I was reflecting and looking at things, I was looking at these workloads and thinking, wow, we had this whole industry where we defined everything as, if I can figure out how it's supposed to look, I can make it look that way. And that was basically the goal of configuration management. And it didn't matter if you were starting with CF Engine or ISConf, where you went up to Puppet or Chef or Ansible, or you were using modern tools that were YAML-based and you liked it for some reason, whatever. There was just a lot. You could define desired state. But then you got to this purpose where desired state was a myth. And I first started feeling that desired state was a myth when I worked at Caterpillar, because they were always talking about how good the future was going to be, but I realized we never achieved the future because you never actually retire everything or actually complete every project. You get it like 80%, you go have a stellar, move on to the next project. And so basically desired state was also a myth. And I then started applying that to computers, where it was like, well, I've defined most of my state, but there's still parts that are left over that we haven't defined. And it's probably okay because it's probably not changing, but I haven't really said this is how it's supposed to be. And so then you start trying to apply science. I have these workloads, I have these deterministic things that I'm trying to do, and so you start with science. And so we built everything around fixed point. Basically, if the manifest is correct, this system will end up being correct. And the value of manifest, you can insert whatever it's called in your tool of choice. But your system definition, if it's correct, you're all good. So the problem is that a lot of that science under all of this actually is math. And so when you start looking at something like this, I have a function, and if I run the function again, it still works. If I run it again and again and again and again, that's, okay, what's that? That's idempotency, right? If I have this formula, I can do it in this order, I can do it in that order, and it's going to end up in the right state either way, right? And that's commutative, I think is how you actually pronounce that, but I always call it the communicative property because apparently I'm bad at pronouncing things for most of my life. And then you get to this one, which is kind of my favorite, which is just you do a function and you get an output. That's pretty normal, pretty understandable. But the whole thing this is trying to tell you is there's nothing else in the world that matters for y other than that function. And that's really hermetically sealed things. I don't know how to actually say this word either. This is really fun. But basically, the idea is that without side effects, you have something pure. You have something very nice. And so when you try and build something, I don't care if you can't, like, maybe you can't talk to the network during a build, or you can't talk to the extra file system during a build, or there isn't, electromagnetic interference from a printer causing you to have bits flip for parity. Then we get into convergence. We had eventual consistency, which was super fun. We'll get there, I promise. Declarative. We had declarative technologies. We have dry run and planning. Because of that declarative mode, because you're kind of saying, I know what the system state should be, you can actually do things with a plan, which was really great. And so ultimately, we've always been at war with entropy. That was really what this entire thing was. We had a system that we've defined. We're trying to fight entropy, and we move from there. Some people got super obsessed with this. And then this field developed that was called chaos engineering. And to me, it was kind of weird, simply because I was very good at breaking systems. I didn't need the help of other computers to do that. But it just kind of happened. And so we had these known inputs, we had the system, we had known outputs. And then we had users. And if you're like me, users and chaos are roughly equivalent when you have users at a large enough volume. And so basically, a sufficiently large enough selection of users is indistinguishable from chaos engineering. And for those that don't get the little thing in the corner, it's these two people that worked at a convenience store, and they're in the middle of saying, this job would be great if it wasn't for the fucking customers. And it's like, these servers, they would stay online forever if they didn't have applications and users. So, but the problem is we do. And so what did we do after that? Well, recently we decided to take the most difficult part of computers, we replicated it, we've made it super easy to use at levels never imaginable. And what's the most difficult part of computers? Well, the people. And then we started making these processes that we anthropomorphize as people, which is just weird. And then you start to get into other problems where, okay, I have a problem, I've run a workload, it behaves like a person, which is, again, weird. And now I need to debug what's going on. Okay, so I'm not clever enough to do this, and this is from the 70s with Kernighan talking about debugging software. And then you get this immortal SKCD saying, like, the first step toward troubleshooting anything is that you have to reproduce. And if you can't reproduce the bug, how do you actually figure out if it's broken or if it's real or whatever? I'll let you read that for a second if you're not familiar with this one. So you go from this deterministic to probabilistic outcomes. And determinism, okay, if I flip over one of those dominoes, I kind of know what's going to happen to the rest. Over here, I just start rolling things, and I'm playing probabilities. I'm playing bets. And don't look at the dice too closely. There are too many fours on one of them. It's really weird. But now we're in this modern world where probabilistic workloads mean that I do not have all of these certainties that I've guaranteed, or that I'm used to being guaranteed. I run something, stuff happens, and maybe it's okay, and maybe it's not. And if I run it again, it's going to look different. This breaks my brain. I've been thinking about this for like 6 months straight. It still breaks my brain all the time. But now, so we have to think in bets and probabilities and distribution. And so literally, I went and found my discrete math textbook from college. It was one of them that I kept because I actually really liked discrete math. And started thinking about, okay, how do I apply any of this to what I'm currently doing? And what I learned was my love for discrete math and my current understanding of discrete math have not stayed congruent over time. So, but I'm going to take you on a little journey of an example of things that I did understand completely well. And that was, okay, so this is the Flocks website where you can download Flocks. There's no version here in this little like download file, so you have no idea what you're getting when you download. And we got a piece of feedback from a user that said, hey, I'd like to know what version I'm downloading. And I was like, that is a completely valid request. I would like to help with that. And so clearly, I turn to an LLM and say, hey, in the downloading area, there's not a version. It'd be cool if there was. Can you do that? And some LLM says, sure, and it gives me this little thing that says Flocks version 183. I don't love it, but whatever. This is what I end up with, which I do like because it's much more stylized the way the rest of the website works and stuff like that. So that's what I ended up with. But one thing I realized during this journey is that your assessment of simple and complex does not necessarily match your tools or your LLM's abilities or whatever. Because I happened to be at a bar when I was working on that version number change because the person that gave me the feedback was sitting next to me at the bar saying, hey, it'd be cool if I knew what version this was. Okay, I work on that. And I was doing another project that was more a thing that we were just pairing on and having fun with. And so I had two projects. I was trying to add a version number to a website, and I had a 20-year-old application written in Perl that had been running in production for 20 years that I was like, I'm going to go see if I can convert this to Go for funsies. So the version badge took more than 6 hours. I tried it with 3 different LLMs, 3 different tools from the ground up, and what I learned was React was a mistake. The 20-year-old Perl application literally one-shotted it with Gemini, and it ran with the happy path 100% correct. Every single test passed in the happy path. The error handling was a little bit rough, but honestly, I wrote up like 3 tickets and they fixed it, and it was fine. So the thing that I thought was going to be really complex was converting all this Perl code into Go. Wasn't hard at all. Adding a version string, which I thought was going to be literally add like, I don't know, an image URI or something to a page, was hours and hours of iteration. By the way, cores is just the worst. I know y'all think front-end people are like very different and like not skilled the same way that the deep back-end people are. Trust me, front-end is so much worse than what we have it. And so we get back to the science though, where because of that, I was like, okay, I tried to add a version badge and I did it through different LLMs and I got different outputs in different colors and different sizes and different shapes with different levels of technical correctness and all of that. And I was just like, okay, how would I test that at all? I got nothing. No. So I was like, okay, we're going to do science. So we have to isolate and control for the variables. The entire scientific method is you have this whole thing you're trying to prove or disprove a hypothesis, and you want to mess with each variable individually and not all of them at once because then you can prove that nothing correlated to anything else. So basically, I want to make the set of things that I know as large as possible. And so the set of things that I know very well, based on the disciplines here today, are idempotency, commutativity, and hermicity, and hermeticity, hermetically sealed things. And so once I know those things and I have that certainty, I need to find this like anchor in all of this because I'm in this probabilistic world where determinism is no longer the thing that matters for every single workload. My brain still doesn't quite comprehend it, but I'm going to keep talking about it. So I need determinism. And so I have this shift from static to agentic. By the way, every time I see the phrase agentic AI, I just get, I don't know, a little bit non-happy. I don't know what the right phrase is. It feels like you just say agentic or AI, but agentic AI feels very redundant to me right now. But I need the environment to be reproducible because the behavior isn't. And so what I need is the workload, where the workload's happening, to be as concrete and foundational as possible. And then I need to have this boundary enforcement. So basically, when you have an it depends thing, you now have to start thinking about operationalizing it depends into your thinking. And this is kind of done with boundaries where you have, okay, here's the bottom end of what is okay, here's the top end of what is okay, and if we are anywhere in the middle of that, we are happy with how things are turning out. Which, like, conceptually sounds really simple. It does not sound really simple to, like, put on a dashboard and things like that. So But you basically go to, is this behavior within bounds? And as I started thinking about that, and going back to my earlier theory that users are chaos, and I was like, well, who's dealt with this chaos before? And it was SRE. And I mean like real SRE, not an ops team that was renamed SRE. And those are two different things. So, but if you had real SRE, where you had business understanding, where you actually had SLOs, where you actually had things that rolled up to user management and error rates and all of that, you kind of had a lot of this already. And so if I'm making the set of things I know is possible, which is not, make the set of things you know as large as possible, but it can't be that large because the users and the chaos is actually what's driving most of the problems. So we move from this state enforcement to boundary enforcement. We'll get back to the SRE thing in just a moment, by the way. And the other thing is, a lot of people think sandboxing is the answer for how you solve a lot of these problems. This is a completely orthogonal discussion to understanding the probabilistic workload. However, sandboxing is also not the total solution. It's a small feature in the overall output of everything going on. So we have to prove that Y stays within bounds. Well, this is a lot like an SLO from an SRE team where you're saying, okay, my error rate or my P90s or whatever is going on is at this level, it's in a threshold, it's got a boundary that it can't cross. Okay, now we're starting to get something that I think we can relate to a little more. But then you get into some of this math more of like how you would display this into, here's how I know it's good, here's how it's bad. And for years we wanted everything to be equivalent and work. And now we have to use like new symbols and I have to remember the Greek names of these things and it doesn't go very well for that part either. But you want to know set theory. Is my outcome within the set of acceptable things? So if I have a probabilistic workload, is it a member of the sample set of success? That's what that looks like. And let me tell you something. I got to play with LaTeX and put it in Keynote. It was cool. And the other way you can kind of look at this is, okay, the thing I did versus the thing I wanted, the absolute value of that, is it greater than the set of the probabilities that I wanted to be in? You can call that an error budget. But basically, we're in a world now where if something failed, you don't know if it's because of something you did or something that something else did. And that's really hard to figure out. And that's why you want to isolate that to be the smallest amount of side effects that can have that input. But you also might just be at the tail end of a distribution if that one thing looks very odd. So if I would go run that version badge request, let's say I ran it 50 times, and one of them just came out with like a text output that was just, I don't know, I'm just going to screenshot, an 80-character terminal in green screen, and we're going to put that in the version number. Is that acceptable? Is it not? Like maybe it's at the tail end of acceptable. It's like, well, the version number's on the screen. And so you can kind of get to this, what you hope is that you have a bell curve for acceptable outcomes, and most of the time you're kind of in the center and you can work around that. But just like with rolling dice, sometimes you roll snake eyes. It's not that likely, but it's not like unheard of. And it's still fine. It's still legal on a if you're playing with 2 dice. So you have to think about things kind of that way. And then you end up with workload evaluation criteria, which is a fancy way of saying, I know if it worked. And so the process of running is the port open was deterministic, but now we have this like confidence interval. And again, you can map this back to an SRE concept of basically SLO violations, things like that. So it's very much take what you learned from your experience, but think more about this from a probabilistic standpoint. Think more about, I understand these workloads. And statistical alarms, like you don't want it to be the thing that's telling you about it. You want to know of the probabilities of the error curve is immensely. So if you were getting distributions where they're all range for days and all of a sudden it's like everything is at the 9th percentile all the time. Okay, changed underneath or something changed, or the user behavior changed, but something is off there because you're no longer distribution. And so down to now, chaos is a property that we're but the real thing is here that chaos has been a thing that because we always had you.
Can just
Continue. Our monitoring or observability solutions have been doing. They might have been doing it in the user space, but not so much in the infrastructure space. A lot of these tools had things to give you P99s or average or distribution changes, and I just don't think that we had invested in that lower level, like below the application layer, too often. It wasn't never, but it wasn't as often. And so shifting to unit testing to statistical testing, it's like now my QA department needs a minor in statistics was something that I heard, which is fascinating, both that they had a QA department and that they thought you needed a minor in statistics, but it's okay. And so if you run something and it didn't run properly, your boundary was actually the thing that was violated. It doesn't necessarily mean that the thing didn't happen the way it was supposed to happen, or it didn't happen. It's just, okay, I need to run it again, or I need to do it more often, or whatever. And so basically, because of this change with agentic workloads being, I don't know how they're all going to behave, you have to know what right is to some degree, which is essentially the role of QA. But to know what right is, you have to know what it was supposed to do. And to know what it was supposed to do is essentially the role of a product manager. And so we're in the middle trying to figure out, I have this product process, I have an engineering thing happening, I have a QA process, and you have to put them all together and say, I have this probabilistic workload. It's a little bit daunting. It's a little bit scary. I don't know how many of your workloads today are probabilistic, but that's increasing all the time. And what I found is that I can't debug things very well in probabilistic with like mutable things underneath. And I used to think that mutability was a thing that you argued about for academic purposes. It was like, Rust saying, we don't do mutable variables by default, or Clojure being like, it's never mutable, or whatever. And I was just like, this seems super academic and unimportant. And then I got into a lot of this stuff. And then I got into Nix, which definitely also changed the way that I felt about mutability. But basically, you need this environment that can't change so that you can reproduce these workloads or run them more often so that you get sample sets that are valid. If I can run this 100 times and I know the only thing that's changed is the workload and not the environment underneath it or the network traffic or the user patterns or whatever, now I can actually have much better analysis. And so how do you get those environments to be constant? I don't know. Anyway, so basically the new CI/CD pipeline though is you want to provision this hermetic environment. You want to run the probabilistic workload n times and then measure the probability of success. And that does feel pretty different. And there are tools that'll help you do this, and there's the way dashboards that do all this now and stuff like that, but this is just the fundamental, I guess, underlayings of that. You no longer ship because the build passed. You ship because your success distribution is approximately where you'd like it, or within bounds. And you want to have an environmental success score that's valid. So basically, I've done the workload, I put it onto a immutable state, I've run it n times, I'm confident in the interval, I scored it, I know it's within bounds, now I'm going to ship. Or now I'm going to move to the next phase of whatever needs to happen there. So I guess I would say for the summary, you would like to basically pin the substrate, have foundational technology that really locks your environments. And you can achieve this with a lot of different tools. I don't mean to say that this is only working with Flocks, but man, it's a good idea. But you could also use, you can use containers to do a lot of this stuff. Locking a container to be completely immutable is a little bit difficult. You can do it from an image perspective as long as that container in that image is what you use forever. But if you ever want to update that image, now you have a different issue. It's not terrible, but it's just more difficult. You really want to look at the shape of things. And so basically, alert on your shifts of probability, not just pass fail. It's more about the slope of the line than it is the line itself. And this baseline for normal randomness is okay, my distribution normally is this wide versus this wide. And those are just new things to think about, at least from my brain. And so basically, to wrap this up, as I was thinking about it, was determinism was our childhood. Determinism is our childhood, and that was what we had for the last 15, 20 years of this configuration management space stuff going on. It was probably longer than that. I joined it 20 years ago, so that's what I'll say. I can't speak for before that. Probability is where we're headed. Probabilistic workloads, and a lot of that is you can map in concepts that come from managing humans onto computers, which again is a weird thing to pull from, but it is working out pretty well. And then we have to have these strong foundations that are side effect free to run these probabilistic workloads so that we can get accurate measurements to see if they work or not. So taking all that into account, the amount of code being generated by LLMs and AI tools and such like that is large. And there's still a high degree of skepticism for it. That's fine, it's healthy. But there's also people that are wildly successful with it. That's fine. Somebody should be, we're spending $1 trillion on it. But basically, we have this unknown quality now. We don't really know if the code that we're seeing for most workloads is good. And if you don't allow AI, that's great. Do you buy software? Cool, because that might be written by AI, so something in there is probably written by AI regardless of what you're doing. And so you need to treat basically this stuff as hostile, because you don't know. And honestly, if you treat everything as hostile, it's not necessarily a bad foundation to start from regardless. Users are terrible. So you have to basically have these control points to develop. And if I was going to leave you with something to think about, it's if you've been building this world of configuration management and operational technologies for a long time, developers were kingmakers for the last 15 years. Whatever developers wanted, they basically got in our industry, in our verticals. In most cases, unless you were super highly regulated where you could just tell developers to pound sand and say you have to do it this way. It's not super common. But now that you have this hostile code, you need these control points and you need these developed. And so this is our time as operators to actually be back in the world and be relevant for everything. And I'm really excited about that. But it does mean we have to evolve and we have to understand these modern workloads. So in closing, wow, statistics is weird. And now I need to know that to do my work. But if I'm good at it, I have job security like I've never had before because these workloads are nuts. Okay. So that's how I'm going to wrap. Basically, I want you to think about kind of the world has changed in that we strived for determinism for a long, long time. And then we went to probabilities, and we're all learning about that again if we haven't thought about it since university or ever. So yeah, there's the QR code for this deck. We do have a Phlox workshop on Wednesday, so if you'd like to check out more about Nix or Phlox, we'll be there. And thank you very much.
Don't go away, don't go away.
Okay.
Thank you very much for the talk. We have a little bit of time for questions while our next speaker gets set up. So if you'd like to ask Michael some questions, just raise your hand. And just repeat the questions, if you don't mind.
Yeah. Nobody has questions.
Who's got a question?
Nobody has questions.
The other thing you can do if you're a bit shy, you can post your questions on Mastodon, and we can debate all these topics. I'm about to post something myself. Yeah, Adam, go ahead, just scream it out. And
Michael, is it that F changed or X changed? Because it sounds like in your talk you're saying that the change is that F is probabilistic. And I think that that's wrong. It's X that's probabilistic. The inputs are what's random, not the function. Most of the system remains deterministic.
Yeah, so I think Adam is basically saying, is the function that changed or the thing you're operating the function upon changing? Yeah, the inputs. And I think that's a totally valid question. And now that I'm thinking about it, I like your answer better than mine. So no, it's fine. The workloads are not deterministic. Like I actually don't think a lot of the workloads are deterministic. Like the way they operate is, but the payload through it isn't. And so I guess it depends on where you're measuring as to what the function is, like what's the unit of function, because is the workload itself a function that you can't determine the output of, or is it the superset of everything that's building up the workload? So does that make sense, or am I just rambling?
I think you're maybe rambling.
He said, I think you might be rambling, but I love it. Okay. I'll take that. So, yeah.
So we know that the substrate is most likely not going to be deterministic because as we know, the meme is we test in production, right?
Mm-hmm.
So what do you do in those cases where you can guarantee that the substrate is not going to be deterministic?
Okay, so he said, we know that the substrate isn't deterministic because that's why we end up testing in production, which is fair. And so what do you do then? And my answer is cry. No, I think it's, you have to kind of figure out where your risk tolerance is for certain areas. In some cases, you might say, I want a very deterministic foundation. In other cases, what's your cost of being wrong? Like if your cost of being wrong is super low and you can ship again in 3 minutes, it's not that big a deal. And so it might just depend on what right and wrong looks like or what your risk tolerance is. But I will say that having used a lot more immutable infrastructure and foundational stuff, I've tried to make that deterministic base as large as I can. But even some of the workloads that are on it are crazy at this point. So, yeah. One more? Okay.
Yeah, just perhaps a silly question. How do you actually emulate chaos
Check.
in a
Han?
pipeline?
Good.
So the question is, how do you emulate chaos in a pipeline? There's a few different ways to do it. One is you actually just roll it out. No, I am dead serious. Like when I was head of engineering at Circle CI, we would put out a change, put it to 0.5% of traffic or 0.025% of traffic or whatever, and you'd start to get signal really quickly on what the error rates were on that. And if the error rates were below threshold, you'd continue rolling out to the rest of the fleet. And part of that was, people would be like, well, how do you not test that ahead of time? Okay, I don't know. Then people would be like, how do you not test that ahead of time? It's like, we can't build a test infrastructure that can replicate this amount of traffic, this amount of service conversation going on, and so you have to just isolate small volumes of it. And we could route certain customers to make sure they were never on the canary routes and stuff like that. We had a lot of control points like that, and that's what I'm saying, like a lot of this stuff for probabilistic workloads, if you go borrow from SRE, you actually will get a lot of the distance covered that they would like to get. So, yeah.
Any more questions? We have
All right.
some time, so don't be shy. We'll take hard questions. He gets paid the same if it's an easy or hard question, so don't be shy.
We can sing songs if you want.
Yeah, over there.
If AI bubble will burst and all this will die, does it make any future?
I think his question was, when the AI bubble bursts and dies, will there be a future? Was that what you asked? Okay. Like, I have a couple existential thoughts on this one. No, I don't think probabilistic workloads are going to completely go away. I mean, they never really have. You've always had users and stuff going on. But you also have, how do you measure the outcomes of these? Like, okay, so maybe AI bursts in some way. Do you think it's going to go to zero? I don't. Most technology doesn't. Even if it blows up, you learn from it and you move on and you build upon it. And a modern LLM may be great for 3 to 5 years. Who knows? Maybe the next thing is generative AI replaces all of this, I don't know. Somewhere we get to the point where Skynet exists or something, and then you still have probabilistic stuff going on. Maybe we have to measure it or defend ourselves or whatever. So.
Just a quick organizational note. If you do want a seat, and we're basically at capacity here, there's also the overflow room just in the main building where you came in and had breakfast. So you can sit there, it's cool, and there'll be a live stream of this room as well if you really don't want to be on the stairs. We've got at least time for one more question. In the back, someone on the stairs. Kris, I think Kris has a question on the back. If not, then let's give one round of applause for Michael.
Thanks.
So as it turns out, it's not entirely optional. So if you're on the stairs, please try and go to the overflow. Thank you. If you want to run, I can delay his talk by like 1 minute, but you got to really boot it. Because you don't want to miss Richard's talk.
Give him a minute.
Yeah. Can you say where the overflow room is?
I did. Just a reminder, the overflow in the main room where we had the breakfast, in the back, there's that room there, the big conference hall. It's called Econ. E.con.
Where'd Michael's mic go? Oh, there you go. There's both. So you can have your own check. This is yours. And then I'll introduce you, and then you.
Okay, is this on?
It's on.
It's on. Check.
Little timer warning things.
Might be helpful, but
You can hold up little signs.
yeah, I didn't really time this. I didn't really attempt to time this.
It's not the end of the world if you go a little over. We have a break right after.
Mhm.
If you want.
And we're sort of starting earlier.
We'll start you like 4 minutes early. So you'll have an extra 5 minutes if you want.
Yeah. Yeah, and I wasn't aware whether taking questions are customary.
Yeah.
That's fine, although I'm not sure. I can take questions on any topic.
Don't
If the battery fails, I will come down.
Oh,
and,
okay.
help you.
don't say anything too embarrassing because you're live now.
Yeah.
Better?
Start in 2 minutes, get those overflow people a chance to get in. And we'll start 5 minutes early. Well, just a longer break then. He's supposed to start at 10:20. No, just let him start now. Yeah. And then we will do a longer break, or if he has more questions, then so much better. But
So keeping in mind that everyone can hear us, I was looking it up. I think I've actually known you for 13 years. Met you 13 years ago. If you can believe it.
It's possible.
Jeez.
it's really my great pleasure to introduce Richard Fontana. I was trying to do the math, but I had the fortune of meeting him around 13 years ago, if I didn't screw the math up. I was a young kind of junior Red Hat employee that I had just gotten hired, and I'd known about Richard as kind of being an authority on everything licensing and whatnot. So I randomly knocked on his door when I was in the office in Red Hat. And he was a super friendly, super nice guy, and I've basically had the pleasure of knowing him since. If you don't know, he's basically been Red Hat's key open source licensing lawyer. He is an actual real lawyer for forever. He's consulted and advised countless open source projects and developers. And actually recently, as you know, Red Hat got purchased by IBM. The legal department, as I understand it, at Red Hat got actually consumed?
Merged. Integrated
by IBM. So anyways, I'm very happy to have him today as our keynote speaker, so please give him a giant round of applause.
Thank you. Thanks, James, for that very nice introduction. Yeah, one question I was wondering was whether Joe Brockmeyer would be here. Does this mean you might write an article about this?
Just might, yeah.
So hopefully it's not going to be a very interesting talk, so it won't be worth writing about. Yeah, and you're giving a talk here tomorrow, right? So this is not a talk about config management. If that wasn't already obvious, I don't have any significant technical experience in config management that I'm aware of. I have in my day job provided legal advice, legal support to people working on some of the projects that people are talking about here, like Ansible and particularly Ansible once in a while. I noticed there's at least one session on Puppet. There's one on Foreman. So I've you know, I have that kind of experience of supporting the people who are creating that software. But this is more of this is a talk about open source. So if you work on open source, some of this hopefully will resonate with you. Let's see. So, oh yeah, James mentioned that I've worked at Red Hat, and now I am officially an IBM, like in a direct sense, an IBM employee. There are a lot of Red Hatters here, I'm aware. Like, are there any IBMers, like non-Red Hat IBMers? Just curious.
They are, they're just shy.
Fascinating. Out of morbid curiosity, is there anyone here from HashiCorp? Not one person.
Also hide.
Yeah, you don't have to hide. Yeah, so I still identify as a Red Hatter. I don't really identify, you know, for what it's worth. But this talk is not a Red Hat talk. This is not an IBM talk. I am on vacation. This is like, seriously, I wanted to go to Ghent. Yeah, so yeah, this is my first time here. So that's very important. It's possible that in the course of giving this talk, I may briefly like put on my red hat or not, you know, or sort of draw upon some experience. I mean, the talk reflects my experiences at Red Hat mostly, but that's only because I've been working there for a long time. All right, so yeah, this is kind of an unusual talk, I think, because it's a little bit half-baked, but maybe in the future I'll give a better version of it than I'm likely to give here. So one thing that, you know, the way I look at open source may be a little bit different from the way most of you look at open source. I tend to be fascinated by the problems I see in open source. You know, I'm struck by how there seem to be these you know, periodic crises and disagreements and arguments. And one reason, well, obviously some of those are about technical stuff that you will all be familiar with. But some of them are about like what, for lack of a better word, a better term I will say is legal stuff. Or stuff that is sort of interesting to lawyers who sort of specialize in this kind of space. And you know, I used to, the people I work with at Red Hat, the Red Hat, you know, Red Hat, lawyers who support Red Hat, I should say now, they're sort of like a little bit more distant from open source than I am, and they often ask me like, okay, well, like what's the latest controversy in open source? So there's even they have this awareness that there is this kind of recurring tendency for people to have arguments over stuff, and for there to be concerns about things sort of relating to legal stuff that are going wrong. So I sometimes think of these as crises. I'm going to refer to them as flashpoints because I think crises is a little bit ridiculous. But I kind of, you know, there are arguments and debates, and you probably are aware of some of them, even if you have not been in open source for a very long time. So it occurs to me that these periodic arguments and crises and flashpoints, whatever you want to call them, they're not like totally random. They're not, each one is not totally new. They seem to have some underlying features in common. There's a pattern. There are some patterns, or at least that's what I would try to hypothesize. And in trying to think about this, I think that you know, the thing that varies over time is what I'm going to call infrastructure, for lack of a better term. And when I say infrastructure, I couldn't come up with a better word for this. But what I don't mean like servers and networks and stuff like that, although I guess I could include that. But I kind of just mean like the current state of play that software is situated in, from a technical perspective, business economic perspective, cultural, social perspective, like everything that is sort of relevant that is going on in the current situation that software exists in. And if that is sort of confusing, that's understandable, but the concept might make a little more sense as I go along here. So there's this varying infrastructure, and that's actually the varying feature is the common thread. So when I think about this concept I'm calling infrastructure, again for lack of a better term, the way that participants in ecosystems around software sort of exercise power and freedom, and whether from a kind of legal standpoint or business standpoint or whatever, social standpoint, think about the governance of open source projects. The infrastructure, the features of the infrastructure at any one time are going to affect like whether you have freedom to do stuff or you don't have freedom to do stuff, and whether some people have more power than others at any sort of given moment. Just going to take some water here. And a key, I mean, I think I haven't said this before, but in a way it's kind of obvious, an obvious point. So the underlying like legal foundations, James mentioned the term licensing. He said I forget how he put it, but I do work on licensing, or I'm knowledgeable about licensing. There is a tendency to kind of think of lawyers who work in this space as focusing on licensing. In fact, many of them do, but that's actually, in a sense, like one of the problems that I've observed. So the licenses in open source are built on these normative definitions, and you probably, hopefully, know about like the 4 freedoms that the Free Software Foundation maintains. So free software being embodying the freedom to run, study, modify, and share. There are other formulations of that. And then the other major normative definition for open source doesn't use the word freedom, I don't think, but is sort of focused on the same kind of concept in a more complex way. It's the Open Source Initiative's 10-part open source definition. And the observation is that these normative definitions that are kind of like think of them as like a constitutional foundation for open source. I won't even really say the legal part of open source, it's sort of open source in general, that these are anchored to an earlier technological world, the world of the 1980s and 1990s. It's kind of obvious because that's where these things actually came from. They were formulated in the late 1990s, and they have roots. Some of them have, the FSF's 4 freedoms has, well, it used to be 3 freedoms, I think, back in the 1980s. So it goes back to the mid-1980s. The open source definition is basically a modification or rebranding of the Debian free software guidelines, which is still sort of a constitutional basis for how Debian decides what is suitable to be packaged in Debian. So this is kind of old stuff. And the observation that I'm trying to make here is that this concept of infrastructure, so the state of play in software obviously keeps on evolving, and there are each time it evolves, these new tensions and power dynamics pop up. But the definitions that are, underlie our understanding of open source and free software stay the same. They haven't, for the most part, haven't been revised, and in fact, no one is really interested in. Well, that's not quite true, but the gatekeepers, and I think I've been one of these gatekeepers in the past. The gatekeepers don't want to revise these definitions. They very much support these definitions. So in a sense, it's open source is a conservative domain because it is tied to these old definitions that don't get modified as conditions change in technology and the economy and so forth. And so one of the features of open source that you see occurring when these arguments come up over stuff is that a lot of times people, not all the time, but a lot of times people think you can fix new problems by, perhaps coming up with a new license that resembles the old licenses. Or, there are some people who so I'm going to contradict something I just said, that there is a small group of people who would argue that the normative definition for open source should change, but they kind of are still basing their understanding of the need for those normative definitions on the old established system. And so people sort of naturally reach for legal fixes when things go wrong. And sometimes that often doesn't really work well. And sometimes that actually creates new problems. So this concept of control points or leverage points. So infrastructure changes over time, and when infrastructure changes, new opportunities to exercise power occur. That's what I was saying before. These are control points, new control points. Sometimes when you try to fix them with legal stuff, things misfire in a sense, and the legal fixes create new problems and new control points, kind of ironically. So I also want to emphasize that when this concept of infrastructure, when infrastructure changes, conditions change, but so leverage points become available that might not have been available before. Opportunities to maybe make profit in a certain way or have a certain type of business model, or exercise power in a sort of project relationship or whatever. Those conditions change, but the actual the opportunities to exercise control appear that weren't present before. But humans are the ones who actually make the choices to exercise a particular means of leverage. So there's always, this is not like a deterministic concept that I'm kind of, articulating here. It is ultimately human. Humans involved in open source are the ones with agency, obviously, and nothing is predetermined or inevitable. So I don't know if any of that made much sense, but I'll try to I'll attempt to illustrate this a little bit by going through history and some of the history, or some of the interesting things that I think have happened in the history of open source. I'll sort of breeze through that, but hopefully some of it will clarify that kind of framework I was kind of trying to articulate before. Some of the interesting historical developments fit this kind of model better than others. So if you think about the origins of copyleft licensing, so copyleft, by copyleft, of course, I mean the GPL, the basic way the GPL is implemented. So the GPL was an aberration. The GPL is a very interesting license from a historical perspective, because before the GPL, originally you had software developers sharing code, and they were able to do this, of course, because for the longest time it was not clear that law could be used, legal constructs could be used effectively to prevent people from doing stuff with software at all. So software was inherently free. It was a commons. And then it became clear that copyright applied to software. That happened in the late 70s, basically. And suddenly, for that reason and some developments in the sort of business or economic sphere, and this is a kind of infrastructure shift of the sort I'm talking about, it became possible to exert copyright over software, which made it possible for people to have restrictive licenses. And not only that, but thanks to at least one court case from the United States perspective, and I assume that there were parallel developments in other countries, it became established legally that object code was just as protectable with copyright as source code. It's not actually inherently obvious that that should be the case. So you could protect object code, you could protect software in general through copyright, and what that means is you have the right to do things under copyright law that only the copyright holder can do. So if you're the copyright owner, you can stop people from making copies, basically, or distributing, or making modifications. That's the basics of copyright law. Once copyright applies to software, you can suddenly have, business models like Oracle or whatever. This is sort of like a kind of obvious but extreme case. Business models based on restrictive object code licensing. So the GPL is kind of a response to a leverage point that came to exist through these legal changes and economic changes at the same time. And the GPL, famously uses copyright law to create a different type of license that tries to keep software free. So the thing that happened was that, in particular, was that because software was copyrightable, you could take code that was already in the commons and create proprietary software based on it. And this actually happened. And some people were very happy about that, but many people were not. And many people in what became the free software community were not happy about it. And the GPL provided a legal mechanism for sort of combating that. So very interestingly, yeah, the GPL is a well-intended attempt to use a legal tool that became available to improve conditions that were sort of affected by changes in the law, right? And the GPL was very controversial in software developer communities. Some people, and this is true to this day, there's a schism, of course, between copyleft and permissive licenses, like the MIT license or whatever. Early ancestors of the MIT license, and of course the BSD license existed prior to the invention of the GPL, and that's in the mid-1980s. So when the GPL is invented, pretty soon what came to be called the dual licensing business model was invented to exploit it. So that, in a sense, the invention of copyleft became its own infrastructure shift. And it created a leverage point that some software developers decided to exploit. And this is really interesting because the GPL is designed to prevent software from being exploited through copyright. Dual licensing is designed to use the GPL to make proprietary software licensing of a certain sort effective again. Because dual licensing is when you have copyright control. For those of you who don't know, it's not talked about as much anymore for various reasons, but it's kind of a foundational development in the history of open source. So dual licensing is where you have control. You're the one copyright owner of a GPL license code base, and you provide a proprietary version for a fee. So you're combining GPL, you're using the GPL to have a proprietary software licensing based business. And that is very controversial, but it took a long time for people to develop the vocabulary to explain why they were concerned about that. And part of it was the experience of how it was used in practice. So this is just an example of how one change leads to another change where the motivations are quite different. Instead of the motivations being to perpetuate the free software commons, you have people using the machinery of copyleft licensing to move, in a certain sense, move code out of the commons, even though in a formal sense it's still there. And there's nothing in the GPL that says this is wrong, or any other mainstream open source license or free software license. Very difficult to if you wanted to try to implement a license to affect that, it's very difficult to do so, and maybe not possible. I've had some arguments about that with people. So you have dual licensing, and dual licensing is also important because it's the first example of a phenomenon that starts to repeat itself throughout the history of open source. This feature of asymmetry. When you have dual licensing, you have to have one copyright holder, and they have control. The way it works is only they have the right, because of copyright, only they have the right to license the software under a proprietary license. Anyone can exercise their freedoms under the GPL, but only one actor has the freedom to use proprietary licensing. So that's an asymmetry, and we see after that many other types of similar asymmetries in the history of open source. So to implement dual licensing, you need copyright assignment or contributor license agreements that give more power to the maintainer of the project, right? Because otherwise you're sharing the power to create proprietary versions. So it kind of legitimized asymmetry, and asymmetry starts to pop up in the 1990s and early 2000s to the present day. Asymmetry becomes a feature of many aspects of open source that relate to legal stuff, not just licensing. So contributor agreements is an example. And just like in general, it's not just licensing. So it becomes a feature of open source that entrepreneurs, businesses, companies come in and use open source as a way of making money, earning revenue, making revenue in a way that is somehow divorced from the ideals that the software, open source software is founded on. So this idea that you have this system that is founded on these principles of sharing and so forth, but people make use of it precisely because it is, in a sense, because it is so permissive in the freedoms it gives people. People use it to introduce new forms of scarcity in some way or other. So the infrastructure shift that you probably, even if you think what I've been saying makes no sense, you probably have heard of what I'm going to anachronistically call the SaaS loophole. So once what's now called SaaS becomes a thing in, let's say the early 2000s, it's soon realized that this kind of breaks open source licensing. And the reason, it actually does kind of break open source licensing in general, but it particularly breaks the GPL and copyleft licensing. And the reason is pretty simple. The legal foundations are based on distribution. So the normative definitions I talked about are all kind of based on, distribution. The licenses, the familiar licenses in open source, there are conditions in these licenses. There are things you have to do for at least with some of the licenses. They're generally all triggered by distribution. When you have SaaS, you no longer have distribution of code, and so if you use the GPL in a SaaS context, you sort of escape the intended obligations under the GPL, even though you're doing things that are sort of similar to what distributors do, because the requirements in the GPL to provide source code, if you distribute a binary, the requirements to license derivative works, modified versions under the GPL, that's all distribution triggered. So in a sense, with SaaS, copyleft GPL licensed software becomes equivalent to permissive licensed software. There's also, this affects permissive licensed software too, because these licenses do have some requirements. They're pretty minimal. Well, some of them have some requirements. They're pretty minimal, but they do have requirements that some people usually mistakenly called attribution, but you have to replicate information. When you distribute an MIT licensing, you're supposed to replicate a copy of the license, the copyright notice, which is usually the author's name. So people think of that as attribution. That also breaks generally in the SaaS model, the SaaS context. So this is kind of a crisis. And so there were responses to this. It was called a loophole because it was perceived as a loophole in open source licensing. And some of the responses, again, there's this element of human agency. So some of the responses are kind of based on principle. People are like sincerely, non-cynically worried about the integrity of open source. And others, again, kind of see an opportunity to exert leverage. Yeah. So just some obvious examples. What I think is a well-intended solution is represented by something like the AGPL, the Affero GPL. So this is sort of an attempt to patch the GPL. I mean, there are actually multiple versions of the AGPL, but thinking of it as one version. To put it pretty simply, it's an attempt to patch the GPL so that there is a trigger that is not just distribution, but basically deployment of a service becomes a sort of trigger point. I would argue that AGPL was well intended, but I would say it is not that well designed to combat the problem it was created to deal with. And I think that's an example of what I was talking about before, that we reach for licenses, when we see these problems, and we try to just like make little fixes, and that's AGPL is kind of making a little fix to an existing license, and it doesn't really solve the problem that well. And in fact, pretty much as soon as the AGPL, the current version of the AGPL is published, it is mostly picked up by businesses using it in a dual licensing context. So other things that happened historically, there were other licenses, they're kind of forgotten today for the most part, but other licenses were promoted by companies to address this loophole, but they were not really motivated by protecting the commons. They saw a business opportunity, right? And this was not generally seen at the time as a bad thing. I think it was only very gradually that people started. When I say there were arguments in open source, sometimes these arguments happen very slowly over time, and the perception that there was something wrong with this was not immediate. So there's lots of things you can kind of point to as sort of like opportunistic responses to this perceived loophole. So another development that's quite different from what I've been talking about, but I think is also in itself an interesting sort of infrastructure shift, and it shows you how kind of expansive this concept of infrastructure is this relationship of open source to brand identity, open source as a brand. So one of the features of open source that is kind of problematic is that it is a brand. There is brand equity in open, but it is kind of a weak brand because there isn't really a good way to protect it. So the open source initiative, in a sense, was set up to try to provide that protection, but they couldn't. They famously were not able to trademark open source itself because open source was sort of assumed to be a generic term, I guess. And so people can use, and people were using open in technology before there was open, people used the term open source. So open is just a weak term. And the thing that I think was kind of surprising in the history of open source was that open source in itself became this valuable brand. And in some ways it became more valuable than the substance it was supposed to represent. And so there was this ambiguity, and again, it was weak, so you couldn't really combat loose uses of the term open. So open becomes this gradually misused term, and it isn't really clear what to do about that. and that's a kind of new control point that created new control points, those new control points were exercised by some people. So there were, going way back in the history of open source, going back to at least the mid-2000s, but maybe earlier, people were pushing, I would say earlier actually, people were pushing the concept of open towards more and more restriction, more and more restrictiveness, kind of really stretching those normative foundations or kind of entering into conflict with them. And sort of like taking advantage of this ambiguity about what open is and making open into a kind of monetizable asset. So one of the, this caused a lot of different types of problems. One of them that is contemporary that you probably are familiar with is the phenomenon of what's called source available licenses. So source available licenses are this set of licenses that mostly have been introduced in the past 10 years, mostly used by like startups that got built up around a popular open source project. And the usual narrative is that they, after like a few years, they find that people are using the freedoms they gave them through the open source license, typically not a copyleft license, which is interesting. Because they often will pick by this point in history, a non-copyleft license because it's a faster route to popularity usually. So they pick a non-copyleft license and people exercise the permissions that the company is giving them, and they, in some cases, provide cloud services based around operating these projects, maybe better than the original company can, or maybe there's competitors who create modified versions or fork the software, and so source available licenses are designed to look like they're licenses that are intended for public source code projects, like projects hosted on public GitHub typically, but they're lacking some of they don't comply with the normative definitions of open source, usually because they don't give you they discriminate against some class of users. So basically, there are different versions of these licenses, and they try to deal with this in different ways. But they're ultimately sort of aimed at competitors, without sort of saying if you compete with us, you can't use this software. They're not honest in that sense. I will mention HashiCorp again here. HashiCorp famously, and maybe this is why apparently there's no one here from HashiCorp. There's like some open tofu people here, right? Like, so HashiCorp a few years ago. So HashiCorp was acquired by IBM like a couple of years ago. Before the acquisition, or certainly before the acquisition was announced publicly, HashiCorp, as an independent company, relicensed its major projects from the Mozilla public license, which is a weak copyleft open source license, to something called the business source license, which is a license that basically says you can use this but not in production. And then in 4 years, it turns into whatever, I guess the MPL, or maybe it's some other license. That's not the worst kind of source available license. So I do not like source available licenses. When HashiCorp did this, by the way, I did not know about, I don't know when I found out about the IBM acquisition of HashiCorp, but it was, I think when it was, I'm pretty sure it was when it was made public to the general world. But I said on social media I was very disappointed in HashiCorp because I admired HashiCorp so much as a company, and I saw a lot from afar. I saw a lot in HashiCorp that I see in Red Hat, and so that I was very disappointed in that. So I said that publicly. So I sort of stand by that. So source available licenses are designed to kind of, one reason why they're bad is that they exploit this confusion about what open means. So these licenses, or at least some of them, look like they're open source, like to the casual observer. If you're not like an expert in open source licenses, if you're not like really clued into this stuff, you might think of these licenses as open source. So you might assume these projects are open source projects. Sometimes it's because the companies will refer to these projects as open source even when they change the license to one of these more restrictive licenses. Sometimes it's not really the fault of the company directly, but there's no question that part of what gives power to these licenses and the business models enabled by these licenses is the confusion it is exploiting around the existing confusion around what open means and what open source means. So source available licenses just exacerbate some of these problems we've seen historically around asymmetry and so forth. Now, interestingly, around the same time that source available licenses become a big problem, this movement, a splinter movement in open source starts up called the ethical source movement. And it's just, I don't know, it doesn't really fit in so well in the model I'm talking about, but I think it sort of should in a sense. So the ethical source movement believes that open source, they identify as open source, developers, users, but they believe that open source licensing is flawed, and that those normative definitions of open source are flawed because open source allows you to do all sorts of bad things. The concern about like open source being used for nefarious purposes has been around for a long time, and it's true that open source in a sense is morally neutral in that it is based on all these freedoms you're getting, and the freedoms are available to everyone. That's like part of the definition. There's this anti-discrimination principle in the open source definition. You can't discriminate against users, or you can't say the GPL is available as long as you're a good person. Some of you may know the old JSON license, which was the MIT license that added the sentence, the software shall be used for good, not evil. That's like, in a certain sense, I think that was never entirely serious license, but that in a sense is the forerunner of ethical source licenses. So the ethical source movement creates these new licenses, and the licenses say stuff like, you can't use the software for any use case that violates human rights law, or things like that. So there are all sorts of problems with with the ethical source licenses. But the reason so the way it fits in with this idea of a recurring pattern, I think that I would actually say that the ethical source movement, in a sense, is its own infrastructure shift. So it's the realization among open source developers themselves that they have to do something to stop the bad things that are happening with the use of open source software. But how do you do something? You can't you're not empowered to write new laws. You're just, you're a software developer. You're not in government necessarily. So all the only tools you know how to use are licenses, because those are the existing tools, the foundational tools of the whole system. So they write new licenses, and the licenses then create, leverage points or exercising these new leverage points. So the licenses, you may support the aims of the ethical source movement, but the licenses are designed to kind of allocate power to certain people and deny power to other people. So they create new types of asymmetries. Which brings us to the present day with AI. And the thing about AI is obviously its own infrastructure shift. AI kind of repeats all of this stuff in different ways and in more intensified ways. So the main thing is there's all sorts of asymmetries around what we're calling AI now, and they're more extreme than anything we've really seen before. So there's a lot of things we could say about the relationship between AI and open source. So I'm tempted to just say AI has nothing to do with open source, which isn't quite accurate. AI in the modern sense is built on a foundation of lots of important open source projects. there are ecosystems of open source projects built up, authentic open source projects that are built up around the use of AI models. But within the world of people creating AI models themselves, the term or concept of open is used extensively, but it's used pretty meaninglessly. And then unfortunately, people using the technology then repeat this problem. So the ambiguity around open just gets worse and worse with this, in this AI era. So open source in the AI context basically just means a model is public. It's possible that it's even fair to say that open source is used even more loosely than that. So open is like pure, it's actually worse than what we have with source available. It's just a signal with no substance, behind the signal. There are other aspects of AI that you could focus on. So there are licenses used in the community of people developing models that are are an offshoot of the ethical source licenses. And some of the practitioners creating these licenses have wanted to refer to these as open source licenses. So they are contributing to the problem of, and this term is called open washing, if you haven't heard that, by the way. So this misuse of open in a sort of open source context, it's called open washing. But also, models, the big issue is that models, which might be described as open in some cases, and of course, I didn't even mention OpenAI, the name of the company, but I'm talking mostly about models that are distributed publicly. Models arguably don't meet the normative definitions of open source if you were to think of them as something akin to software, because there is no source code in the sense that the training data that is used to create the models is, as a rule, with maybe very rare exceptions, as a rule not published. Often it can't be published, but even information about the models' training data is not disclosed. So there's this kind of extreme of non-transparency in a context where the term open source is being widely used by the practitioners creating the models and even the people using the models, which is quite unfortunate. So you might say, can't we solve all this by creating a new license? And I think by now you know my answer to this is that licenses are they're not good at solving these problems. You can try to solve some of them with a license, and some people are trying to do this. So some people who are very angry about AI, so they're in open source, have proposed creating new licenses that basically say you can't use this software to train a model. Now that violates the open source definition pretty clearly, but people proposing these kinds of models think of them in some sense as being legitimate open source licenses. But it's not even clear that licenses could effectively solve these problems are so big that licenses are just very, very brittle tools. They can't do that much. They were very effective for the limited purpose they had in the 1980s and 1990s. The problems we have today with all of this changing infrastructure, as I've called it, is so complex, involving so many different types of issues and problems that you can't have a single type of tool address it. You need multiple types of tools. A license is just it's the wrong type of tool for most of these problems. Maybe for some of them it can affect some of them. So we've seen this before, but it's really, is my mic off?
Take two.
Okay, hi. Can people hear me now? Yeah. So licenses are not the solution. So I think James, when James was talking to me about doing this talk, he said I should try to be inspirational, and I'm not used to doing that. So I mostly just complain about stuff, as you probably noticed. I've mostly complained about everything that's going wrong in sort of a confused way, and so I do. trying to be somewhat inspirational. I think that the problem, I think I've identified a problem that is a real problem, that we have, the way we conceptualize open source is rooted in the past and doesn't get updated for these new problems. And it's just getting worse and worse. And you can't, and it's not just a matter of like having new versions of the same old type of thing. The concept of tools being mostly licenses and the definitions that licenses are built on isn't good enough to solve the increasingly complex problems around open source that we experience. So my thought is that the problem is that this traditional notion of freedom that open source is built on is a static concept. And what if we instead try to reframe these freedoms in a way that is more dynamic or adaptive or as I'm saying here, mobile. And so here's like an attempt, a very crude attempt to map those original 4 freedoms to a kind of reframed mobile, what I'm going to call mobile freedom. So instead of run, study, modify, share, reproduce or rebuild, verify, participate, exit, and then there's like a new concept, sort of a counterweight that is stewardship, referred to as stewardship. And these would, in a sense, address places where the original freedoms have become sort of hollow because of the kinds of problems that have occurred. So just going through these kind of quickly, the right to reproduce, I mean, this is not an original idea in any sense. It's kind of a generalization of, the work done on reproducible builds. So we actually don't, even though in a certain sense, the GPL is designed to enable users to rebuild software from source code, it doesn't do a super great job at that. I mean, it's the best mechanism we kind of have right now from a licensing standpoint, but it's not enough. Like, and for systems that are more complex than just like, source code. Source code is, being able to rebuild source code is not enough. So I think, in a sort of foundational sense, there's a need for a more robust notion of the right to rebuild or reproduce. Verification, this is a little bit, I think this makes sense, but I think it's a little bit more hazy. I think that increasingly things that are adjacent to open source or that are claimed to be related to open source involve, so they involve claims that can't be verified by users. Like an example might be someone claims to be running a service based on an open source project, but maybe they've actually modified it in some substantial way without publishing their modifications. How can you verify the claims they make about those things? You can also think of this as applying to the governance of open source projects. So projects might claim to be vendor neutral, for example, or to use certain voting techniques for making important decisions in the project. Well, how do you verify those claims made about governance? So verification becomes a type of mobile freedom that we can conceptualize now. And then I mapped the right to modify, obviously a fundamental part of the original definition of open source, with this idea of participation. So of course you need the right to modify, but you also, you need if you are dependent on a project, there's a sense in which you should have some way of participating, ideally, in the governance of the project that you share in and that you depend on. And that is modification is a local freedom. Participation is more of a collective freedom, a sort of notion of collective freedom. And I'll mention stewardship in a moment. So this is not, this is not some sort of radical proposal for open source development to become like a free-for-all with no sort of standards of contribution, but it's sort of elevating project participation to the level of the original freedoms. And then, you know, something I've thought about for a long time. So everybody, you know, talks about how the right to fork is fundamental to open source, but it turns out in practice, and this has become increasingly true over time, is you can't easily fork projects in most cases. Like, you're dependent on a project. Let's say it changes license to one of these source available licenses. If you don't have the expertise or enough resources, the freedom to fork is too costly to actually practically exercise. So, you know, another aspect of this is that I think open source should more explicitly state that it is built on the, you know, this idea of the right to compete, which is, you know, directly kind of in conflict with these source available licenses. And then this idea of stewardship. So stewardship is sort of the counterweight to these sort of reconceptualized freedoms to, you know, reproduce, verify, participate, exit. Stewardship corresponds to, you know, the work you need to do to sustain projects and communities. So obviously something that people have been concerned about for a long time. Again, it's something that ought to be elevated to the foundational level for what open source means. I think you know, these flashpoints that occur in the history of open source, especially around legal stuff that I've been kind of talking about, they're not evidence that there's something wrong with open source, really. I actually think it's actually a sign of a strength in open source. Again, I'm trying to be sort of positive about this. I think open source is a self-correcting system. It often seems to take a long time to correct the problems, to come up with solutions. But I think you know, I would embrace this idea of open source as this constantly correctable you know, system. And that's again why this notion of mobile freedoms is, I think, something that we need in some sense. So I want to kind of say that it's important to recognize that this is a human endeavor. So these so-called freedoms that I have tried to articulate, reproduce, verify, participate, exit, stewardship, they actually correspond to real human activities, and that is very important to think about when thinking about what open source ought to mean. So the right to reproduce is based on, you know, curiosity. The right to verify is based on integrity. The right to participate is related to the notion of solidarity. The right to exit corresponds to the concept of courage. And stewardship, of course, corresponds to care. So these are all human forms of these kinds of reframed definitional freedoms. And also I want to make clear that I'm not proposing that we replace the existing freedoms or the notion of what an open source license is. Those are still going to be a foundational part of open source for me. But I do think that we need to have a bigger sense and more expansive sense of what open source means definitionally, that is not just rooted in these kind of static checklist of permissions, 1990s, 1980s kinds of concepts. So I think the thing is that I would conclude with is that, you know, asymmetry is something that's inevitable in open source. It's just a feature of this phenomenon of infrastructure shifts. There's always going to be changes in the field of play, and that's going to create different power relationships and leverage points. What we can do is make sure that power doesn't get ossified, and that's what this notion of mobile freedoms is sort of aimed at. It's aimed at making sure that when concentrations of power come up in communities and around software and systems, we have some way of understanding how to think about that and how to possibly think of changes to them that can try to alleviate those power concentrations and in a sense keep openness and freedom moving so power doesn't end up getting stuck at any particular point. So we can keep asymmetry negotiable. We can't eliminate it. And I think that's a somewhat hopeful view. And that, I think, that is all I intended to talk about. Have I exceeded the...
Okay. Let's have a round of applause for Richard. Thank you. break in a moment. We're going to first give Richard some time for questions.
Yeah.
And if you have some questions, give him a shout. Raise your hand. Yeah, all the way in the back. Just please repeat the questions too.
That sounds like some, I basically heard half of that, so I didn't hear the whole thing. If,
I'm gonna run up.
yeah, maybe. It sounds like, it sounds like an interesting question.
Over here. Someone else has their hand up and we'll come up with a mic for you. Yeah, gentleman in the right.
Yeah, so there's a process going on to get a new license for AI, for LLMs. I don't know exactly who it is, but it's a large project worldwide. Maybe you can comment on that process?
So you could be talking about any one of a number of things. Are you possibly talking about the open source AI definition?
I guess so.
Yeah. So, I didn't mention the OSAID. So I am a, although my criticisms of the OSAID have been all over the place, I've been a critic of it. So the open source initiative a couple of years ago decided to embark upon this pretty ambitious project to create a new definition, a new open source definition specifically for AI. And that, yes, that would become sort of a basis in part for judging licenses, but it was also is sort of more ambitious than that. It was sort of aimed at trying. It was, you know, it was well motivated. It was aimed at trying to combat this problem of open washing that I referred to that exists in AI. The problem with it is, I mean, what I would say is the main problem with it is that it was they came up with something too complicated and too impractical, and also it didn't make anyone happy anyway because it has this big compromise built into it. So it basically tries to address this problem of non-disclosed training data, but it does so in a way that has a kind of hole in it, and there's a justification for that. But that made no one happy, and you know, anyone who has a sort of position on this sort of debate that's going on. So it just, I think it was sort of pointless, frankly, and it seems to be something that the OSI has not paid much attention to recently. So I think it is not a successful thing, and I think maybe, you know, does it fit in with what I'm talking about? I think it maybe shows that trying to come up with a definition similar to the open source definition is not the right approach to address this problem, but I'd have to think about that some more.
So just we're going to do some more questions if you want to stay around. If you do want to go on the break, we're going to be back here at 11:30 sharp for Adam's talk, which will be questions in the back here.
What's that? Oh, yeah. Yeah. You want me to get them to pay attention or something? Is that what we're doing?
I'm going to do that for you. I'm your hype man.
Right?
Everyone, stand next to me. If there's people
Yeah.
next to you, please move in. There's a space. Everyone here in this row, there's room in the middle, please move in. The third row, the sixth row, the 13th row. If you see a space towards the middle, please move in. Thank you. I've paid a whole bunch of stand-ins to make Adam's talk look more popular, and we really need to fill the seats. So otherwise they don't get paid and I don't get paid, so yeah, please, move in. Oh, one's for you?
Yeah, which one?
Whichever you like.
This one.
Check, check.
Yeah? Ooh, one whole minute left.
What?
One more minute.
Oh, yeah. I have the pleasure of introducing Mr. Adam Jacob. You might have known him as the founder of Chef back in the day. Who's used Chef before? Who still uses Chef? Okay.
That's fine. I still love you. I haven't used Chef in a long time.
So Adam's a great conference speaker, and we gave him this talk on the condition that he would give us lots of live demos. So hopefully we're going to get to see something cool today.
James is full of shit. There will be demos, but I don't know about lots.
He's the founder of a company called System Initiative, and he's going to tell you a story. So please give him a big round of applause.
Good job making it back from the break. Yeah, hi. Let's get straight into it. Yeah, we'll just go. Let's do it. I'm Adam. We're going to talk about AI native automation, and I'm just going to give you the TLDR of the whole talk up front. So instead of making you wait for the reveal, this is everything I'm going to say, and then I'm going to come back to it again at the end, and then we're going to work it all out. So look, here's the deal, and some of you in this crowd, I think, are not going to like the deal very much. But I need to just tell you that I'm telling you this out of real love. This is the room that I feel most comfortable in. You are the people that I most identify with. Like, I love the things that you love. Like, and that's why I'm here saying these things to you. Like, because I think that they're true. So AI is the future of software development. It just is. Every objection you have, and I'm sure you have some, I'm sure you have many, they will all be overcome. It doesn't matter what your objections are. The reason is that the velocity increase is too high. It's simply too, it has too much utility, right? It's too useful to imagine that anything's going to happen except that utility gets consumed. It will get used, that's it. And operational velocity follows development velocity. So anytime that there's an increase in developer productivity or developer velocity, there's an increase in operational velocity, right? And that means that we will have to get better because we are going to have to match the pace of what's happening in software development, which is getting crazy. The existing tools, let's be frank, barely enable the velocity we need now. Yeah? Raise your hand if deployment and operations is the bottleneck of getting software into the world at your company. Yeah, and there's some people that are waffling, but they know the truth, right? Like they don't want it to be true, but they know. So you have two choices. You really do. You either figure it out together. This room figures it out because we are the people who, at this point, I think, are probably the largest gathering of people dedicated to operations and automation anywhere on the planet. I don't think there's a bigger conference that actually solves for this problem. And I wish there was, because I'd go, but there isn't. We're it. We are the final bastion of people who get together and talk about these problems. And so either we figure out together how to fix this and how to move forward as a team, or we will wait for someone else to do it for us. And honestly, that's incredibly boring. Yeah? So I think what we should do is figure it out together. And so what I'm hoping you'll take away from this talk is that you should flip. to the team that says, yep, this is going to happen, and what we need to do is figure it out, and we need to do that together, and it's going to be super fucking fun. Yeah? Okay, that's the talk. You can go. If you're like, fuck this talk, now's the time. James is out. See you later. Thank you. Yay. We'll back up. I'm Adam. He introduced me. Many of you know who I am because I've been coming here this whole time and will come until they decide I can't. I think of myself mostly as a systems administrator, even though I haven't been one for a while. I was the CTO at Chef. I wrote Chef originally. I was there most of its time. Now I'm the CEO of System Initiative. I love open source in a way that is like deep and fundamental and sometimes annoying to my partners and to those around me, because I really believe in the power and impact that it has had on my life and on yours and on the life of others. And so I'm an absolute open source kind of free software true believer. And I kind of love you nerds a lot. Like you're kind of my people. And I started this company, and it's called System Initiative. I started it 6 years ago, which feels like an eternity in startup time, because it kind of is. And the goal of System Initiative was to figure out how to build a better infrastructure automation solution. And we did a bunch of really ambitious things. We tried a bunch of different angles and approaches. I think we probably built 6-ish, maybe 7 different, completely different product ideas over the course of those 6 years. Just trying to figure out like what would be better. Because I think I had been looking at this problem of like, you know, we do all this work and then we have to go operate it, and then when you talk to people who actually do the work, they're like, yes, it's working, but it's misery, you know? And I was like, we got to figure out how we can make this thing sort of be less miserable. And I'm proud of the ambitious things that we tried. I'm proud of the work that we did. I'm proud of the team. But ultimately, we failed to build something that was good enough, as evidenced by the fact that raise your hand if you loved System Initiative, like used it and loved it. The only people who are doing it are people who work for me. And so, look, I failed those people who worked for me. I failed all of them. I had to, last week, I had to let a lot of them go, and I love them. So many of them had worked for us for 6 years or more, and it was the right thing to do because the product just simply failed to find any fit. You didn't love it. And I kind of failed you because when I started it, I was like, I want to serve these people. Like, I want to figure out how to build something that makes these people's lives better. And I just resoundingly did not. And so last week, we faced up to that, you know? Like, we had to do the right thing and go through that. And then this week, a small team of people decided to try again. And so that's what we did. This week, we're going to do it again. So a question you should be asking is, why try again? Because there's easier things to do in your life. I build startups for a living. I'm good at it. I can raise money. I like raising money. I like building teams. I like all of those pieces. I could just go do anything at this point that I want to do. But the truth is, there's a couple of reasons, really 3. One, the last 6 months in AI happened. And so if you're not a person who's been really paying attention to this, you might not notice that something changed, or it might have just always felt like the same cycle of hype, you know? And so you've just tuned it out because you're like, it doesn't really matter. Here's the truth. Across the industry, kind of all at once, in the last 6 months, we all figured out how to use AI to be incredibly effective at writing software. I mean, crazy person talk. And it happened in small pockets, inside large organizations, inside small ones, and those people started talking to each other. And some of them were talking into the internet. They were like, this is incredible, and we are going to take over the world. And you mostly ignored those people, right? Because you've been sick of their prattle, right? For the last year and a half, right? Which, peace. You know? I get it. And it happened. And they started talking to each other about what they're doing. Turns out they were kind of doing the same things. And at System Initiative, what changed for those people, sorry, before I get into System Initiative, what changed for them was that they figured out how to use this as technology. Not as hype, not as dreams, not as, Terminator robots, but as actual things, just like you use Postgres or write a shell script. And they figured out how to use those things to actually solve their problems. Yeah? And that wasn't true before. That's why you were skeptics, right? It's okay to be a skeptic. You should have been. I was too. I'm going to get to this again later. But, that happened. Now, At System Initiative, we saw a glimpse of that future. I would say maybe 100 days ago, 180 days ago, we took some prototypes that one of our customers built of using MCP to talk to System Initiative that sort of like showed a glimmer of being awesome. And we were like, you know what would be awesome is if somebody who actually knew what they were doing maybe built one of these. And so we did. And it turned out it was ridiculous. It did crazy things. We did things like, we had people show up cold, have production issues, say, hey, we're having this production outage. Here's the description. Go discover any infrastructure you need in AWS and troubleshoot this bug. It found 2,000 pieces of infrastructure, modeled those things, analyzed them, and found the bug in concert with the source code in one shot. That's insane. That's crazy, right? We saw it do things like translate architecture between AWS and Azure. We said, we have an app running in AWS. Here's the source code. Now translate that to run in Azure, and it did. And it did. Again, crazy talk. How long would it take you to do it, right? Just ask yourself, how long will it take you to look at your app running in AWS and move it to Azure? I'm not saying it's like an impossible task or whatever, but this happened in like 20 minutes, right? Less, right? Crazy. And one of the things that happened for me is I never want to build infrastructure in any other way ever again. For the rest of my life, I'm going to build infrastructure most likely by working with an agent to do it. Because I don't remember most of those things. I don't remember how to put together all the things that I need to put together to run something well in AWS. But the agent does, and that loop was just better. And we saw that loop, and once you see it, you can't unsee it. And then finally, I'm just not done, and neither are the people that I work with. Like, we love this problem, right? We love this space. We love you. We love this work. And so we just weren't done doing it. So what changed with AI in the last 6 months? Why was there this moment that we crossed that can never come back from? One, the models got better. So the frontier models have been improving. They've been improving quickly. But how many of you used like AI to write some code and it was shit? Yeah, the whole room. Exactly, me too. And so, but it turned out that as those models improved, not all of them, but most of them, in the last 6 months, all got good enough. They crossed some threshold where suddenly, with the right set of prompting and the right set of behavior, the code they're producing is actually pretty high quality. And it actually seems to work. The second thing that happened was Claude Code. And why this is important isn't actually because Claude Code is so much better than any other possible thing that could write code. It's actually because it's not an editor. Because historically, what we've been thinking is, I'm going to use this AI to augment my ability as a software developer to write code. But I'm responsible for the code. I'm going to be reading it and understanding it. I'm the one who curates all these lovingly built functions and words and stuff on the screen, right? And Claude makes that very hard to do. If you've ever used Claude Code, it's just a terminal window, and it's like, I'm writing code, you know? And at first, you're like, well, I better go read all the pieces, and it's kind of slow. But once it works for a while, you stop doing it. You just do. You're just like, yeah, man, let it rip. You know? Let's do it. Let's go. And it happens to everyone who tries it. It's the same thing that happens when you sit in a Waymo. How many people have gotten in a Waymo in San Francisco? Maybe not very many because you're in Europe. It's bananas. The car drives itself. When you first get in the car, you're like, this can't be safe. And then the car pulls out, and it takes 10 seconds, my friends, 10 seconds for you to be like, this is normal. It's fine. And you just trust that car, it's cool. Because it's just a fucking car. Yeah? And it's fine. And that's what happens when you use Claude Code. And then finally, it is just technology. We figured it out. It's not crazy. LLMs are just LLMs. And they do what the thing that they do. It's not magic. It's just boring. It's just technology. It's fine. It's Postgres. It's Bash. It's Perl. It's Ruby. It's whatever you like. It's fine. It's fine. It's fine. It's just technology. Relax. And we all relaxed. The whole industry filled with technologists, not everyone, obviously, because some of you still hate this talk. But most of us who were like talking to each other in the background were like, yeah, I get it now. It's fine, right? It's fine. Here's an example of what really changed the most, and the answer is velocity. It took 6 years for us to build roughly 6 or 7 versions of System Initiative, right? In the last 180 days, we built a version that actually almost worked, but was stuck with all this weird baggage from all the previous iterations of System Initiative that you hated.
right? You were like, no, I don't want to give up source control, you know? No, I actually don't care about visualization, you know? Like, it was still had all this baggage from those decisions. But in the last 3 days, we built the bare bones of a new product that does the vast majority of what System Initiative did, essentially single-threaded together. And it has terminal UI, it has its own agent that works on it, it has a web UI. We did in days what would have easily taken us months to do by hand. Easily. And I know because I've been building it over and over and over again by hand. It's wild. And the quality is quite high. So who cares if I spent the last 6 years getting the product wrong? Now I can get a new product, get it wrong in days. I have so many more shots on goal. I have multiple people in my life who I love and respect, who I know as actual people with their faces, who have had conversations that are something along this line, which is, I am sitting alone and I am generating 50,000 lines of working code a day. 50,000 lines. Now, a reasonable reaction to that is, why? But the truth is, it doesn't matter, because if it works and solves the problem, it's phenomenal. And that is the truth. That every single person in this room right now has all the skills required to generate 50,000 lines of code a day. That is wild. That means that there's literally nothing in the world that you have ever seen technologically that you couldn't reproduce if you just had the money to burn on tokens. That is fucked up. But it happened. It's true. The impact of this on velocity with software developers is roughly the impact between the size of that text and that text. So if you think about the impact of DevOps and cloud on our collective velocity and the seismic impact it had on operations. How many of you are old enough to have done operations work before the cloud? Oh, I love this room. It was a big freaking deal, right? Like we did good work, right? We changed literally the planet. Every organization on the world became a software company because we figured out the operational side of that work. That was incredible. And it is nothing compared to the acceleration that just happened. It is nothing. I am underselling it. Do you get it? I'm underselling it. It's crazy. Look, when software development accelerates, operations always follows. It must. The code has to go somewhere in physical reality. It has to do something on computers. It still needs those things. It still needs networks. It still needs all that stuff to happen. That's what we do. But the way we have done it historically, we're the bottleneck now, right? What stops your company from going faster? It wasn't that it couldn't hire software developers. We've been cranking software developers out because it's an incredibly high-paid job for a long time, right? The reason that companies stop buying software developers is because they can't deploy it fast enough, because the operational burden is too high, because the loop of troubleshooting is too big, because they can't react to failures and errors fast enough, because they can't do security review. They're going to solve all those problems. And what are we going to do? We're going to fucking use Terraform. That's our big plan, right? Come on, we have to change, and we have to change radically, because it's obvious. We're the bottleneck now. It doesn't work fast enough now. There's no way it survives that kind of change. So the time for you to be a skeptic has passed. It's okay if you walked in this room a skeptic. I was a skeptic. My wife is a delight, and she has a lot of people that she works with who do like social justice work, and they got very hyped about AI immediately. And they went off on wild tangents telling me about all the crazy things they were going to do. And I was like, no, you're not, you know? And they stopped talking to me about it because I was such a skeptical dick, you know? They would literally stop talking to me. They were like, we're not hanging out with Adam anymore because we don't want to hear him poo-poo our dreams, you know? Because the hype was insufferable. It was awful. And real harm is happening to real people that we know and respect, right? It's awful that those things are happening. It is. But it already happened. And nothing is going to stop that change now. Somebody asked a question earlier about like, what happens when the bubble bursts? Won't that just wipe it all away? No, it won't, because that velocity increase has already happened. You think the bubble bursts and what happens is we take the most productive people and they lose their jobs? Be real. Be real. It's not. It's not. What happens is we lose ours because we didn't figure it out and they did. The utility's too high. It's not going to collapse. Like, I'm not saying that bad things won't happen. I'm not saying it's not seismic. It is seismic. I'm underselling it. That's how seismic it is. But we have to figure it out. We either adapt or we get left behind. Those of you who know me well enough know that I like heavy metal. This is Randy Bly. He is the lead singer of a band called Lamb of God. What's up? And Randy's been in this band, very heavy band. They make, really awesome heavy metal music. You should go listen to Lamb of God. But they've been writing songs together for 30 years. And I don't know if you've ever had friends who you do something with for 30 years, but you kind of start to hate each other. Like you spend 30 years picking on each other, and like farting in a bus or whatever, and you just don't want to hang out with people anymore. And so when they write songs, they have a problem, which is that if you write the song first, and then somebody comes and changes the song, what you want to be is like, no, that's not how my song goes, right? You want to be like, I'm over here playing, I'm killing it. And then somebody else comes in, and they change the note, and you're like, ugh, I don't want that. And you have to resist that need because they have a saying, and the saying is, good is good. Sometimes things happen that are just good. They're just better than the thing you wanted to have happen. What I wanted to have happen was everything stayed the same. I love being a software developer. I love writing all that code by hand. I love all of it. Doesn't matter. Doesn't matter because good is good. Turns out it doesn't matter the song changed and you don't like it. It's still changed, right? And all we have to do is adapt. We have to get better. Okay, doesn't matter how you feel about it. Good is good. Let's talk about how this is working in software development. So roughly, you wind up with a process, if you're going to accelerate to this level, that works something like this. You have this idea of software architecture. How many people think of themselves as a software architect? A few of you, which is great. How many of you have made fun of software architects? Yeah, way more of you, right? Me too. Turns out the thing that they're great at is the thing you have to become great at in order to use LLMs to write software at this velocity. Because you know what they're good at? Really specific vocabulary that has really specific examples of its behavior. Have you ever been in a code base that was written by hand using design principles like domain-driven design? You ever had to write code that was always supple to requirements and decoupled across all of its things? How many people have had to do that? Did you like it? Put your hand down. No one did. It's insufferable. It's insufferable. Even though you know it's good for you, it's like wading through a sea of nothing but broccoli. But you know what's good at doing that? LLMs. They don't care that it's insufferably hard to write great architecture and clean code. They'll do it all day, because they can write 50,000 lines of code a day. The only problem is you don't know how to do it because you decided it was boring and stupid and slow. Yeah? But now it turns out it's exactly what you need. It's exactly the thing you need. So you have to have an idea of what the architecture is and a vocabulary to express it. If you don't have one, if you're thinking, what will mine be? A good answer would be domain-driven design, because that is a very good, and it thinks about vocabulary in a very specific way. But it doesn't matter what you choose. You also have standards. You have ways that you work in order to write software for your domain. So you take those things, go into a process that probably looks roughly like this. You design things, you plan them, then you implement them, then you test them, then you review them. This is probably your process today, yeah? Raise your hand if it looks something like this. You're like, yeah, we maybe don't do as much planning. Don't do a lot of design. But like, it's roughly right, The things in green are what's left for you. Your job is design and planning. That's it. That's it. You don't implement, you don't test, and you don't review. Because the speed at which those things happen has exceeded your tiny brain's ability to grasp what the hell is going on. You can't do it. You can't do it. You simply can't keep up. But you can keep up with design. You can keep up with, yes, I think that is a smart change to the software architecture. Yes, I think that is a reasonable way to think about implementing this problem. Magic machine. And then it's going to go and do all of those things, right? You have questions. I have no doubt. you're going to start with, are you reading the code? The answer is, not really. Not really. I can't. It's going too fast. With 30,000 lines of code a day, 50,000 lines of code a day. You're not reading that shit. No way. No way. What you are reading is architecture. You're reading documentation. You're writing standards. You're reading the code for guidance, and you're spot checking to make sure the architecture doesn't go astray. I'll use an example of this prototype we were building. John Watson, who's a delight, he's right here, he built an implementation of secret storage that he cleverly called vaults. And the way that, that he implemented vaults, John's never done domain-driven design. And so he told it how to build vaults, but then it went and wrote code according to what John told it to do, which violated the architecture principles of the software. And I could see it in the outputs, because I am a pretty good software architect. And I was like, there's no way that PR is designed correctly. I only saw it after the code landed. He had a working version of vaults, but I looked at it and was like, no, that can't be right. That smells bad. Turns out it was. And then we fixed it, and it's fine. We just moved on, right? That's incredible. I didn't actually review the code to do that. I just looked at the outputs and was like, there's no way that's the right shape. And then we fixed it to be the right shape, and then I spot checked it, right? You're really just looking to catch derailment, which happens way less often than you think it does if you follow a reasonable pattern of working with these tools. 2, human review just simply doesn't work, right? The velocity is too high. I've harped on it, but could you review 10 2,000-line pull requests a day? Because Paul Stack sent 5 of them yesterday. 5. So you can't. What's going to happen is you're going to take all that intelligence you build into the software about how it's designed, about what its software architecture is supposed to be, about the standards that you have, and you're going to let those bots rip. You're going to just make it so every PR that they send, they read again and go, does this match our design standards? And it's going to do such a good job. I mean, a face-meltingly thorough job. You don't do that shit. I know, because I've seen your source code, right? You whiff at architecture. These things, they hold to that shit way better than you do, right? It does a way better job than you do. So you're just going to trust it. You're going to be like, you know what? I worked with this thing. We made a good plan. Seems to work. I validated it. Test pass. Let the robot review it. If it doesn't, then we fix it. Otherwise, merge it. Just move on with your day. Security. That's what you're thinking. You're like, that's the last place. It's like we've climbed I'm telling you to jump off a cliff, and you're like, but I won't, because security and supply chain safety, right? That's what you're thinking. You're like, I'll never let that slop into my life, right? Okay, sure, man, fine. 2 things. 1, probably, and this was a thing we realized yesterday, so I reserve the right to be wrong. The answer is you don't accept pull requests anymore. You don't, because you know what you don't need? Anyone's source code. You can generate source code at 50,000 lines a day. You know what I need you to do? I need you to write a design document in my issues. I need you to say, this is how this thing should work, Adam. And then I'm going to read it, and we're going to talk about it. And then I, because I trust my agent, I'm going to let that thing rip. I don't need your pull request. I need your brain. I need your ideas. I need your collaboration. The same thing happens in security. You know where the secure parts of the software are. Not all your software needs to be highly secured, right? No, it's the boundaries. Like it's AAA, it's encryption, right? So yeah, that vault implementation we read, because I think it should encrypt your secrets and not leak them. Yeah, because I'm not a dum-dum. I didn't just tell the LLM, because that's insane. But once you stop doing that, it happily does the right thing. This is a smaller surface area than you think it is for most of your programs. Okay, now you're like, slop. That'll save me, Adam. I don't have to do this because slop, that's going to kill us all. No, it won't. Back to strong architecture and thorough planning. I do have a spelling error I didn't fix, though. Paul caught it yesterday. I should have used an LLM to review my work. But I hate the way they sound. Okay, look, you're going to give it strong architecture guidance. It's going to follow your planning, right? It's going to catch the obvious flaws in the design phase. You'll be shocked at how many bugs you catch just by reading its plans. Just by asking it to make a plan and then reviewing the plan and being like, that's a dumb plan. And then it fixes the plan and then it does the thing you're supposed to do. It's not hard, right? Now, most of you, when you wrote this stuff, the idea of a plan mode didn't exist. Most of you who've fired up Claude Code, you never bothered to hit Shift-Tab and turn that into plan mode, did you? Didn't even know it existed, because it didn't until like 4 months ago, right? But now it does, and you should be using it because it catches these sorts of problems. Okay, let's talk about quality, because this is actually probably the last place we are clinging to the cliff, right? You're like, it couldn't possibly work good enough like my artisanally crafted, we worked hard at this. We got good, Okay, 2 kinds of quality. And I don't know if I'm the person who invented this frame. It doesn't really matter. But one is external quality. Think about it as, does it work? Is it secure? Do people like it, right? This is how it's perceived by your users. This has always been the actual measure of whether or not your software was good or bad. You didn't like System Initiative because it had poor external quality. It did. Even though it was kind of rad and like had many things in it that were really cool, the ultimate arbiter of its success was you. And you said no. Yeah? So no matter how clever it was on the inside, and it was so clever, it was so good, you didn't care. And that means it didn't matter. It was wasted time, right? It's the only thing that ever mattered, and it's unchanged in an era of AI. It's unchanged. If you ship things that suck, they still fucking suck. That's it. And that's why you kind of hate AI right now, because people are shipping a lot of stuff that sucks. And you're like, oh, I don't like this thing that sucks. And you're like, yeah, right. Stop sucking. Yeah? Do better. Your taste, your expertise, still required. Okay, but what we obsess about is not usually external quality. We obsess about internal quality. These are the things that teams need in order to produce high-quality things externally, right? If we don't do these things as teams of people, we decohere in our ability to build things that are good, right? And so some people talk about this as the craft of software development, right? It turns out some of this still matters, but mostly it's just software architecture patterns, because it turns out these are the key ingredient to making AI-generated systems stay coherent in the face of requirements. And if you've ever experienced people who just built really complex things with AI and then they started to fall apart, this is why. Because there was no software architecture. Because AI just does what you tell it to do. And so if you just told it to rip some slop, it rips some slop. Yeah? But if you tell it to write clean, well-architected code and you have a thesis about how that works and you use that vocabulary, it does what you say. Now, what we spend a lot of our time doing is not software architecture, as evidenced by most of you not raising your hand, except to say you made fun of software architects. Yeah? Instead, you think a lot about principles, right? How many people here know what dry is? How many of you believe it's important? Most of you, if you're being honest. Well, it doesn't matter now. Cheers. It doesn't matter because you never read it. What do you fucking care if it wrote 5 versions of opening a file? You don't care. You don't care. It doesn't matter. It did matter. It used to, but it doesn't anymore. Kiss probably doesn't matter because what's simple anyway between friends, Let's talk about D.AUD. You ain't gonna need it. This is a principle that I think might survive because at the rate you can write 50,000 lines of code, it's very tempting to just rip through everything you think could ever possibly be good. And that, we know, is bad, right? Now, most of what you argue about on your teams, though, is taste. This is actually the reason you hate AI, because it has bad taste. You have an opinion about what good is like. I love heavy metal. You hate heavy metal. That's taste, yeah? It's okay. But things like how the code is organized, or the style, or naming conventions, they don't matter. They don't matter. They never matter. But now they really don't, because you're never reading the code. So you gotta relax. Every time you're arguing about taste, every time you're arguing about some arbitrary principle that's how you collaborated with other people as a person, all of it's dead. Doesn't matter anymore. Except as they apply to creating external quality and defining the architecture to ensure the agents don't go nuts. Talking to agents about architecture leads to stable systems, the same way that architecture led to stable systems in the large with human beings. You might have hated software architects, but you love software that has good software architecture. You love it. You just don't like writing it because it sucks. Now, what we've been doing is vibes, right? We've just been popping up an agent. Michael, I think, had a prompt That was a terrible prompt, right? He was just like, I want to do some things, do it. And then he was like, and I suffered for 10 hours. And it's like, yeah, surprise, right? Of course you did. You gave it nothing to work with. That it worked at all is a miracle, given how terrible that prompt was, right? But of course it has brought chaos, right? Of course what it brings you is chaos. This is why non-engineers struggle, and why all of us should not anymore. But if you can't express architecture, that's the #1 thing you need to learn to do. If you don't know how to talk in terms of software architecture and design, now is your moment to go buy Eric Evans's book, which is kind of impenetrable. It's a tough read, Domain-Driven Design. You could pick up Implementing Domain-Driven Design. That one's easier to read. But look, I don't care. Pick a different architecture. Ask Keith. Keith probably knows a million things. Wave your hand, Keith. This is Keith. I don't know many things. Keith will help you. Okay, look. I just invited everyone, talk to Keith at the Zone about software architecture. Look, what's happening here is a Cambrian explosion of software. It is crazy how fast the software is going to change. There is literally nothing that you couldn't build if you had access to the capital to create enough tokens to drive it. I mean anything. Every single thing you thought was a moat, the only moat that's left is that people use it. The agents use it. That's all that's left. It doesn't matter. There's no technical moat, none. You're gonna be like, well, it couldn't rebuild Nix. And I'm like, motherfucker, it built a better Nix in a week. In a week. If you knew what to do, if you knew how to say it, if you knew how it should work, it would wipe away all of your sins. That's crazy. It's crazy. It's wild, and it's getting wilder. Okay, what's it mean for automation? I'm going too slow. Look, first it means you have to build for agents first. The primary consumer of automation now is agents, right? People need transparency into the agent and into the outcomes. If you can't see what the agent is doing and you can't correct those steps, the agent can't see them either, right? This is why it needs to be open source. AI native automation, speed is the most important piece of it. There's 5 things it needs. 1, transparency. You gotta be able to introspect every point of the process. 2, it has to be extensible because the agent will unblock whatever it needs with code. The way we built automation in the past was like somebody else built the Terraform provider for AWS, right? In the future, you can just say, build me some automation that does shmoo. And then it will, if the framework is good and the validation is strong, right? You just have to be able to do it right in line. You're no longer blocked because you can generate 50,000 lines of code a day. Has to be one-to-one to the domain. The LLMs are trained on real-world data in the world. So every time you are tempted to build an abstraction to make it easier for your tiny little human brain, what you're doing is making it harder for the agent to do the right thing, right? One-to-one models. Use the training data. Validation. Each step has to have policy embedded because what we do is operations. We impact the real world. When we make changes, we don't just call a pure function with no side effects. Everything we do is nothing but side effects, and they usually cost money and cause problems for people in the real world. Yeah? So we need ubiquitous validation at every stage of this process. We need to be able to say, here's what correct looks like contextually for me, and apply that to that automation process in line, and we gotta be able to write them immediately. This is true at every stage of the process. So if you think about the way you do validation now, you do it wrong. You care about the full life cycle. You have to have visibility across everything. Right now you have automation split across CI and CD through the code base, right? Through all kinds of stuff. Here you gotta have all of that stuff. It has to cover all of it. Troubleshooting, debugging. It needs access to all of that data. This is why infrastructure as code is in trouble, right? It does none of those things well. Right? It's not transparent, it's not extensible, it's too abstract, it has terrible validation, only covers part of the life cycle, and it's too damn slow. One way you know this is true is here are the things you talk about when you talk about infrastructure as code. You talk about principles and taste. You're like, how am I gonna factor my Terraform modules? Is it a Teralith or not? Oh, you didn't dry up that, you should have used a loop. So, not a loop, I'm sorry, it's declarative. We're not allowed to do loops. Loops are too hard, right? Anyway, obviously wrong, right? So what might this look like? What might this future look like? So 3 days ago, we started taking these ideas and saying, let's take what we learned from System Initiative and what we loved, and let's go build a new thing that tries to embrace these things. And I have a rule that you have to have code names for things that are like this. So the code name is Swamp, but its name is not going to be Swamp, okay? And it's not quite ready for us to like open a repo, you know, and be like, let's go. But it has all these principles in it already, so I just want to sort of go into it. So one is here. Let's see if I can do this. Maybe we'll skip to Keeb, because we only have a couple minutes left, right? Are we at time? Okay, let's actually switch. So what I'm going to do is introduce my friend. This is Keeb. Keeb's going to come up, and he's just going to give you a demo of Swamp. You can find us later, and I'll show you like how we develop Swamp, and how that flow actually works, and the plan loop, and issues. I got so many things to say. But Keeb is going to show you Swamp. Do you want me to just plug you in?
No, you keep it there.
Oh, too late.
You can both?
No, I got this one, it's fine.
But
Hey.
you gotta use this one.
Yeah.
Here we go.
I got you.
Okay.
I'm like your AV guy.
You get a terminal ready for me?
Yeah, I'm going to do it.
Yeah. All right, does anyone in here have a home lab by any chance? Okay. And who's heard of Proxmox? Okay, yeah, the room, right? So maybe like you, I have some friends, they ask things from me like Minecraft servers to run on this home lab. And so I build it for them. And they run on a Proxmox server. And every other week I get a request for something new, maybe to make some changes, install new mod packs, start a new server, whatever.
I'm going to hold the mic so you can type.
Okay. Yeah, so what do? I do what you probably do at your job. I get a request. I have some idea how to service the request, and then I get to work. Sometimes I get distracted. And so this project Adam just talked about, Swamp, sounds interesting. But I like to put things to the test, you know? At the heart of things, the reason why I have a home lab is because I love to fuck around with technology. I like to take interesting ideas that I hear at conference talks, and I like to put them to use. So, you know, can Swamp actually build automation to help me manage this problem that I have with my friends? Can it actually discover what I have running and maybe make some suggestions about what I might want to do? You know, to set the table, Swamp is 3 days old, doesn't know anything about my environment, doesn't know anything about Proxmox. It doesn't know anything about the concept of discovery, which is to take resources that are actually running, import them into my infrastructure or my automation, and then do something or build workflows on top of it. And so yeah, here's how it went. So I'm gonna actually SSH into this home lab by first jumping through to the public internet, to my home. Okay, here I am. And yeah, so here's where we started, okay? Empty repo. Swamp has no Proxmox support. I said, hey, I have Proxmox running over here. Build what you need in order for me to be able to interact with it, okay? So it looked at the Swamp source code. It looked at existing models, and what it did is it built an extension model to Swamp itself, okay? This is like building a Terraform module for you or provider for you to be able to start automating some infrastructure. And it hit limitations. So what did it do? It modified Swamp itself and adapted, okay? And then I did things like, okay, now that you can authenticate and look at the state of my Proxmox cluster, maybe what I want to do is look at some VMs. Maybe what I want to do is maybe start one, okay? And so, yeah, the agent didn't pre-build anything. It extended Swamp. It extended the model as it needed, built authentication, built the ability to get things like VMs, and then we just vibed, okay? So this is what it looked like, okay? So I had the user request to describe some infrastructure. It started with an empty thing. We started with a plan. We created the extension model, you know, built the code for me. We built the vaults and the credential stuff. We hit some limitations. It adapted. Then we did a full infrastructure scan, ran the scan, extended it as needed, and you know, here's the summary of what it built. Okay, so then next. Now, here I have Claude code, and now I can ask questions about my infrastructure. So analyze my Proxmox infrastructure, and maybe give me some suggestions about things I might change.
How long did it take you to do this, Keeb?
About 10 minutes.
10 minutes. How long would it take you to write a Proxmox provider for Terraform? The room laughed. I just want that to be just for the record.
Yeah, 10 minutes. Like I did this last night, you know, after being severely jet lagged, waking up at 2 a.m. I was like, this is a problem that might be interesting. So let me see if I can put it to the test, okay? And here's what's going to happen. It uses that entire workflow that it built in 10 minutes, and it's going to analyze all of the VMs that I have running, and then make a suggestion about maybe some things that I might need to change. Okay, so here we go. Right? It's got the name, it's got the CPU that I'm running, so that 14% load. I'm using 50% of my RAM. It's been up for 20 days. Here's the storage. This is true. I have a SAM amount for my ISOs. Here's the 3 servers that I'm running. Any Terraria players out there played Calamity? Super fun. Or modded Minecraft. Anyway, yeah, and then maybe there's some ideas here. Like, hey, you're kind of overcommitting. VM 102. What the hell is going on there? These are things that I might be able to optimize for myself. Okay, so now all this is read-only, right? Wouldn't it be really interesting if I could start to service my friends' requests and maybe, I don't know, create some VMs and operate them? And so here's the plan about how Swamp will extend itself in order to add VM create, start, stop, delete, basic CRUD stuff into the model. So what is it going to do? It's going to extend the input schema. Then it's going to add a task polling thing. So because the way that Proxmox works is you say, hey, start this thing, and it gives you a PID back and polls until it's done. It's going to implement create VM, right? Start VM, stop VM, delete VM. And there you go. So now I hit enter. I've reviewed this plan beforehand. And in about 5 minutes, I'm going to have full automation of Proxmox to create, delete, update, start, stop VMs. There you go.
There you go.
That's it.
All right, I'm going to steal this back.
Send me your order again by email, and then you get a button at the bottom to modify, and then you can modify your workshop that you want. We also have a women's lunch, but Carol will be talking more about that.
Hi everyone, if you signed up for women's lunch, or even if you didn't, but would like to join, I have vouchers for that, and we have signs in the cafeteria with config management camp on 3 tables that is reserved for us. So come look for me. There are also some vouchers at 3 or 4 of the booths, but yeah, just come for me, and also stationed there at those tables before lunchtime. You can get a voucher. Go ahead and get it on. Thanks.
So we have Ignite coming up. The first thing I need to fix is make sure that this machine doesn't end up without power, because otherwise it's not going to be fun.
Oké. Moet je die wel gebruiken met de gasten?
Couldn't see Adam's talk. Why not? Iets met een klant en
Because you have to sit in front here. No, no, here. Yeah, whatever. Who's giving an ignite? I'm looking for... No. Sure. Yeah.
Buytaert? Buytaert?
Who's never seen an ignite before? Francis. Francis, stop explaining. Yes, you. That's how we get a room quiet. Actually, talk to everybody's good Toshaan.
We have the ignites now. Ignites are the fun factor form of the conference. So, a bunch of speakers who are crazy enough to send me 20 slides. They're going to get 5 minutes. They're going to be auto-forwarding. If you don't agree with what they're saying, it's only 5 minutes. Where's James? James ran away. Oh, James is hiding in the back. I think we have more Ignite speakers that should be queuing up right there. I think we have more than 4 today. If they don't show up, too bad for them. But let's get this going, because actually I'm so stupid to doing Ignite myself today. And I just want to talk today about just enough container orchestration.
Are you the first one?
Second,
you're first one? Yeah, you have to use this one.
Then we need to fix this thing. So for those who don't know, my name is Kris. I've started this conference together with
Yeah, and if you are ready, can you pass it to the next one?
Sure. I have crazy ideas. Sure. People always stress at me when their DNS is broken. I'm sorry. DNS, for those who still don't know, is DevOps needs sushi. And that's basically shapers create a problem. So what is the thing? Containers are here to stay. If you think containers are going to go away like AI is going to go away, no. Problem is, how do we deploy them? We've come to a point where people don't package software anymore. People just ship a Docker Compose file. Well, no, we even stopped doing that. No one has gone proprietary, so we're screwed there. We don't have a solution there. So Kubernetes is the only option we have. Like, Kubernetes is awesome if you have the right use case for it, but it's for a lot of organizations way too complex to manage. If you deal with the average enterprise, they have no clue what they're doing. And you know what? Not everybody needs to be doing distributed computing. Do they even teach that class here? I don't think they even teach it. I spoke to a bunch of people in different universities, and they have distributed computing as the last year master's class. Yet we want to have everybody play with it. So what do we really need? What do we really need is something that's lightweight, something that can do simple container deployments, that doesn't do complex networking, storage, and all those things. Basically, you want to take a Helm chart and throw it at something, and it should work. And that's all you need for a lot of systems. You don't want that complexity. So that's kind of the thing I told James, like, 8, 9 years ago, like, you have MGMT, what about you just build this? And then MGMT is going, it's event-driven, it's idempotent, it's distributed, but it's simple, and it works. So, where is the code? Why didn't we build it yet? Hey, MGMT is awesome. Who's using MGMT?
And some other people that are not here.
Someone else, James. We all know James. He's a great guy. Puts up pictures of Toshaan and me in every single slide, so it was time for a little payback. This is James, and James is stubborn. So what did I do? I asked Claude. And Claude actually built this thing for me in like half an hour. And it works. So, just stuff container orchestration is a really small thing that mimics everything that I needed from a Kubernetes API. And I just deploy a deployment, a service, whatever, and I throw it at that daemon. And this is what it does. It launches and creates a bunch of MCL files. Those MCL files, they spin up a container. They expose the network stuff. And they do the little things that I want. This is actually an example in the test scenario where you just spin up a small little thing. I didn't do anything to get this working. Just ask Claude, build me this. And it generates MCL. Now the problem with generating MCL is there's not a lot of examples out there. So yeah, I now have a really small system that can deploy a couple of containers and it works. Is this something I want to keep on building? No. But I think a bunch of people who have more time on their hands can actually contribute and spin up things with this and go forward from this. And actually I know there's people in the audience that already are talking about building similar things. So what is not something that I'm on maintaining, but this is something that actually I hope triggers James to start building useful stuff with Mgmt. And now you can say something, James, if you really want to.
So it's true. We're actually going to show a pure MCL container orchestrator tomorrow in the Mgmt talk that Andrew Clay is going to be demoing. And today at 4 p.m. I'm going to show some even fancier stuff of real world magic, role deployments, etc. So thank you, Kris.
What's your name?
Okay. Is it good? Okay. Yeah, perfect. Welcome everyone. So, who uses Kubernetes on production here? Half, maybe more than half. And GitOps? Almost the same. So, my name is Koray. I work for a company called Kubernetes, and I do consultancy stuff mostly. I do also some community stuff. I'm CNCF and platform engineering ambassador. I also do DevOps and KCD Istanbul things. So this is something that you most probably at least once had in your life with a deployment or something on your CI/CD pipeline. But I mean, hopefully GitOps suggests a fix to that, and with this promise being declarative, versioned and immutable, pulled automatically, and continuous reconciliation, things are should be better. But yeah, I'll talk about some prides here. The first one is I'll talk about some sins, and the first one is pride, and it's about thinking that we know better than the system. So if you believe that your Git repo always reflects the production, that might be wrong, because there could be some some people might be doing some ad hoc changes. but then you should always monitor and for drift and get action on it. The second one is envy, just blindly copying other GitOps setups. Some organization might have a very beautiful setup for themselves, but you should always think about your organization, your needs. You should not copy everything and try it, but instead start simple with your own setup and then adopt new changes. The third one is sloth, or ignoring the reconciliation errors. So observability monitoring, this is not optional, you have to have it. And you should not ignore any reconciliation errors. You should act on it, fix them as soon as possible. Otherwise, things will be piled up and probably will there will be a bigger problems in the future. So alerting, observability, you have to have all the time. Wrath, or blaming GitOps for non-GitOps problems. So we are all resistant to change, especially if you are now going cloud native or implementing GitOps, Kubernetes. It's mostly easy to blame GitOps or the new tools, but the important part is that everyone in the company or who uses those systems should know how it works, understand how it works, and act on it. Last, or obsessive feature chasing, I think this is a problem for all of us, for all type of things. It's good to follow the recent changes, recent tools, but you also be careful about what to do or what to implement on your organization. If you don't need it, then maybe just try it out, but don't go to production right away because, yeah, it will create some other problems. Other sin is gluttony, or one repo to rule them all. So for your GitOps, especially for GitOps at scale, you might have issues having all the application code and the configuration into one repo. Argo CD also has some documentation for it regarding the monorepo. So try to have multi-repo strategy, make systems away from each other. And the last one is greed, or hoarding knowledge. Well, the whole DevOps thing is about, I believe, sharing the knowledge, understanding what's happening where or on which step. So documentation, knowledge sharing sessions, guilds in a organization, meetups, those are all important, and you have to make sure that everyone in the organization understands what's happening. So key takeaways, GitOps is not a discipline. It's a discipline, not a tool choice. You can use whatever you want. You should always watch for drift. Observability is not optional. Simplicity is more important than complexity. And you should not ignore the reconciliation errors. Thank you very much. I had this talk with my friend Jansu for GitOpsCon initially, so I also wanted to give her credit. Yeah, you can reach out to me if you like, I'll be around. Thank you.
Can you use this? Sure. Thank you. Yes. OpenVoxView, yes. You ready? I think so. Good luck. Hello. My name is Sebastian. I'm main developer of OpenVoxView. I'm working at Service ERP as a cloud engineer. And why I started OpenVoxView was I wanted a single binary replacement for Puppet board. And we showed the first version on VoxConf last year. And the main issue I had with Puppet boards was Python. Something from OpenVoxView, we have queries. In Puppet board, you can have one query, you can execute one query. If you want to do another query, you have to duplicate your tab or anything like this. In OpenVoxView, we updated it to you can have multiple queries. The query you have history of queries. You have predefined queries for frequently queries. So it's much easier. Looking into predefined queries are in the configuration. You can define them easily and look into rerun them from the UI without problems. You also have the query history. It's in-memory database, which queries are executed, so you can rerun them. You can adjust them and so on. It's a nicely thing. And really new are query parameters. Query parameters are you have the problem. You have your Puppet code and copy your PQL query from your editor to your Puppet board, OpenVoxView. Then you have to replace your string interpolated variables, and then you have to adjust it. You have to copy it back. You have to replace again with your variables. It's an annoying task. So in the last week, I thought, hey, let's recognize variables, provide some input fields, and render a new query, so you can you don't have to replace the variables every time. You can also have predefined views. Predefined views are in config like the predefined queries. You can have an inventory view. You can have a view of your broken nodes or something like this. It's really easy. Also, we developed a Puppet module for this to easy deployment. 3 lines of Puppet code, and you have an OpenVoxView running. Some people asked for documentation, so I added documentation. Not a developer thing. And last Friday we released 1.0 and get to production ready. So if you want to use it, use it. If you find issues, create issues, pull requests, everything is welcome. The next ideas of OpenVoxView are maybe PQL syntax highlighting and completion. It's nice to look in long queries and see highlights and things like this. A dependency graph is an idea between catalogs or between resources in catalogs. It's not an easy task, but we want to add it somehow like in Puppet Enterprise 2018. And we want to update our query parameters to save the query with the variables in it. Currently, we save the rendered query, but we want to save the query with the parameters in it. Also, for the predefined queries, we want to do the same thing, so you can rerun them and have only adjust the values of the parameters. It's a nice, helpful thing, I think, and maybe someone use it. Some great ideas in development was a member of this audience put a pull request at a dependabot. Nice idea, clean project, everything is fine. But this is a TypeScript, JavaScript thing. And NPM has every day a new, a new version of any library. So you have to much to do with the dependabot on a TypeScript JavaScript project. Yeah. Thank you for your attention. Feel free to contact me, contribute. Thank you. This. When's this? You ready?
Almost.
Yeah.
Hi, my name is Ulf Månsson, working for a company called D.AUD, working with electrical charger. I submitted this talk like a couple of months ago, talk about how you build a more effective engineering team with processes, standardization, and everything around that. But I changed my mind because that's not what you need anymore. So much has happened in the last couple of months, as I see it, and this is because of AI. What I've seen is an explosion with AI. It's changed completely how you work, how you do things, like Adam was talking about before. And this has happened like during the 6 last months, or 7 maybe now. People talk about 6 last months for a couple of months. This was Bill Gates. He was on a Swedish television show a couple of days ago. He's like a programmer. He's liked to program. Even when he was CEO, he was programming. He said that. I'm pretty impressed what the AI got much better. He's focused on AI now. He's not doing very much of coding that he did before. So what AI will do, instead of having a team that is 10 times faster, it will be 100 times faster. And I think Adam showed it very well. This is a real change that is happening now. A year ago for us at my company, we started to use AI, ChatGPT and tools like that. We saw like a 25% increase in performance. I was like Adam saying that AI was nothing. It will not change anything dramatically, just a tool. Today, I would say it's really increased the performance, at least within our company, between 200 and 1,000%. Adam was doing even more within this company. But this is what we have seen already now. For example, we set up like a AWS core setup according by the book and everything with Bloomy script. I would estimate it would have taken 6 months to do that. ChatGPT estimated 4 to 8 months. It took like 4 weeks to do that setup. We have created an in-house tool now. We did it in 2 weeks. ChatGPT estimated to 4 to 7 months. Actually, it was me doing most of it, and it was in Java. I haven't programmed in Java for like 10 years or something like that, so it will take even more. So we put like user stories like this. This is from Jira. We just copy it from Jira, put it in Codex or open code, and then the output a couple of minutes later was like this. It was like whatever we asked for or what we would like to have. This was like a simple task, and we already defined like the architecture and everything around it. So it was just super simple. So we did it like in 5 minutes. And this would have taken like 1 day or something like that. And I work on a hobby project as well, together with a friend. We have spent like 6 weeks. We have made like 50,000 lines of code, complicated microservice setup and everything. It was estimated to take between 12 and 24, 1 to 2 years. This is a merge request that my friend did. If you read in the bottom, you see he changed like 258 files, 13,000 lines of code was added, 11,000 lines of code was deleted because it was the refactorization, and he did it in 2 days. So this is where my computing career started, with a ZX Buytaert, if anyone remember that, it's old enough, 1 kilobyte of memory. This was like the first major thing within computing for me. And actually, I wrote like the program to the left is the program I wrote. You print it on a type print. I was actually selling it in classified heights. And if you find it, it was generated now. It was called Airfight, after Airfighter in Sweden, Viggen. There's a bug in this code. If you find it, you can contact me. Then the next major thing for me was like internet, where you start with FTP, SMTP, Gopher, if anyone remember that one. That was before Netscape and Mosaic. This was like the major thing in my computing career. And now is the third major thing. It's the AI coding agents, like Claude Code, Open Code, Codex, and things like that. When you create plans and it creates the code for you. I haven't seen something like this in since the 90s. Where are we going now? This is Santa Maria Columbus going to US. They didn't know where they would go. We don't know where we go. How will it end up? Or will it end up with Trump, like in the US ended up? we don't know, but a lot of things were changing, as Adam pointed out before. So I would say stop write code, create code instead. That is the future. Then I would like to do some raising hands. Everyone that has used ChatGPT can raise the hand. Have you put some in production code from ChatGPT? Keep your hands. Okay, good. Have you used tools like Codex, Claude? Keep your hands. Okay, have you put something in production from them? Good. I think you're quite work safe in a 1 or 2 year for now. The other of you, I think, have to change your mind and start to use those tools because you will be out of job. Thank you.
Who's next? Is me?
Yeah.
Oh. Brew me coffee. This is not.
Yeah, you can also hold it.
You can use both. I can use. Anyway.
You ready?
I'm here. So this is going to be interesting for who is using Puppet. I think also who is using Ansible. This is about Pabawi, a class infrastructure command and control tool, which I did, Alessandro Franceschi, from example 42 in the last 2 months. So what it is now, a web interface for Puppet, Bolt, PuppetDB, Puppet Server, and Hira. You can easily activate integrations and basically visualize on web whatever makes sense to visualize with this kind of integrations. So, for example, inventory listing with PuppetDB or via Bolt, execution of commands via Bolt, Hira lookup of the keys used in the code and code-based analysis with the Hira plugin, future integrations with Ansible or any kind of similar tools. The tool is self-explanatory in terms of how to configure it. You have a page for setup for every integration. It's quite easy to set up in an existing infrastructure. And you run it on your machine. The current version is supposed to be run locally, and to see what you can see from, for example, the inventory of PuppetDB, in this case also Bolt nodes, so a list of nodes in your infrastructure. This tool is for the classic infrastructure, good old VMs and physical servers, if you still use it. What you can get, of course, whatever information you can get from tools like PuppetDB on a node detail page, with relevant information, you can see any kind of stuff which is available on PuppetDB. So facts, Puppet facts, of course, are visible in different ways. The point is that you can also do a global search for facts to see how some values are present in your infrastructure. That's the next slide, but I am anticipating times. The whole idea is also that you can get from PuppetDB reports, of course, of Puppet runs. So you have a visibility of front end, a new front end for Puppet reports, see what is happening, what is changing, when it changes, details on the specific reports, details of the events. So what has changed in Puppet world, in this case, a single file change in the last Puppet run. And of course, this is all coming from PuppetDB, all available and nicely visualized, shown. On PuppetDB, we can also have the full list of managed resources by Puppet. So useful to have, nice to see, nice to know what you're currently managing with your Puppet tool on your system. As well, you can have a lot of information about your infrastructure facts. So interesting, see all the IPs of your nodes, see all the domains or the operating system, whatever is written in fact can be easily, especially quickly visualized in this web interface. You have the integration with Bolt, so a web front end to execute Bolt things. The list of execution done, when, on which machine, the status of the execution, and of course for each execution, the detail page where you see what happened. In case of Bolt, there is also automatic discovery of the
tasks available and the relevant parameters. So you don't need to configure anything. You have already the interface to put the right values in your, for the parameters of the task you use. For every execution, you have, of course, the detail page with what has happened. This is now working with Bolt. Future plan is to make it work in the same way with Ansible. So basically a web interface to the commands you run on the infrastructure. You can have, with a higher integration, also the analysis of the Puppet code. Basically, if you have, you can see what are the classes most used, what are the classes not used, if there are some links in the code to fix, if there are Puppet modules to update in your Puppet file. The code analysis does this. And there is also the integration, which allows you to look up hierarchies, how they are evaluated in your node. So for a given node, you can see what are the values of your hierarchies and where they are set in what part of the hierarchy, which is useful for understanding what hierarchy does. And also you can do a site-wide hierarchy lookup, so understand the values for some specific keys in all your nodes. So you have this kind of information available with the hierarchy integration. Last but not least, you can do catalog diff. So compare two catalogs using two different Puppet environments of two different branches of your code, see what are the resources different, and so have a sort of preview of what Puppet will do on your system before changing it. Needless to say, this was done in 2 months, but not by me only. There was also my friend Claude and his own friends. Version 1 is under work. Actually, started it 2 days ago. There is a lot to do, but I plan to do a full integrable, pluginable plugin system. Tomorrow, I'm going to talk about this. Room B after lunch. Be there if you want. If you're interested, you look at it. I can demo it. I can show it. I can also install it quickly in 15 minutes in your Puppet setup because it's very easy to set up. Thank you, everybody. Oh, yes.
I think I also need this. Can you help me with this? I don't get this. Like this. See, it's annoying.
All right.
Let's do it. Hello. My name is Yair, and I'm most likely one of the oldest people around here. I've been doing systems and operations since the early 90s. I started actually with VAX VMS. I actually was working with OS2, if anybody in this room even have a remote idea what I'm talking about. I remember when there was no internet. And then there was Unix for me. I was falling in love with Unix systems design. And Solaris, we ran containers in Solaris. It never failed us. I was mainly enjoying, and we know Unix has one thing. Do one thing, do it well. So it kind of stuck with me. I kind of like it. But I think we also kind of forgot this thing. And then time flew. I worked as a quality assurance engineer for quite known brands. Then I did some other things. Had the pleasure of working with a lot of this open source community where I lived in Israel and then Berlin. And then became a consultant, manager of a company. Fell in love with DevOps. And then I had a kid a year ago. And I don't know what happened, but I wanted to do my own thing. Like just one tool to check how it goes right now. Started like a pet project. It was just a CLI, very simple. And I tried to use the tools we have now, and I really weren't enjoying anything that was happening around me. Yes, I'm going to wait for the next slide. First Ignite. So like I say to everybody, Kubernetes is brilliant. Yes, it solves Google's problems. I'm just one person. I have no ability to deal with this monstrous thing. And also from work, I don't like Kubernetes. I spent 5 years telling people not to do Kubernetes. All the simple tasks require complex infrastructure. What about simplicity? I just want read open telemetry. I don't want to deploy a whole backend called Yair with a lot of databases. I want simple tools because I'm a simple person. Yeah, I'm a simpleton. I want easy to use, easy to maintain. Please, no YAML. I hate YAML. I despise YAML. So I built what I needed. And that's the magic where it comes to what Adam was talking about. Apparently, Claude code started really for me. It was just basically doing bad shit. But now, I learned how to work with it. And the first tool I created is called Cykli, or Cycli if you read it like this. All the names are in Finnish. It's a CI that is basically works locally and first local. So at last, we can use our M4 processors. It has SDKs for Rust, Go, TypeScript, Elixir. There's no YAML, no DSL. Where's James? It's built on Beam, so it has concurrency of Beam. And it works remotely and locally the same. I use it for all my projects. Now I also did Nopia, another Finnish name. It's GitOps. It's written in Elixir. I don't know Elixir. There's no Redis, no Cassandra, no service mesh. It's just one dependency, and it also does CD events. It watches the repo. It syncs the state to your cluster. OK, it has CRD one, but there's no Redis and no Cassandra. It's the old one. I'm mega dyslexic, so I sometimes don't see stuff. The thing is this. Yes, I agree. This comes from vanity and frustration. But it also comes from the idea of Unix infused with what I really like about DevOps. And it's amazing that we can do all these things now. I created so many tools. And they work, like there's Kulta, Seppo, Polku, Ilmari, Rauta. They're all trying to do one thing and do it well. So I think with the new things that we can see around us, we have the power to do a lot of great stuff. I even got really, one night couldn't sleep, and I have now my own programming language. I don't want to talk about it too much, but if you want to talk about it, catch me somewhere. It's my own programming language. It's compiling to itself soon. These tools are not in production. I wouldn't use them in production, but Cykli works. It does what it needs to do. And I started in June, and now I have 12 tools, maybe a startup that I'm starting, and that's it, basically. And I'm saying we can use these tools to go back to the Unix way and not do Kubernetes.
Okay.
Who's hungry? Bobby Saloon here.
Thank you.
Go find that too.
Hello. Thanks for coming to my talk. It's always nice to be here, so I appreciate my talk being accepted, being invited, and thanks for coming to watch this in this room, or in the internet. So what I want to go over today, as you can see, mostly, is when it comes to platforms, some observations I've had, things people have told me. I don't actually do real work, I just make slides. So this is all through other people's experience. But, you know, seven things, some of them are kind of the same thing, but go over some things that people stumble with when they decide to build their own platform. Now, as I'll get into, what I mean by platform is like a platform as a service, an internal developer platform, an application platform, whatever you want to call that kind of thing. It has several names that it goes by. So first of all, I've been an analyst. I like to use charts, all sorts of things. So I just wanted to put a little warning out here that if you don't like charts and industry analysts and things like that, you should prepare yourself, because there's going to be some of those in here. And as always with surveys and charts, you know, they could be right, they could be wrong. More than likely, they're somewhere in the middle. They're, I think, as the technical people say, not technical like y'all, but the technical chart people, they're directional. They give you some idea. And they're also better than just making a claim without a visual. I'm never a just big words on a slide kind of person. So why are platforms interesting to look at now? What's going on with that? Well, speaking of charts, here's a chart from the most recent CNCF, Cloud Native Computing Foundation survey of the cloud native world, which for the most part means the Kubernetes world. I don't know if they're surveying the remaining like Mesosphere and things like that, containers out there. But if you look at this, what you can see, if you look at the dark one, and you know, you go from from darker to light, you can see this steady rise in container usage, right? And what this is saying is how many of our applications in production versus development, you know, what percent are the respondents are saying where most of our containers run. Now, I mostly pay attention to what's running in production because that's what runs things, not just development and test and staging, all those other things. And so, you know, I think if you look at this, and especially if you've been around, you remember when things were smaller, it's pretty clear that containers, which is to say Kubernetes for the most part, are really starting to become a significant part of what's running the world, if you will. Now, there's a little bit of tempering to do with this. If you look at other charts and kind of poke around, right? If you ask the question, if we look worldwide, what percentage of the applications that are running in containers and running in Kubernetes? It's actually a very difficult figure to find or to get accurate. But I would estimate, like last time I tried to figure it out in the fall, it's probably, by looking at other people, it's probably around like 20% tops or so. Depending on how you count like hyperscalers versus banks versus like other organizations like that. But here's another cut, kind of showing you the same momentum of containers being important from IDC. And what you can see in the red is you basically, 100 area charts are fun because you can see declining and growing. And so you see the green are VMs and you see the red are containers. And so you see that same steady rise in container usage. Now, as the report writers note, fun enough, most of those containers run in VMs, which is fine. But you can see where the kind of primary thing is. It's really increasing and kind of in that same kind of slope. I shouldn't use technical terms, but in that same kind of growth rate or that growth that you see from the CNCF area. So what becomes, you know, also interesting to look at is, so now we start to think, so we have all these containers, they're running there. Presumably they have some applications, some software running in there. And what becomes important is how we manage those containers, right? And what people are looking at nowadays, you can see lots of interest in it. I never really trust in 80%. I think even if 80% is accurate, you should probably bring it down to 78 or 82. Because of course there's the 80-20 spread, which people just kind of make up. But we'll go with this. But you can see this rise in interest from 2023 of just like 30% of people were into platform engineering. It's probably back when they were like building out you know, various things and they weren't yet up to platforms. But now there's tons of interest in this. Most organizations are interested in building platforms. And indeed, you know, it's part of this kind of cyclical thing that goes on, that's been going on for a while, where you see over and over again, there's a lot of infrastructure build out. A new type of infrastructure comes around. Sometimes it's a new type of client, like with mobile, but a new thing comes around in the stack. And in particular with infrastructure, everyone gets obsessed with the infrastructure. Here we are. Building out the infrastructure, figuring it out, you know, often redoing it instead of just improving what they already have, or debating which one you're going to have right or left. And I think I kind of made up this chart. You know, 2007 is when the kind of the first platform, I'll call it of my generation, being kind of a Gen X born in the late 70s type of person, or a person, not type. And you know, around then you see Heroku in 2007. There's all this PaaS stuff that comes out, platform as a service. And sometime, I'm just estimating, I don't really know when you would call this, but around 2019, 2018, you know, I mentioned Mesosphere and other stuff. You've got these orchestrators out there. And then finally, Kubernetes just comes in and just consumes everyone's attention. And then we have container as a service. And that goes on for some time, you know, lots of complaining about it, lots of people really liking it, lots of people figuring it out. And now, you know, I don't know about you, but what I see is more, as I just showed with the previous, the Gartner survey, there's more interest in, we don't call it platform as a service anymore. So just erase that from your mind, even though I'll let myself say it. But there's a lot of interest in platform. So it's almost coming back down, well, in a good way. It's consuming more and more of what the interest is. And you know, I think a lot of that is because we have got all these containers, we're finally putting stuff on it, and then what you become interested in is how do we make it easier for our application developers, or maybe your robots, if you're doing that, to deploy things automatically to it, to manage it at scale, you know, manage of thousands of these containers and the applications in them. And that's what really brings in that notion of platform as a service, or a platform. Now, what I want to go over is the kind of anti-pattern that I see, or patterns that I see, so, you know, famous old 2017 quote here, is that everyone kind of knows they need a platform. And they might appreciate other platforms out there, but they're like, we have special needs, right? Like, we have unique needs. We might be one of 300 of our type of organization, or 3,000 in the world, that pretty much does exactly the same thing. But the way we do our platform, something special running in it, right? Now, this is from 2017, so things might have evolved since then. But if you look at more recent quotes, you can see one by the same person from 2025, right? This same sentiment exists, that building your own platform, the kind of experts out there, they all sort of hint at, like, it might be a bad idea to build your own thing. But we keep doing it over and over again. We're very much into building. And you know, like I said, I've observed this stuff for a while, so I thought I would put together some of the problems I've seen in the past that people have when they are building their own platforms. And hopefully, as you're building out your platforms, this will allow you to not trip over those things and stumble. You'll be able to avoid some of those patterns. Or that whole notion of, like, why don't we just build this from scratch for the exact needs that we need? And hopefully, at least some of you will be convinced that it's not really a great idea just to build your own platforms. So first of all, or I guess second, this is me, if you can't tell. I've been lucky to work for, I think, about 11 years now. I started off at, well, I've worked longer than that, but at this current place, at Pivotal, which was acquired by VMware and kind of sort of by Dell. And then eventually VMware was acquired by Broadcom. I work in the Tanzu unit, so I can't talk to you about VMware, VCF, or any of that stuff. I could refer you to someone else if you have comments. But in doing that, I've been able to study how large organizations basically do software. And I've been lucky to write several books here. I don't know if 3 counts as several, but it's more than a couple. And I've had a podcast for a while. I've got 2 podcasts now, and I started another one that's kind of topical to platform engineering. And as a note, if you do like podcasts, or if you're looking for something to do tomorrow, I think at 4, I'm going to have a live recording of software-defined interviews with my friend Andrew Clay Schaefer here. You should come check that out. Ask some questions. We'll open it up probably for people questioning things. or who have questions and who question things. So what is a platform? Just as a quick review. It's great. A couple years ago, the CNCF came out with a platform reference architecture, which meant when I have been instructed to not give vendor pitches, I don't have to only show a vendor slide. I can show you a neutral, industry consortium-driven one. But if you look up at the platform reference architecture on the, I guess it would be your right, you can see a lot of the stuff. Not all of this, I would say, is like in the platform. At the very least, it's things that your platform works with and integrates with. But there are a fair amount of components in there. And again, if you've got the frame of reference as a platform as a service, this should feel pretty familiar. The other important part of this, there's two important things. One, this is kind of sort of like a view of what you need to run applications. All of it is centered around you write your own application, you want to run that application, you want to manage it. That's really what you're bundling up in a platform. And also of note, I don't know, it's kind of interesting, even in this reference implementation, the infrastructure is kind of like not important to it, right? So it's more that you're running on whatever type of infrastructure that you want, and you have all of these services built into a platform. Now I came across this next one. If you're really into like, maybe they can use this for like Tron 3 or whatever. But here's a fun view from Forrester of like everything that's in a platform in the IT stack. If you're into like three-dimensional diagrams, that I thought I would just show for you. Maybe you can get the slides later and ponder this. It's hard to tell now that I'm looking at it if that back part is in front or it's in back. It's a good illusion to figure out what's going on there. So let's go over what these 7 problems are that people have when they build their own platform. So the first one, let's call it unexpected scope creep. I guess, is all scope creep unexpected? Maybe that's redundant. But this is a scope creep you can predict. So if you remember back to that platform, right? A lot of the times when I've encountered people building platforms over time and other people who kind of cover this stuff, what they kind of think of as a platform, what they end up building for the first time and kind of abandoning is there's base container images, templates that they have. They might set up like a namespace in a cluster for developers to have and just hand that over to them, right? I think of this as I'm a former application developer. I think of it as the blinking cursor problem, where like the platform is a blinking cursor waiting for me to do everything else, right? And sure, by providing these templates and base images and things like that, you're providing the best practices that people can use. But what you're leaving out, this is just some stuff off the top of my head that I came up with. Now listed. But there's all of these other things that typically, when I look at the platform teams in large organizations, the platform teams are also heavily involved in this, right? So they're not just delivering a pipeline, they're not just delivering these base container images, they're not just delivering kind of integrations here and there, but they actually have a whole finished off thing that handles tons of these things, that takes this kind of toil and worry not only out of the needs of the developers, but also out of the hands of your security people and audit people. It automates a ton of that. And then just to drive the point home about this huge scope that actually building a platform has, there's I really like the CNCF stuff apparently, but here is the robot, which is to say ChatGPT's summary. If you look at the cloud native maturity paper, it's a new version of the platform maturity cycle. I warned you, I'm going to use phrases like maturity cycle and things like that, so hopefully you're not offended. But if you extract out the features and the technology across the 5 phases of this maturity model that they believe and have also observed platform teams doing, hopefully you can see that's a lot of stuff, right? So as you look at this maturity model, which goes across 5 phases in the journey, in the life cycle, you're kind of expanding out from that original scope that I was going over, adding in all sorts of new features and integrations, changing the organization around. It's actually, it's in beta, if a document can be in beta, but it's a really good overview of not only the technology you put in place, but as they say, the business outcomes, what it actually affects and how it changes things in your organization. So the point of the unexpected scope creep, and I see this over and over again, and I know other people do, is that you initially think building a platform is going to be easy. I think it's only application developers who think everything can be done in a weekend. You know, other people a little more wise about that. It might take a couple of weeks. But it ends up being more features than you thought it would be. And therefore, you know, you kind of get in this situation where you've gone through all this work and you don't actually have all of the features. And then that results in underestimating the ongoing investment. That is how much money you end up having to pay for it. Now, typically, why this is done is because you think of a platform team, right? And if you model this out, you can use whatever currency you want because it's just simple math. I probably should have changed this over. But if you model out, let's say we have one team of 3 to 8 people who are building a platform for us, right? And let's say you don't have a very well-paying organization. They pay like 125,000 currency units per a person per year. I realize that's not like all-in pay that you would have depending on which region and all the other stuff you got to pay on top of that. But you can start to chart out this cumulative cost of one team basically building your platform. And of course maintaining it and doing the kind of ongoing running of it like a platform team would do. But just as a reminder, you've got many different components depending on how you want to break it down and which parts you're going to actually do. And so you've got a lot more than just one team with 3 to 8 people. And to model this another way, let's do another simple, I forget what the phrase was, but kind of like a dumb, stupid way of doing it, but just something that points in the direction. You're probably going to have more around 3 to 8 teams of 3 to 8 people, just to keep the numbers round, right? So then you do the math on that cumulative spend, and you can see you start talking about real money over time, right? So this is like, I see people underestimate this kind of effort, this way of thinking about it over and over again, right? It seems like it will be quite easy, again, in just a little bit of time to integrate this stuff together and get quite the discount on your platform versus purchasing one. Now, of course, the other thing to consider, I was talking with someone, I guess 3 weeks ago now at a large bank, and they were pointing out that with the kind of initial, like, that kind of blinking cursor of just giving access to namespaces and clusters, what ended up happening with the various development groups who are using this is they would have to have, let's call them shadow ops people on those application development teams who spent their time finishing out that platform and spent their time managing that platform that was given to them. And you know, this is kind of a delightful big bureaucracy enterprise conversation. He was like, and of course, the managers of those teams love this because now they have more headcounts and responsibility and they seem cooler. And so like that is a little bit, that's kind of a vicious cycle to get caught in, unless you want to seem cooler with doing things. But it really gets to the point that if you do kind of this partial, as often, if you have this smaller notion of the scope of building a whole platform, you're going to end up needing more and more resources from it. Because not only that, your team is going to have to run the platform, update it, help people, educate them about how to use it, theoretically like monitor it and manage it as well. Now in contrast, teams who don't spend time building out their platform and instead spend time managing their platform, helping people use it, doing the integration, you can see all over time, this is probably over the last 8 or so years, you can see all sorts of, what I think are pretty impressive numbers, depending on what you care about, the number of operations people who run that platform team, or if you prefer platform engineers, as people would say nowadays. And whatever, it's hard to extract these things, but there's ratios about the number of developers they support, the number of application teams they support, the number of apps. But I think these are good baselines to start with when you're thinking about, if we're building out our platform, do we achieve these numbers with the staffing that we have? And it's good, like if you do build your own platform, you can kind of run it against these benchmarks to see if it's meeting these things. These are what you're shooting for. All based on true stories. Some that are still running, some that are not. If you bank at Rabobank, they're up here in one of these things. It's fun to talk with them about the way they run their platform a little while ago. So next, the other thing that comes up, and this is one of those things that's kind of the same face of, or a different face of the same thing. There's people who, they run their platform as a project, right? But really what this ends up being is platforms as sprawling projects, right? So you have all these projects out there. You got many different platforms, right? They think like, it's going to be this one-off thing that we're going to do. Or I forget who it was this morning. They were like, hey, probably no one in this room, but everyone pretty much like does 80% of a project and then moves on to a new thing, right? And so that results in this, this sprawl of platforms. Now, that often, as I was talking about earlier, so much of what you see when people build their platform is done because people have very important critical needs that only they can build, that can't be achieved through other means, such as buying a platform or just using the corporate standard one. And Abby Bangser here at the last KubeCon, she had a great talk. It's like 15 minutes, well worth your time walking. And she has a good metaphor for this, which is, or analogy. Despite all the studies I've done, I get those two mixed up. But I guess an analogy, you use the word like, and a metaphor, it's like as, or like kind of more poetic. Anyhow, as she pointed out, she has this analogy that like those kind of platforms are like Christmas puppies. Now, or I guess if you're much wealthier, Christmas ponies. But you know, I've got 3 kids, and every time they tell me they want a pet, I'm like, I know you want a pet. You know, but that's, to use one of my favorite phrases, that was your gift, and now it's my problem, right? And that's kind of what ends up happening with this platform sprawl. All these people who need customized things, you end up with all these platforms spread out, all those different teams managing them, and the kind of mess that results for that. Or maybe mess is wrong, the kind of amount of work that you may or may not want to be doing, and cognitive load, I think. And you can see evidence of this, again, in another survey, right? Like, you know, as you can imagine, for as long as I've looked at this stuff, it's kind of astounding that these priorities still come up, that we haven't really solved it by this point. But here's one going over the priorities that people in this space have. And you can see that a lot of people are like, man, we got to have less platforms, right? Like, we need to consolidate these things. We need to standardize on them. There's, I guess I only talk to banks, or those are the memorable ones. They have the best, worst stories, probably. But there's another bank in this area here on the continent who their whole initiative is like, yeah, we spent 5 years on silos and specialized IT, and let's stop doing that, right? And so now they've put in some initiative to try to consolidate and standardize these things, which you see over and over again in organizations. So instead of that, what is the better notion of thinking about things, right? And you've probably, well, hopefully you've come across this notion. If not, there's plenty of information out there. There's this notion of platform as a product. And the important part about this is, well, the product part. And there's a couple of things. One, what you're doing, if you have a product, well, if you want to stay around, it's important to realize you have customers of the product, or users if you prefer. And so in this situation, what you do is you pay a lot of attention to the customers of the users. In the case of a platform, it's primarily application developers. You have other, let's call them stakeholders, usually your compliance and security people, other folks. But you start thinking about how would we build this platform and ongoing add features to it? How do we product manage it? And you can see this is an example from a couple years ago. This is another great presentation to point y'all at. Where the people at Bol, you know, the Amazon of the Netherlands, for people who don't use it, they have they think about, like, the platform team sits in the middle of all these different silos, and they try to unify it and integrate it together for the developers. There's some great findings that they have in there. Now, the notion that I was saying that's important about this is product managing the platform, right? And the thing about product managing, and then having the, let's call them implementers, you call them platform engineers, platform developers. The thing that's important about that is it is a fair amount of work to kind of monitor what your customers, the developers, want, and your other stakeholders. Think about how you experiment and put that in there, and then monitor if it worked or not. Monitor is a different word in this room, but how you gather feedback about how it works or not. And the point there is that amount of work, that amount of attention that you're paying to it is pretty all-consuming, right? Going through that cycle, doing that, and you're probably, if you're doing this kind of product management, this kind of platform product management right, you're probably not going to want to spend a lot of time just like building the goopy innards of the platform, right? You've got a lot more interesting things to do than building the platform. And just as a hint, or not a hint, but kind of some direction, this is like a survey of common questions that you would ask developers to be like, hey, I'm a product manager. I would like you to like the platform, and by extension me, us the platform team. These are the kind of things that developers, typically application developers, are interested in solving. So it's kind of a survey you can send out to to check out that. But it helps represent the kinds of things that a product manager, that a platform team is interested in doing versus, again, that plumbing that's underneath there when they could just outsource that effectively. So the next thing, number 4 on our list here, that people often encounter is, let's call it homegrown lock-in, right? Or to use a word from earlier today, artisanal lock-in. And what this ends up being, again, to bring it up again, there are often, and I guess, of course, I work at a vendor, so I encounter this all the time, and it's very memorable, just like every time you get, I assume I never really have, but I imagine when you get punched in the stomach, it's very memorable. But people have this notion that we need the customized stuff, we've got to fit it into the way that we do things, and even worse, if we were to buy a platform, we would be locked into that platform forever, right? We want to avoid the lock-in. And you might say, you might start asking them like what lock-in is, and they're like, it's lock-in. Like, we know that we don't want lock-in. So what that means is we need to get some open source stuff, maybe, probably, and integrate it together into our own thing, and then we're fine. We've avoided the lock-in. Of course, as the title gets to, what you end up doing is you're building your own platform, your own form of lock-in. You're assuming that the thinking that you have, the design that you have, that knowledge of that is going to persist past, as we'll get to, the people who find a new job after building a platform. But you really are building your own cage, if you will, that you're stuck in. You can't really go talk with other people about how they do things. You can only talk to yourself, which is delightful on other topics. But you're really not avoiding this lock-in so much. Now, there are ways, I think, to think about and achieve the same thing, right? Like, I think this is more or less, I'm sure there's other ones, but I think these are the 3 things that people are trying to think through, avoid, or have when they're talking about lock-in. And the first one, from way long ago, in 2006, I think, there was this guy, I think he still is, hopefully, there was this guy, Simon Phipps, who worked at Sun Microsystems, and he was like their open source guy. And he had this great notion of the freedom to leave, right? And it was essentially another version of talking about portability. It was like, you can use, this is back when, closed source versus open source was very controversial. And it was basically just like, we only want open source, no closed source stuff, which is a problem for Sun, if you remember. And so it's more about the notion of like, well, you can go wherever you want, but you can always leave, right? Like, it's easy to leave. And that's more of the kind of lock-in that you should be paying attention to, which is to say the portability that you have. You want to be able to shift to different platforms or different things. And of course, as Adam was going over, it's very easy nowadays if you have the right kind of stack out there. Apparently just a week or less, which is great. Now there's also the, those boring architects and other people that were mentioned earlier. There's also certain switching costs to think about. This is not just licensing or paying a subscription, but it's the time that you put into doing something, the risk that you take on doing something, the time it just takes to move and rearrange things, right? And you probably want to, let's see, maximize the first 2 and minimize the third, right? But these are more of a more sophisticated way, I think, and helpful to think about lock-in avoidance rather than just lock-in, right? Like, if we actually spend money on something, we must be locked into it. More go over these criteria and see how it fits into what you want. Now, as I mentioned earlier, the other issue that people have, and this is certainly something you see a lot, which is fun for people but less fun for organizations, is that retaining the skilled people who can build those platforms, who know about that exciting plumbing in there, they turn out to be very valuable, highly skilled people. And as proof of that, when you look at surveys again, from the oldest CNCF survey to the newest, what you can see is the lack of skills when it comes to cloud native technologies or Kubernetes. It's been in the top ever since 2017 for a long time. And obviously there's a typo there. That's supposed to be 2025 on the other side. So I think it's improved, or respondents, it's improved a little bit according to people who said it was in the top 3. We've gotten like 4% better at it, right? But skills and knowledge of how to run this cloud native stuff is always a problem, and it hasn't been fixed if you look at this, right? It's always an issue. Now, security is always the number one issue in these things. So I would even raise up skills and the other ones higher than that, because of course, security, right? I don't even know why you need to ask that question. That's always a top one that people are concerned about. And also, who is ever going to answer a survey and be like, top 3 security? No way. Don't care about it, right? You almost feel self-obligated to answer that. So the skills that people have to build a platform, not even just run it, but build it and do the ongoing management are very valuable. So, I hear this story over and over again of you hear these lots of organizations try to build out their own platform, right? Based on whatever container stuff, Kubernetes that you want to use. At the end of a year, most of them haven't really delivered very much, right? They had that scope creep, or they got bored, or a new executive came in and completely redid the strategy, whatever it may be. There's a few of them that actually succeed in building something that gets a bunch of production applications. They get up on a much bigger stage than this and give a keynote, and then mysteriously, 3 or 6 months later, they're working at a new organization, right? Now, you could say there's all sorts of problems if you're outside of the tech world, even in the tech world, about, well, maybe they should have been paid more to be retained. And then someone's like, oh, we can't do that. That's a lot of stuff to handle. So from a worker perspective, that's great. But again, from the organizational perspective, losing people who just built something really cool for you, sometimes whole teams of people, is not great. Now you're basically left with this platform that the wizards made for you, and you've got a lack of wizards who know how to do anything with it, which is a bummer. So that's something that comes up over and over again when you build a platform, versus if you buy a platform. And this gets to the homegrown lock-in. There often are many other organizations that use this platform. And I mean, I guess from a worker standpoint, that kind of means the value of the workers goes down a little bit. So sorry about that. But it also means that you've got a higher chance of retaining those workers, and you don't have the interruption if you're depending on the skilled labor that is often poached from you once they've been successful about it. I guess if you're a manager, you could also say, never send your successful platform builders to a conference. Don't let them present, which is even more impressive to think about. But it might be an effective strategy. So number 6, I mentioned that security is very important. And I am by no means a security expert. Security people start talking to me, and I just start thinking about I got to finish number 4 of Dungeon Crawler Carl, because I got to get to number 5. I just found out there's actually 8 books. I thought number 5 was going to be the last one, and I'd be caught up. So I'm busy. What was that guy talking about? I forget, right? I just zone out. So I tried to think of some way that I could represent the increasing need to worry about security, how much time is going to be consumed if you've built your own platform. Again, think about that stack of all the things, the integrations that you have, the dependencies that you have. And, it just gets worse every year, right? Things are constantly attacking you, going after what you're doing. There's constantly problems that you're finding. And if you build your own platform, if you remember the Christmas puppy, not only was this your Christmas gift, but it's also your problem now, right? This becomes something you're responsible for, and it's easily going to consume a tremendous amount of your time. And then meanwhile, you've got to have your daily stand-up meeting to go through the backlog to figure out what new features you're going to be giving your customers, your developers, which is to say product management. Not only that, but there's also all sorts of exciting things that happen where you also want to have new governance that comes into place, new things that you're going to be wanting to run your platform on. So that's a whole other thing. Again, if you've built your own unique Christmas platform or holiday platform, a gifted platform, that also becomes your responsibility to figure out how to move things around and manage it. So not only in the security area do you have this, but you also have this in the thrilling world of governance and geopolitical climate and macroeconomic trends, which sounds like something that would be really nice to outsource to someone else and have them worry about those things. So finally, number 7, highly related to the skills stuff, but this is more of an effect to be aware of and watch out for. Now, probably all heard this great phrase, resume-driven development. If you haven't, one, as always, you can have the individual perspective and the organizational perspective. But what it means, there's actually a paper about this. It's not just some funny like tweets or skeets or toots or whatever, right? It's not funny phrases that people have out there. There's actually some Germans got together and wrote this paper, which of course, right? And you can see the definition. There's kind of this interesting trend. If you go back to hiring, right? When you want to hire people, you want to make the job seem interesting, at least in tech stuff. And so you list out these new technologies that you're using. There's a new opportunity to do exciting stuff. And so you tend to have this kind of like signal put out by hirers, by people hiring, who like work on this cool technology, right? So one, you start creating the cycle of like, then potential employees want to know, I got to know this new technology to get a cool job or just a job. And so what happens is all sorts of, whether you're an operations person, a developer, someone in IT, you start thinking, I should be working on cool new technologies, not this old stuff. And so that kind of drives this, whether consciously or unconsciously, it drives this idea to use new things, to move on from what already is, you know, there's always a joke that we want X new technology to be boring, which means runs very well, we understand it, it's stable, and we can start making money because of it. Or if you're in a government service, you know, providing services to our citizens. But these boring technologies get ignored because people start pursuing this resume-driven development. And you can imagine I wouldn't have shown you this paper if it didn't have a conclusion that I disliked. But you can see that tends to drive a cluster of like less knowledge about the system and an overall bad system where there's a high degree of, as they delightfully call it, RDD. There's even a technical term for it. So those are the 7 sort of pitfalls that people fall into. And I thought, you know, that's kind of a quick overview. And when I was going through this, I was thinking, usually at the end of my talks, I skip over like 5 slides because I haven't been able to cram all those slides into the time that I have. But I noticed it's pretty short when you go through that. So I thought I would give some bonus material at the end here and go over a few extra things beyond the actual 7. Maybe it makes it 10 or so, inspired by our hamster friend here and his extreme desire to get deals and to get lots of 2-for-1 things. I don't actually have 1,000 products, but I've got about 3 or so, and I only wanted to spend so much time on this graphic. So if you're into business stuff and you're older, you might remember this from a long time ago. This is a, what are these called? Value maps? I gotta be honest, I was really never into this, and I didn't like it, but boy, people were like fucking thrilled with this stuff when it came out. So here it is, for those who really like it. And the whole notion of this, the importance of this map that Simon Wardley did, Wardley maps, that's what they're called, is that when you are building a stack, of course this model is universal. It could probably apply to what soda or beverage you pick for lunch or what you choose versus like how you want to customize it. But the point of this approach to things was if you're doing a business, you want to figure out what you should customize, what you should do yourself, versus what you should buy, essentially. And there's all sorts of metaphors about like cowboys and Pittsburgh and town people or something. And the kind of like point of it is to say, once you chart this out, find the things that are not valuable, that are not a competitive advantage to your business, or as I think about it, what are things that do not cause your customers to give you money, right? Like, in general, when I go to the home of our hamster there, when I go to Albert Heijn, I don't really know what platform they're running. I just go there for like their groceries and for the mobile app experience that they have. And because I know that on the little self-checkout thing, I don't have to print a receipt out. It's pretty awesome. I just like scan the barcode on my phone and I can go out without this stupid little piece of paper that I immediately, I mean, they even know there's like a trash can right by the gate to get out of the grocery store because they know that piece of paper is useless. So it's really nice that their applications are good. I have no idea if they run Kubernetes or Mesosphere or whatever because that's not valuable to them. It doesn't mean anything for how they operate. So according to a Wardley map, if it doesn't mean anything, don't spend time on it, transform money into not spending time on it and buy that thing if it's a commodity thing. Now, in contrast, also, I don't know, maybe it is down here, but also in the Netherlands, there's this delivery service called Picnic. I don't know how to pronounce it in Netherlands, I apologize. But what's interesting about Picnic is they custom built, I found this out waiting for lunch a year or two ago. They custom build these little tiny narrow trucks, and they actually have customized that because they're a grocery delivery service, and also, like here, but in lots of the downtown areas of the Netherlands, there's very narrow streets. And so it's one of the things they want to compete on, that they can actually go anywhere very quickly, very cheaply, with basically these like really good bakfiets. I'm sure it's a little bit more than that. But they think that that's part of what their competitive advantage is, so they built that platform, unlike the Albert Heijn and the Jumbo trucks that are just trucks. Because what do they care, right? Like, they work perfectly fine. They just pop up on the curb and they're like, hey, I'm here with your groceries, and they deliver them. So when it comes to building versus buying a platform, or anything for that matter, if you have the tolerance for it, go through one of these exercises. There's many ways to do this kind of strategy thing, but just a basic thing to ask yourself is like, so if we built our own platform, are we going to get more customers, right? Like, are they going to think like, oh, I really like your discount pants, but the fact that you're running and built your own platform, that's why I'm buying you over the Hema pants, right? So think through that, and probably what you'll arrive on is that like building your own platform doesn't really make too much sense. Now, another thing to look at, again, just kind of a bonus thing. Of course, we're interested in AI stuff, right? I think maybe I haven't mentioned that until now, which is perhaps a personal best. But it's important to think about, all right, so we're going to be adding this new workload, as Adam was talking about earlier, of just AI everything, right? It's going to be either applications done this way, written by AIs. It might be us running models or just running your all sorts of plugins, whatever you want. This is a whole other load that you have to worry about as a platform person. Again, more work on your plate than really you have time to spend if you're building your own platform. So finally, that's why I generally think, you should probably stop building platforms and start building apps instead. Don't really worry about building your platform. There's plenty of them out there you can have. With that, thanks for attending this. Thanks for having me. Let me try to go to the next slide. Oh, there we go. Now I can finish. If you want some more stuff, I'm always happy to talk. Well, I'm frequently happy to talk, occasionally. But you can email me there, and you can get the slides there. And there's just some more information about. It's actually based on a paper that you can read through there if you want to go there. So thanks. I appreciate it.
Great.
Hello everyone, I'm Stan, and I will talk to you a bit about Pickle and a tool I've been working on. Yeah, I know. So I'm Stan. I'm a system and network administrator for some time, as you may see for yourself. Let's lay out the ground. We are using infrastructure as a code tool like OpenVoxView, Ansible, and File, whatever you want, so nothing too much original. We like to model the world with their configuration language. Each of these tools has its own idiosyncrasies and best practices. And in my experience, when you're deploying a stack or a set of stacks, at least in the world I'm living in, multiple tools need to be used. It's not always Ansible or Terraform. So it has some, in my point of view, it has a direct consequences. It's your configuration. Maybe specified with the schema in a form, not really ideal for every one of these tools. For me, the first most issue is that you end up modeling with a bunch of mappings of list of mapping, and combination of those. And it's perhaps a combination which makes sense for the author of the configuration, but it's not really usable for the tool you're targeting. So, or you're not always using the right keying for your models. Anyway, it's hardly ever the right model, the right schema for all your tools. It has a number of consequences. And also, of course, YAML is not always the right syntax to use. That's hardly a surprise. And so, the consequences, from my point of view, is that you will want to transform your configuration data, to make it more usable, consumable for your tool, because you want to pursue the goal to have less complexity in the configuration code your tool are running. And how are you going to specify this transformation, which I written myself, have the goal to keep a model simple for the human being we are, but keep it simple by transformation for the tool who are consuming this configuration data. Well, the tool I've mentioned have a whole bunch of capability features to transform this data. To name a few, OpenVoxView has expression which can slurp some external file to where you hopefully will find data easily actionable. Ghent, of course, in this field will help you in that also. Ansible has a lot of features, filter modules, which will allow you to consume any kind of data in any kind of shape. And file in the manifest field will also help you consume data in various forms. And of course, you can always resort to use custom scripts programmed in your favorite language to actually transform your data in this easily actionable form for your tools. But why not using a configuration language to do this modification of your model? JSONet comes to mind, of course, Q or DAL, and there's a couple of those. But as we have already recently seen, why not using Pickle for that? It was first introduced here 2 years ago. If you don't know Pickle, I encourage you to have a look at the wonderful website and to quote what sits on the landing page. It's a configuration that is programmable, safe, and scalable. So if you don't know any kind of Pickle, you can easily have a taste of it. I encourage you to consult the documentation, the tutorials. Here you have a snippet taken straight from the homepage of the Pickle website, you can see that you can easily type your configuration, put constraint on it. Here you will notice that the port will not validate the constraints, of course. But this talk is not really about Pickle, mostly. Supplying configuration. We want to have easy to model configuration data, so we decide to use Pickle for that. We gain a lot of facility by choosing such a language. And how do we transform this Pickle configuration, this Pickle's model, in actionable configuration for our tool? A simple way is to use the Pickle tool to evaluate the module, to generate JSON, YAML, whatever you want, and then you simply use this file with your favorite tool, Ansible, Terraform, whatever, with some feature I mentioned earlier. Or if you're not comfortable with the idea of generating intermediate file and launching your tool, you can use your tool, because most of them have this facility and feature, to fork exec Pickle to generate the configuration in the right format, running your Pickle expression to transform this data to make it more easily actionable by your tool, and you slop it, read it, and interpret it, and you're done. You have your data easy to use in your playbook, in Terraform configuration, or in your end file value applied by your end values applied by end file. So that's two simple ways to see how to go from your user-friendly, hopefully, and actionable, easily actionable and transformable configuration in Pickle to your tool, which mostly reads and slop JSON or YAML. So now we have simple ways, at least two ways to transform our data configuration to our tool. We have nice models, nice configuration data in Pickle modules. And there is still operation we want to operate on our stacks. This object we write and conceptualize to operate our infrastructure. And this task need also, in my own experience, access to this data configuration also. What I mean by this task, is that ClearOps, is that a bad idea, like it was already been said? In my own opinion, it's not a bad idea, not always, not necessarily. Two plain in natural task on stacks comes to mind. It's applying a stack and destroying a stack. And it's a task, be it operated, done by a human or whatever pipeline, it's a task which has to be performed. And of course, there is also a lot of tasks which can make individual subtasks of more larger one about assembling, testing, and debugging components and stacks. When you are pursuing these activities, you, instead of always remembering what to do, you just codify your task to gain time. So I believe it's not really ClearOps, it's tools to compose our code. Of course, task-oriented tools exist for a long time. There's Make, of course. I love Make. Anyway, there is modern ones, too, just to name a few there. And the idea was to introduce yet another one, which I call typical for task and Pickle. It has a small set of features. The first one is it provides a Pickle module which allow you to describe tasks and commands with some syntactic sugar. It can obviously execute tasks and commands, leveraging a great package which allow you to interpret shell scripts in your without forking. And of course, it can fork exec any kind of commands, including, if you want, your favorite interpreter, be it a shell or not. It provides an external resource reader in the sense of Pickle, using the Valves package, which is a Swiss Army knife to access a treasure trove of external resources, mostly secrets. With Valves, you can, using pseudo URL, access secrets in systems like HashiCorp Vault or your KMS from your cloud platform or whatever. Here you see a simple example using the read function of Pickle. We access through this external resource reader a simple KV secret on a HashiCorp Vault. Typical also define allows you to define introduce temporary files while executing tasks and environment variable. This is a simple and straightforward way to configure your task with data you can extract directly from your configuration data, which is in typical module. And it's a command line tool. It has a set of commands to inspect the provided embedded module. It can, of course, evaluate, just like the pickle command, a module, but with the typical specific external module already activated. It allows you to list the task defined in a pickle module, and it, of course, it allows you to execute the task defined in the module. How do you use it? How do you install it? You first have to install pickle, then you have to install typical. It's 2 binaries, pretty easy to do. And of course, you read the file manual, not the one of pickle. This one, it does exist. Typical that does not have manual for now. For now, you have to use the source to see how to use it, or please show to a question, ask me, contact me. Anyway, I will work on some documentation, hopefully soon. A simple hello world in typical is quite easy. It's a simple module importing the embedded one called typical. It has a schema, and here a simple hello task, which uses the embedded shell in typical, which allow you to execute a simple echo. Nothing too fancy here. Whoa, I'm really speed. Future works include, of course, a bit of documentation. There is also an upcoming PR on the Pickle source about a Pickle 1 CLI framework, which seems very promising. Maybe in its current form, typical may become obsolete with the adoption of this CLI framework, and that's cool. But for me, the most important task will be to resist adding too much feature in this simple tool. Some reference about what makes this possible and what was the inspiration. Of course, there is this book by Keith Morris about infrastructure of code. There is a Pickle website, of course. The Atmos tools on Claude Policy also was a great inspiration in thinking about how to organize our tasks around stacks. There is a Val library, and there is a GitHub repository where you will find the typical code source. And I was really quick. That's all. I'm available for questions if there is any. Thank you.
What has been your main point of friction or missing thing or about adopting pickle products?
Sorry, could you come again? About?
What was your main?
Yeah, got it.
What was your main point of friction or missing feature or thing in pickle that hindered adoption of pickle for this sort of work?
Sorry, I'm trying to turn it on again, and I'm not succeeding. I should not I've turned it off. Ooh. So the question was there something missing in Pickle that urged me to write this simple tool? Honestly, nothing. It's just that there is no common executor in Pickle right now, and that was not the original purpose. Only very recently, a colleague of yours introduced this ClearRun, this Pickle Run framework, and as I said, it's very promising. But for me, the his to scratch was really to have a simple tool to be able to run any kind of command with direct and simple access to my configuration data. So instead of evaluating a Pickle module or whatever format of your configuration, instead of picking your configuration to determine which kind of argument you need to use to run this command or to fine-tune all your tool, your IC tool, be it Terraform, whatever is launched, be it for exploration, troubleshooting, or regular applying. That was the main urge, to have the possibility to easily access to the configuration data to construct action. That's all. So if something was missing, it was this. That's all. But perhaps it will come out. Welcome. Yeah, please.
Can you model dependencies or data flow between tasks?
That's a good question. Actually, right now, you can only call a task and call another task. That's all. And I admit that I am resisting the urge to introduce any other kind of dependency in the task because I really want to keep it simple. So that's the only thing you can do, a task and call another task. That's all. And well, thank you very much, and have a good afternoon.
Okay, so that's probably like half the room. There's probably a joke to be made about, you know, the kind of people that this type of game attracts, but, you know, let's get started. Quick intros before we start. I'm David Moreau-Simard. I'm currently an architect at OVH Cloud. I'm nearing 2 decades of various work in IT, sysadmin, DevOps, necessary kind of things. I automate a lot of things at work, but at home too. You know, I run a home lab with a home assistant and that kind of stuff. And I've played a wide range of automation games. Steam says about 2,000 hours. I'm still a noob, but I enjoy it. I have a great time. If you want to reach out, I'm a Mastodon. And Greg, you can go.
Yes, my name's Greg. You might remember me from such shows as Foreman, Ansible, Fedora, CentOS, and a million other things. But right now I'm a sysadmin at Fedora and CentOS, and I also quite like automating things and working for a large number of years in open source. In particular, one game, although I can confirm from my stats that all the others are over hundreds of hours as well. But in particular, we'll talk about Oni a bit later on. But that is a screenshot from Steam. I am not making that up.
Yep. Before we begin, a quick disclaimer. It's really easy to spend hundreds or thousands of hours in any of those individual games. Building or fixing just one more thing. Just, like in Civilization, one more turn, and, it's 4 a.m. in the morning, and you got to wake up in 2 hours for work. We don't want you getting fired for your job, getting a divorce. Play responsibly. Do with this information what you will, but it will not be your fault. Thank you.
So we're just going to set the stage here for those of you who haven't seen these kind of games before. You don't need to watch this video too closely. We're going to talk over it, but yeah, don't be too distracted.
Yeah. So this is a quick time lapse from tutorial. Just setting up the stage. So we all have constraints in system and software engineering. We have time, resources, budget. How we deal with those constraints in various interesting ways can lead to things like technical debt. Life is a series of compromises and trade-offs. So we will go over some of those themes together, walk through some examples from these games, and see how that turns out. So,
and not just constraints, right? We like to prototype, we like to debug, we like to learn how new things work. These games can help us with those skills as well.
Yeah, and Greg and I have been playing some of those games together for the past couple of years. And there's always, we're playing together, and there's these themes that come back. Oh, let's leave that in the backlog, and we'll fix it later.
Next sprint.
Yeah. So we've been wanting to talk about this for a while, and I'm really excited to get into it.
Yeah, we have 2 week sprints because we play together every 2 weeks.
Yes, 2 week sprints. Yeah, exactly. Great fun.
So I'm going to talk this first one through. This is a different game. It's called Dyson Sphere Program. It's a very pretty game. But this is our first steps in automation, right? You can see my character here is mining iron ore by hand because we've all got to start somewhere. We've got to spin up our first cloud server or buy our Raspberry Pi. And we are going to have to do something with those materials, right? So we are going to start with automation. So I'm going to say, well, I don't really want to do that by hand. So I'm going to create my first mine. And I'm going to put that material on a nice little belt here. And that's going to go running off somewhere else. And these are our first steps, right? These are our very first things. That's that first Ansible -m ping, right? It's going to be a first try to get things going. But we get a little further, right? We think, well, okay, the ping was nice, but we'd like a playbook, right? But first I'm going to write the playbook, so I'm going to make some smelters here by hand in my backpack, like an animal. And then I'm going to put them down, right? So here I am, I'm waiting for them to get built. You can see it's taking a little while. I probably should have sped that bit up. Oh, I did, good. And now I'm going to put them down, right? But I've got automation already. I know I can click and drag in this game, so I don't have to put each one down by hand. And then I'm going to wire them up to the iron ore, and then I'm going to put some inserters. Well, Factorio calls them inserters, DSP calls them sorters. We could have consistent naming. We could have a whole talk about consistent naming. But in any case, I'm going to put something that loads the iron into the smelters. I'm going to put an output belt, and the iron's going to come out of it. This is our first playbook, right? This is our first manifest. And you can see I already learned a little bit. I'm copying one of those smelters, and I'm putting the sorters on all of them with a quick click and drag, apart from the last one where the belt wasn't built yet. And then, very much at the end of the process, I'm going to put that iron somewhere, right? So in a later game, it would go off to be consumed, but here I'm just going to put it in a box. Literally, if I could have had a fence to throw it over, I would have done that just for the joke, but doesn't exist in DSP. But this is our very first automation, right? Our very first playbook, just getting that first pipeline going.
Yeah, and the general idea is that you could be building those iron plates by hand, but as one single person, one human, you don't scale. So you need machines to automate your workflows, and eventually you want to automate the things that automate your things, so you have more time to automate more things.
Right, so let's get into that automation, right? We don't scale. This is yet another game. It's called Shapes. Let's get into that. I'm going to build here a mining platform by hand. And I know how to play this game, so I know that I can click and drag things. We've done a bit of that, but I'm still doing it by hand, right? I'm going to put down the mines, there they go, and now I'm going to build the belts by hand. This is me writing my configuration file, right? I'm going to do it all by hand, and it's going to take me about 45 seconds to actually finish this thing off, right? So you can see I'm almost done, here it comes, we're almost there. That took me a little while to do, not very long, because I know what I'm doing. And there we go, we got our output, it goes off to some other part of the factory. Great. I've prototyped, right? I've built the thing by hand, I've understood how it goes together. But now we want to do that more reliably, more repeatably, right? We want to scale it, because we don't scale. And now you've gone too far. Yeah, there we go. So here's the exact same process, but now I have a blueprint. And these games pretty much all have blueprints in at some point. So now I've copied that thing, right? So I can drag it, and okay, Shapes won't let you do the blueprinting of the...
Copy-paste, amazing.
But I copy-paste it, right? And then I put the belts in, and now I'm done. So now I've put 3 times the output in about half the time. We don't scale, automation does scale. It allows you to practice those things.
Yeah, we've just scaled horizontally or mining. We have more resources so that we can automate more things. And yeah. So there's different ways to organize your factories, There's no real wrong way. Here, what will look like, this is in Factorio. We are walking down what is typically known as a main bus. So you send your iron, your copper down a principal area, and then you fork out these resources to build components off of the side. So you can build green circuits, red circuits, and then these green and red circuits get used later on. So this is really like a supply chain that you build iteratively over time. And so this is main bus. It works, and it's a fairly easy way to keep your factory tidy without too much spaghetti and things going every which way. Well, it doesn't mean that doing spaghetti is wrong, but we'll talk about that a little bit later.
Yeah, that has its moment. But you can saturate this thing. You can saturate your network links, right? You can have a throughput problem.
Yes, just like in system and software engineering, there's a number of compromises and trade-offs. Like this main bus design. If somewhere in the factory I consume too much iron, I don't have enough bandwidth. I don't have enough throughput. I could have add one more belt that will help. Eventually, I will need more iron because you always need more iron. There's different ways to do factories. So here we have a factorial mod called Factorissimo that allows you to build inside factories. And you can build factories inside factories inside factories. So just kind of like containers or packages, here I have factories that take input, clear interfaces. It takes an input and it gives an output. And then I even have trucks that take care of delivering and shipping resources all around. So I don't need to do complicated things. And if I need more of something, I can just copy paste this, just like a Docker container or anything like that. And then I will have more circuits, more iron. I just need to make sure that it's supplied with raw resources. But that's another way to package your factory. So earlier I was talking about different trade-offs like latency, bandwidth, performance, volume, right? So this is another game called Captain of Industry. It has a lot of trucks, lots of different kind of trucks. You can still carry stuff by belt. You can carry stuff by trucks. You can carry stuff by trains, and even by boats. So you can choose to bring resources from elsewhere, just like you could outsource some part of your processes to a software as a service company.
Coal as a service.
Yes. Yeah, so bring me some oil from this remote drilling rig, right? So it's really interesting to see how people come up with different solutions to different problems. But at the end of the day, it teaches you to make informed decisions based on how much of something I need, how far is it away, how much do I need? Is it okay to carry it by small truck? Maybe if I need a lot of it, I need to build a train. But then you need a train network. And it kind of rabbit holes down from there.
It's also a time-related thing as well, right? Because you might need that thing right now. Yes. And it might be awkward to get it by ship, but at least you can get it right now.
You can take shortcuts, technical debt, and can fix it later.
It's not the only thing we can practice with these games. We can also look at monitoring and observability. So here we have another round of Dyson Sphere program, and what you're seeing right now is me just playing the game. And what I haven't noticed yet, that me playing the game hasn't noticed yet, is that a little hydrogen icon has appeared just here at the top of the screen. I don't think I have a mouse cursor. Oh wait, yes I do. You can see it just here. And so I'm about to notice that and go, wait, what? And in a minute I will turn around and go, hang on a minute, something's going on here, and I need to go and check it out. So this is my monitoring sending me alerts, right? And I should probably pay more attention to my... Oh, there I go. I just noticed. You can see me putting my mouse over it, getting a little indicator where to go, because, I'm inside my program, right? So I get to actually walk to where the problem is. But I'm going to look. I've got an alert of monitoring telling me there's a problem. Let's go and investigate. Sure enough, there's nothing on this belt. What's going on here? And I can have a look, right? I can say, well, sure, yes, there's no hydrogen. That's odd. And there's none on the belt. Sure, I'm tracing the problem, right? I'm doing my log analysis. I'm doing my code tracing. There's nothing in the tank. What's going on here? I go
Lots
back
of troubleshooting to be done.
Right, yeah, I'm going back further. Now I'm like, okay, let me just double check this. And sure enough, I go and look at my statistics, right? My Grafana dashboard. And here's my hydrogen production. Oh, it stopped about 7 minutes ago. What's going on there? It was fine, and then it just stopped. That's odd. That doesn't seem like a supply problem, or not at all, right? I look at my refineries. Oh, wait a minute, there's no crude oil here. Well, sure enough, the crude oil belt seems to be empty. Ah, here we go.
The belt was broken.
Somebody broke the belt. Can't imagine how that happened. But yes, and now I've fixed my problem, right? And so I can see the oil coming back in, and the hydrogen's going to start flowing again very slowly. This is a real problem in DSP. But this is monitoring and observability, right? This is me taking steps ahead of time and saying, I need to know if this thing stops. That's a skill we need, right, in the work we do, and you can do it in these games as well.
Yeah, and different games have different approaches to it, but you can set up monitoring to be alerted when you're low on resources somewhere, or maybe your storage is full. So just a bit like you would do monitoring with Prometheus or other kind of software. You can set up things such that because once you reach a certain scale, we were talking about scalability earlier. You cannot keep an eye on all the parts of your factory all the time. You need ways to help you with that, so you have the tools and you use them. Here I will talk a little bit about security, because of course there's security in these games. I was trying to find a good example. This is what I came up with. So for those who have not played Factorial before, what we're looking at now is here there's some biter nests. So biters in Factorial are like the monsters that are we the monsters in Factorial? They're trying to defend the planet. Are we the baddies? I don't know, but anyway. So this is kind of like breeding biters, basically, and it's used for technology. But the idea here is that if an accident happens, one of those biters could make it out and start, clawing at your base. So you can see here on either side, I have some guns. I have some ammo prepared in case an accident happens. So that if a biter does come out, it doesn't destroy my base. But I have, just like in security, you do security in depth in different layers. You can see I've built this on an island, so that if a biter does come out and somehow my turrets fail, I ran out of ammo or anything like that, well, at least they'll be stuck on this island because, well, they cannot fly or swim. So just a little bit like you would have a database server. You would not put it on the public internet. You would put it on a private network with firewalls and different measures to protect your stuff.
I mean, it looks a lot like a DMZ to me, right?
Yeah, like a DMZ. You don't want stuff. You control what gets in, what gets out.
So technical debt's a whole thing. I have a talk about this later, by the way.
We could have spent 25 minutes talking about any of those teams.
Quick plug there. But anyway, you'd love a factory like this. So this is Satisfactory, a game in first person which leads to spaghetti like none other. But you saw the main bus there as I flew over it, and I've got nice clean layouts of my iron ore into the smelters there.
It's not so bad, right?
It's pretty good, right? Well, yeah. So belts at angles, things unsupported, and belts coming out of all different directions. And why is it like this? It's because we were building this massive thing here and that massive thing over there. We were prototyping. We were trying to figure out how this thing works, what materials it needs, how much of those materials does it need, and how much of its output do we need. But here's the problem. We never rebuilt it. If you didn't notice it, it's very subtle, it went past very fast, but there's another floor of this factory above this thing. We built on top of it. That wasn't a good idea, but it was what we did, right? We took a decision. Well, we didn't take a decision, we mostly ignored the problem. But that's how technical debt happens, right? And if we wanted to scale this thing, there's no space to do it. There's no room left on those belts, right? We get massive technical debt here. So you can get some practice in your refactoring and in figuring out, like, and also experience in making those trade-offs and knowing when you should not do that, or when you should.
And you know, I've made peace. I was able to make peace with. I used to be very perfectionist. You know, tried to do everything right the first time around. But you know, you don't always have the experience. You don't always know. You don't always have the technology. You don't always have the tools. And so I learned to just embrace the spaghetti, make things work, and then make it better, and then make it pretty if you want. And yeah.
I mean, you can take it too far, right?
Yeah. So this is a great video series by a YouTuber called Let's Game It Out. You can take a picture. There's a QR code to a playlist of one of his satisfactory playthrough. He has a great fun going far and beyond what these games were originally intended to be. It is like terrible on purpose, but it's also great fun and entertainment.
I particularly love this bit here. I have no idea why this belt goes around like this.
Yes.
It's like completely pointless.
And this is like a tower of belts for some reason. Anyway, it's great fun. I highly recommend it. So what we've just looked at, or it could be like Jira labels or GitHub issue labels. Those are all things that you get to practice in these kind of games. Troubleshooting, monitoring, planning, or managing expectations, right? Automation, scalability, the limits of what you can do on your own without tools, automation, and factories. But also, how to package the things such that you have, clear input, clear outputs, and all of those other things. Not without forgetting, managing risks and security.
So we've gone fairly fast. I prepared some extra material just in case. One game we've not talked about yet is Oxygen Not Included. I said I have 2,500 hours in that game. I might be AFKing some of that, but still, it's a lot. Oni is a bit different to the other games we've shown off, and it's very hard to make small clips of Oni that really make sense. If any of those did make sense to you, I hope they did. But in this game, what Oni really excels at and why I love playing it so much is it's extremely good at the prototyping part and playing around. It's got a detailed physics engine and a detailed logic engine, and I just love building crazy Rube Goldberg things in it and seeing if they work. So this here is me building a volcano power plant. So what's happening here? Lava in the top left. Dropping down into a room full of steam, heats the steam up, steam goes into the steam turbine, makes power, right? But immediately I'm starting to practice some of those skills again. I've got constraints here. We have a power system in Oni. These wires can burn out. They have maximum ratings. And so I have to make sure that I don't overload these lines, that I'm actually doing things in a sensible way. There's a whole fluid system. So you can see I've got pipes down here in the bottom left running water around, but also you have pipes for gas. There are conveyor belts as well. And then, as I mentioned, a very detailed automation system. This is the thing that makes the lava doors work. So you can see if I go full circle back up here, there's a little system that decides when to drop more lava into the room. I can tell you it took a few iterations to get that right, and I melted my base more than once. But that's the point, right? We're prototyping, we're iterating, we're practicing, and we're thinking things through logically. It's a really, really useful set of skills. And if you do like that side of things, I highly recommend checking it out. The other thing we haven't really talked about, again, because the video would be very long, is refactoring, right? Refactoring can take a while. You saw some of the tech debt examples earlier on in the talk. It can be something that you have to really think about, right? You have to think, well, okay, I learned something from the prototyping stage, but now I have to tear this whole thing down and build it again. And in some cases, it's because you built it wrong the first time. And in some cases, it's because new technology has come out that makes it interesting to redo. That's what's happening here. Up here in the top left, you can see my oil refinery. It's a slightly different format, but basically the same thing as the video earlier. So oil comes in, hydrogen comes out. But then I get a technology that allows me to multiply that hydrogen, right? So I want to go from 6 refineries doing hydrogen to 3 refineries doing hydrogen and 3 multiplying that hydrogen. And so you can see I'm tearing it down. In this screenshot here, I've taken out most of the belts so I can try and figure out how I'm going to route this. In this screenshot, you can see a whole like in-game day has gone by at this point because it's gone back to being bright. And I'm still sat here going, okay, wait a minute, if I run it this way, then I can do, I don't know, maybe this will work, put the belt in. I had about 400 hydrogen in my inventory at this point from the number of belts I'd deleted. And then finally here, I got the final thing working and it's all up and running. And again, another whole day has gone past. It's a really good set of skills. It took me about 20 minutes to run through that, and I've got some idea what I'm doing in DSP. So it's good to practice these skills. It's good to practice thinking things through, right? Logically, inputs, outputs, logical structure. How scalable is this? Could I copy that and put it down again? Maybe.
Yeah, and you know, this is something that could not have been possible at the beginning of the game because Greg did not have the technology to do that. So you know, research technology, get better at it, and then you can do better the next time you come around. So, you know, I really love this XKCD. It's, you know, is it worth it to automate your stuff? Not all the time, right? You need to find out how many times do I need to run this, how many servers. If you need to, I don't know, automate something that runs once a day on a server, you might set up a cron. If you need to scale it up to 1,000 servers, you might need something better and more convoluted, right? But depending on how much time you save, how much time you spend, you know, if you're doing things manually, you want to be more efficient, automate your things so that you have more time to automate more things. But you know, you have to ask yourself the question: is it worth it? And you know, exercising with these games gets you some amount of experience and dealing with that.
I think it goes back to that perfectionist point you made earlier, right? It's not always worth being a perfectionist about these things. Does it actually save you any time?
Yeah, I mean, you could spend so much more time before then, and then find out later that you have a new technology that makes things so much easier. So was it worth it to spend all this time early on? You know, it's something that you learn with experience.
This might be why we have hundreds of hours in these games, however.
Yep. So I want to quickly, before we wrap up, I want to link to some of resources because so there's the Factorio blog and the Captain of Industry blog, notably. So there's a lot of amazing engineering that goes into these games, right? They feel like games by engineers for engineers. They have a lot of complicated math to scale up to, you know, mega bases across different planets with millions of items going every which way. So there's a lot of interesting tech, and on these blogs, you will find some of those, how they do it, and it's just amazing engineering.
Yeah, we're not the only ones who think this either. There's quite a few resources out there. We picked a couple for you here. In particular, I really enjoy the interview article about how Factorio is a good interview. And I would probably agree, although it's quite a long interview. I think our last game got to about 70 hours before we got bored. But I take the point, right? It's interesting insight into how people think because we build our factories in different ways, right? And so looking at what comes out of that process can be a very interesting thing to look at.
Yeah, you know, I think I think it's very interesting what you could learn from someone just from looking at how they build things, just like how they build software. What do they care about? What do they spend time about? And where do they choose their compromises and trade-offs? This is all interesting. It's not like there's no one good, perfect way to do things. So it's really interesting. I have 2,000 hours and I keep learning new stuff. So it's always interesting to see how people do things. That is it. The factory must grow. Thank you for watching. And once again, play responsibly.
The player base must grow.
We have maybe a minute or two for questions, but otherwise, you know, we'll be there. Feel free to reach out.
You have time. I'm just,
yes.
I'll get set up.
Yeah, sure.
Is sushi okay?
Is sushi okay? Yes. I actually do a thing called sushi belts in a couple of the games I play. In fact, that refactoring of the hydrogen processing I showed in DSP has what I call a sushi belt because the second round of refineries need to input and output hydrogen, so I put them onto the same belt. There's also a place in Factorio called Gleba that uses a lot of what's called nutrients which rot, and so I use a sushi belt for that as well.
Yeah, you know, a sushi belt is an interesting way to solve particular problems. You know, sometimes you have, this is mine.
Oh, okay, fair.
Sometimes you have space constraints. You cannot like build all over the place, and sushi belt might be a good, you know, way to work around that. Any other questions? Yes.
From what I understand, I've seen you taking practices and skills into the game. How well do you think it works the other way around? Can I take, I don't know, a kid, have them play those games, and then learn those skills and transfer them out there into real world skills?
Do you want to repeat the question?
So the question is, how well do skills transfer out of the games into the real world for people who perhaps haven't done engineering before? I would say they transfer fine. I think it goes both ways. I definitely would expect people who have done a reasonable amount of hours in these games to have realized that they need to think more carefully about certain things.
Yeah. It practices like critical thinking and learning how to iterate, make things better, make things prettier. But also, as a teenager or a kid, they might care about different things. They might be more about making things prettier or things like this. So again, there's no wrong way. And it tends to attract the software engineering crowd. For me, it doesn't feel like work, not yet anyway. But maybe it can help a future software system engineer.
I think if someone came to me, if I was on an interview panel and they said they played a lot of Factorio, I'd want to ask questions for sure. In the same way that World of Warcraft is management experience, right?
Yes.
We got.
Yeah, any more? That feels like all the questions. Thank you so much, everyone.
Oh, we got one
maybe
more?
One more.
How do you manage a large team in one Factorio server, let's say? Like 50 people.
Yes.
I'm not sure if we could get 50 people into. So how would we manage a large team in Factorio, say 50 people? I don't know that it supports 50 people.
Oh, yes,
tried.
it does.
Oh, it does? Okay, fine. We managed 2, and that worked quite well. But I think again, it's going to be practice in delegation, right? You go and manage this. You go deal with this. I'm going to handle the oil factory. I always do oil.
It's also like teamwork, right? Like Greg and I, we care about different things, and we have different strengths and weaknesses. But because of this, we work together to a better effect because we complete each other, right? So if you scale it up to 50 people, like an SRE organization, it's actually a really good idea to do this at work. Like let's do a Factorio thing. I've done it before. It's great fun.
I think if I take it to Satisfactory, actually, we had a really good experience working on our different priorities there because I like the prototyping and I like the exploring, and you like making things scale.
Yeah.
So I would get the first thing up and running, and then while you're building it out, I would go and find us some new resources to mine.
Thank you, everyone.
Thank you.
I don't know if we need to actually close it.
hop and rap, so. Closer, you'll see the demos a lot clearer. And if you want to ask questions, I can actually hear your questions. So like if you're beyond the second half, I probably won't be able to hear your demos. So. He's like, what? Go. Hi, everyone. How's everyone doing? Thank you for coming. I'm James. Has anyone ever seen one of my talks before? Yes. Some people want fireballs, so I've got fireballs for you to wake up and see the fire. Just a little quick hello. If you don't know me, grab a seat. Don't be shy. I'm going to be sitting here to type, so just so much easier to sit and just get going. It's going to be more fun for live demoing. So I'm hacker, config management. Who's seen my blog, anyone? Just raise your hand. If you haven't, just raise your hand so I seem really popular. It's like my canned joke. Yes. My background's in physiology. So, I got into computing kind of as a side thing, and here we are. DevOps believer, although I don't see that many people are kind of following the mantra. And as of recently, I'm actually a business owner, if you can believe it. So we're going to talk about that. I've started a company called M9RX. It's a legal entity since about 8 months. And so basically, it is just an avenue to actually fund and support this MGMT project, which some of you have heard about. In September, we passed version 1.0. So it's basically my official stamp that I've been using this on real customer hardware, and people are happy, and it's not killing kittens or whatever. So really in production, and kind of every day is just for me about polish and adding more things and more capabilities. And I think soon, and already in some areas, we're going to totally surpass Terraform and Ansible and Puppet and all these legacy tools. So hopefully I can convince you of that today, and then you'll see the kind of capabilities that you can have. And because, you know, I want really good infrastructure. That's why we're here. I want an elegant future, and I want you to be part of this elegant future with me as well. MGMT is the software. This is kind of my funny thing. I guess slowly more and more of these tools are dropping off the list, but gonna see what we can do today. Just some quick background. I like doing demos, and who has not seen any demos of MGMT? Just raise your hand. Oh goodness. So we're gonna do, like, this is really gonna be the hard mode demo. First demo, just for fun. We have a documentation site. Look at that. It sounds dumb, but it's probably one of the most important demos. It's not perfect. I'm doing as much as I can with limited funding and trying to keep things open source and not proprietary. But you know, we have a big resource reference. So all the resources you have in MGMT, they're all listed here. All the functions that we have, they're all listed here. There's quite a lot, because if you notice all these ones that are prefixed with Golang, we import the whole Golang standard library, or most of it. So you get all those for free, plus all sorts of built-in ones and special ones and so on. And we have a user guide just to get you going. So that's also not perfect, but it'll get you some part of the way. If you've used Puppet, this will just feel really natural and better to you, I think, or I hope. So have a look at this. And if you're good at doc writing and you want to help out, we'd love your contribution. So yeah, is that a good demo? Snore. I know it's kind of boring. So I'll show you just some basic stuff. Basically, I've got a big feature branch, but is that big enough? Can you see that? How about that? Yeah. So basically, the rough idea in MGMT is you have you know, some resource, you know, hello world, hello config management camp, or whatever you want, and you save that, and then you can just run MGMT. I'll just run it in this local mode, and it'll run, and really quickly you can see that hopefully it created that file, right? So this is the declarative thing that we're used to. And the special thing about MGMT is it doesn't just shut down like Puppet or Ansible or anything like that. If you delete the file, it notices and the file comes right back. This is the classic demo I've done since basically day one. And it's so fast that you can remove the file, oops. Oh my goodness, remove and cat the file over here. And even before the second part of the ampersand runs, the file will come back. And the extreme thing, you can even just run it in a for loop. The watch command, if you don't know, just pulls some command over and over and over again really fast. And you can see, look how fast MGMT starts up and always just fixes the state. Make sense? Cool? We want to go fast, like rocket ship fast. A quick little demo you might have noticed. I hit Control-C, and what happened? It shut down under a second. I've actually put a lot of time to making it shut down when you ask. So if it takes more than 1 second to shut down, it's a bug. So let me know. But it's super fast even at shutdown, so you can move on to fast things. Second kind of demo, just to show you a little bit more, because we're going to build on this. This is same kind of thing. We have these functions, and functions in the language are streams. So datetime.now is a fancy stream which returns basically the time of day in seconds in the Unix time way, which is an integer that, you know, counts forever. And every time this updates, the dependent variable updates, and every time this updates, that's right over here, it's being used in this template, which goes into this file, and the file can detect when it needs to update. We do some fancy compiler graph optimization stuff. And if we run this example over here, and then I think it makes a folder. Oh yeah, there's some other stuff in here from my other demos. So you can actually just do this watch again. We'll just cat what's in this folder, and you'll see that the actual contents of this file right here are changing every second. Right? That stream propagates through, and it knows when to reevaluate the world. And if I kill it, hi folks, don't bump those cables. They are delicate. We have a, oops, something not working. You want to charge your laptop? Kris, come on. Yeah. I'm in a demo. Really? Yeah.
I mean, you're touching a file. It's the same demo we've been giving for the past 10 years.
Because a lot of people haven't seen it. So same sort of thing. This is a slightly different. This is a slightly different example with system load, and you can see that that flows through as well. And as you run this over here, you can see the system load change as well. Okay, please, Kris. You're distracting me. This is our conference chair, everyone. So if you interrupt Adam's talk also, then I would be okay. I'm saying you have to interrupt Adam's talk also. Anyways, so that's the basic rough point of it, right? So the whole language knows when to recompile and efficiently flows data through the graph. Does that make sense? I got a little distracted there, sorry. But so that's the rough idea. And so we can actually build fancy things with these primitives. I haven't always had all the resources and pieces to build these fancy programs, but I'm going to show you a bit of code, and I think you'll find it interesting. So let's just kill this over here. So what I'm going to show you now, if I can find it, is some code. So the first bit of the code, I've commented this out because we don't really need it today, but what it does is this small amount of code which is commented out, I have a virtual machine resource. The key part over here is the MCL code runs on all of the different machines. They'll cluster together so that they can communicate. And this loop here is going to start up 3 VMs. So test 1, 2, and 3. I've already pre-provisioned these machines. I just took it out so we didn't have to focus on it. And then the fun part of this demo is if we are on one of those host names, so if we're on test 1, 2, and 3, we're going to just include this rolling class. And let's look at what this actually does. The rolling class here takes some values, so max and a namespace. In this case, I just gave it the word rolling, but you could name this like job1 or anything you want. And what we do is we read in a value called just an integer from a text file. So this is the idea of this demo is, let's say you have a fleet of machines and you want to roll some change through the fleet in an organized manner. Think of like a distributed state machine. So the idea is you might want to have 100 machines, take 2 of those machines arbitrarily at random from the pool, stop some service, upgrade a package, run some command, start the service up again, and then put them back into production. And then once those are healthy again, go through to the next 2 and so on, one at a time. Does that sort of thing sound familiar to some of you? Don't be shy, yeah? I'm not making this up. But so we want to do this. A lot of times you have to use custom tools, and they're very complicated. They're often centralized orchestrators. So we can run this as a true distributed system. So there's no machine in the cluster that you can kill that breaks the system. It's not an orchestrator. Some people call this choreography, but yeah. Now, I don't want to do installing packages because it's a bit slower, and I want you to see really the demo specifics. So instead of having an actual package that we upgrade, I'm just having a fake package, and the version number is stored in this file, just as an arbitrary way to show this working. So this basically just reads data in from that file, which is on each machine. And then the second thing is we have this etcd cluster that supports MGMT, and we're storing in this what we call the desired value. So the version of the package might be 4, and I want it to be number 5 or 6 or whatever. And so if we look over here, we have these 3 machines, 1, 2, 3 here on the right, and this is the cluster itself. And I actually have MGMT writing all these values out to a text file, and I'm polling that text file so you can see what's happening on each machine. Does that make sense? So it turns out the actual version on this one is 3, and the desired version is 3, and that's the case on all of these. Okay? Good so far? Okay. I want to go through it slowly. So now here's the actual code. This whole code, it's 100 lines of MCL. We have a block here that says, is the actual version the same as the desired? Okay? You could do less than, but in this case, let's just do different so you could go forwards and backwards. And then what we do here is we have this world function. This is a system package that you'll see all the way up at the top. And what world does is it looks at an election that happens on all of the machines. And each machine with MCL code and resources can opt in to being part of the elected set or not. So each machine is basically putting their name into a hat, and the distributed choreography machine is going to choose 1 or 2 out of those machines at a time. And so it does that. And again, when this value changes, this set variable, it's a stream. So we'll receive the first version of the election as a stream, a list of chosen, the next list of chosen, and so on as time goes by, as things happen. And then basically the simple thing is if that set, if this host name is in that set, we have a Boolean which is I am scheduled or not scheduled. Does that make sense? So if you have a set and 2 hosts are chosen, if my host name is in that set, I know it's my turn to act. And so then if we're scheduled, what do? Well, we just, here this is a package resource, we could just update the package, but again for the demo, I'm just updating the version number in that file, simulating a package update. And then I have this command here called timestamp, and all this is to do is going to echo the time that this exec runs, this exec resource. It's going to echo the time. It's going to sleep for 10 seconds to simulate, doing some work. Obviously, it could be starting, stopping a service, whatever. And then at the end, it's going to echo the time again. Okay? And then the last thing is if it's scheduled, after it's done that, we run a withdraw. So we tell the scheduler, I'm a host, I did my thing, I don't want to be part of this set anymore. And so that's this block here. Otherwise, if we're not in that block, we actually have the schedule resource say, yes, please add me to the scheduling block. Max number of hosts, a TTL of 10 seconds, if a host goes missing, and you can pick the scheduler. There's round robin, alpha scheduler, any kind of scheduler you want. Does that make sense? So you'll see it happen in a sec. So here's all that information. On each machine, they're printing the scheduled set. So you can see the set is empty. Nobody is scheduled on each of those machines. And you can see the start and end times of the last time I ran this demo, which was just before. This is Canada time, not whatever. So you want to see this? Yeah. OK. So what we're going to do is this is etcd cluster right here on the left. And so we can put a different version number like this. And I think this demo is running properly. Let's see. So I put vor, and you see immediately it switches to 4 desired. OK? And you can see that each one has also chosen test 1 just arbitrarily. It did the thing start and now it voted for test 2. And you can see the timer started again. It waits for 10 seconds, 19, 20. Oh, and now it picked test 3. And see, it went from actual to 4, 10 more seconds, and it should do that. Flips through, and then it's unscheduled. That went fast, right? You want to see that again? If you don't encourage me, I'm not going to show it to you again. You're going to have to be on the live stream. Do you want to see that again? Okay, so we'll watch again closely. Pick a number. 7. All right. So we're going to go to version 7. So think about what happens. The moment I just push a key into the etcd store, the desired value on each of these 3 machines, it's going to update right away. Because now, I know something's wrong. Or, excuse me, I know that the version number is not what I want. So each machine is separately going to put themselves into the scheduler saying, I want to be scheduled to fix this situation, right? They don't have to talk to each other. They just say, put my name into the hat. The scheduler will then update, again, really fast. It'll pick some host at random. I don't know what it's going to be this time. You'll see that choice made on each of those 3 hosts. And I've told the scheduler to pick 1 host at a time. I could do 2 at a time, doesn't matter. I only have 3 hosts, so it's easier to follow one. You'll see then the start timer start on whichever host does it first. It'll update the version from actual to the previous actual to the current actual, which is 7. It'll run for 10 seconds, and then it will take itself out of the scheduler, and you'll see that jump to a second machine and then a third machine. Ready? Tell me when to press go. OK, so you see 7. This time it chose 3 down here at the bottom. You can see it started. The system clock is right up here, if you're curious. OK, 6, and should be done in a second. Done, finished. Now it chose test 1. So over here, this one's starting. You can see it ended at 16, and literally exactly the same second, right? This is like millisecond fast, 100 millisecond latency of the scheduler. Over here, now it jumped to test 2, boop, and it's going all the way through. And it should be done. And then, boom, takes it out of the scheduler. Is that cool? Yeah. Can we do better? Error handling is a great question. Ask me after. I'm going to show you something else first. And then the other cool thing you can do, so that's like 50 lines of MCL. And I can put that in the class, and that's just a package you use, right? You don't have to even write this you know, not even 50 lines of MCL. But if you want something custom, it's easy to do it. Another thing that I did, by the way, this is here at the bottom. You can see this. This is me, that status file that I'm pulling just to show this demo. It just takes those values because all those values are streams and they just flow through the graph. The second cool part of this demo is we have an HTTP server resource in MGMT. In contrast with all the kind of legacy automation tools, we have our resource model. These are living, breathing, moving, dynamic things that can interact with the world. And they can even act as HTTP servers and start up an HTTP server. And the HTTP server does this fancy thing called automatic grouping. It groups an HTTP server UI resource. Again, this is all part of core MGMT. And also HTTP server UI input. And all these, you can look through this code later if you want, but basically all it's doing is it's taking, reading a value from etcd, that same value I was just poking at manually, and putting it into a form. And also, if I find that form, here it is. This is that form right here. Just refresh this, show you it's live. This is tunneling to test 2, but this same web UI exists on all of the machines. And so now we get a slider. So if I go, I can actually just see this is at 7. It goes from 0 to 10 just arbitrarily. Let's put it over here somewhere. So I put it to 2. You see now desired is 2. Boop, boop. And now it's running that whole scheduling roll through process again. So it's picked test 2. That's running for 10 seconds. Boop. Now it goes test 1. Now it's running over here. 38. If you look at the clock, watch when it gets to 48. 5, 6, 7, 8. Boom. Finishes. And now it's doing test 3. All right? And all of this, I've built a whole user interface, a whole system for deploying whatever you want in 100 and 200 lines of MCL. Not even. Is that cool?
Can you change the version number twice quickly?
Yes. I'm going to show you something different instead. Remember I told you that web UI was tunneling in, because this MCL code is running on each server, right? So I have that same data. This is down here. I'll just refresh this. This is just an SSH tunnel into the first VM. Oops. It's going over the internet. This is not even in North America. So the internet is a bit slow. Oh, there we go. So yeah, this is in North America. So excuse the latency. So this is test 1. This is test 2. If I go, I can click here or here. It doesn't matter. I click over here. You see that one updates. And now it's doing that same process again. Is that cool? And yeah, and so that's, MGMT is not Puppet. I call it config management because I think that's what it should be called. That's what the art for me is. But it is not Puppet config management. It is not Ansible type of thing. It's a new paradigm of building fancy, complicated distributed systems. There is no orchestrator here. This is no Ansible. This is no Terraform. If the Ansible machine or the Terraform machine that runs those jobs is down, you're in trouble. This does not have a central point of failure. So it's just this distributed algorithm that we built, and it kind of runs everywhere. So yeah. Any quick questions before I move on?
Can I store my attributes outside of etcd?
The question is what?
Can I store my attributes outside etcd and have them applied from Git?
Yeah, so you can, MGMT is just in some ways a stream engine, so you can read and write to and from streams from etcd and many other things. So if you wanted to use some other backend to read and write the data from, go right ahead. I might not have the backend written necessarily, but we have some sources and it's pretty easy to write new ones. So yeah, great question. Any other quick questions? Yeah, gentleman over there, scream.
Is this based on Raft or is it your own?
Yes, great question. So the backend that I'm using, so basically it does it almost exactly like Kubernetes. We have a cluster of something, in this case etcd, which is indeed based on Raft. And the compiler that I've built works out how to kind of work things out and do all of this complex. It's a great question. I can tell you more details. One important difference from Kubernetes, and again, we're not trying to be Kubernetes, is Kubernetes requires storing state in etcd. And you have to back up. Who's like using Kubernetes? Maybe? Who backs up their etcd database? Yeah, exactly. Almost no one. If you lose the etcd database, you're going to be in trouble and have a bad day. And no one backs it up. And what is the answer? The design of Kubernetes is wrong. This is not how you should be building your infrastructure, genuinely. None of the data in etcd that we use it for temporary coordination. It is not a stateful store of data. It's just a temporary store to coordinate. So we use it very sparingly because the MCL algorithm, the MCL compiler and the code, that works out all the fancy stuff. So if you nuke this etcd cluster and you just rerun MGMT everywhere, it'll have to regenerate some of the analysis it's done about choosing who gets scheduled and so on, but a second later you'll have everything back probably. Maybe a minute if you had something crazy huge, right? So this is been my research project to show how infrastructure should be built, and it's finally production ready, so it's been a while. You want to see some more demos? Oh, and by the way, tomorrow, Andrew, who is right there, wave, Andrew is going to give another demo showing a container scheduler that I built in MCL. So you got 100 some odd lines of MCL and you have a mini kind of Kubernetes. Similar to what Kris was building, but written in pure MCL without AI. And so this is really the point. You should think about MGMT and MCL as like a Python or a Golang, like a tool that you could use to write and build other tools, except it's very powerful and you can do it very quickly in a small amount of code. Whereas, how many lines of code would it take you to build this distributed rollout system? 10,000? Something fancier that's not centralized? 100,000? I don't know. Do you know?
I mean, we just use shells. We don't write any code.
Yeah, exactly. So you need to have something, and the beautiful thing is this system is the same as your config management system. It's the same as your provisioning system. It does everything all in one code base. So you can analyze and type check the whole life cycle of your infrastructure in one shot. So yeah. So next demo. Let's go back here. WireGuard. I can actually show another demo if you want. I just have to deploy this demo. So I have different code bases here. This is actually a different demo here. So, oops. I'm going to just build a new version of MGMT from the main branch. I had some special code in for the what's it called, demo. So I'm just pushing a new version of MGMT because I want to use a different version of the binary. The scheduler demo has some special magic in it that I haven't merged yet that I wanted to show today. So that's why that's going to push. And who's used WireGuard before? Everyone? I'm going to show you a WireGuard demo in a moment. I showed you this rolling state machines. Silly little demo here, but full lifecycle management of hardware. We actually can go over here. We have in the MGMT collection of resources, we have this firmware attributes resource. So anyone who has like been in IT who had to like onboard a new laptop, like you press enter or delete or whatever to get in the BIOS and you go through, change all the settings. Who's done that before? Everyone, right? So we can actually do this programmatically. There's a Linux API that can do it on a lot of hardware. So we actually just have this firmware attribute resource, and you can set the boot order, which is what I'm doing here. You can also, maybe for policy, you might want to set secure boot to on. So this can do that. I'm not going to mess with my machine's hardware, but it works as you expect. So if you manage hardware, could that be useful? Maybe? My God, quiet crowd. So that's a fun little thing. And let's just do this demo. So let's go over here. What I'm going to show you. So I have a slightly different code base, which is, oh, I forgot to open it. Yeah. Where's my editor? So everyone set up WireGuard, and I want to actually solve this problem of transporting keys. So same set of demos before. We set up 3 machines, and then here at the bottom, if you can see that, oh, I have to do the deploy. I'm just going to do a deploy to this cluster. So basically, it takes all the code, it compiles it, it type checks it. Look how fast the type unification is. And now it's pushing this deploy into etcd, and then every host will see that deploy in a second. And what do we do on that host? We basically swap SSH keys between all 3 hosts. That's quite simple. And then we have this WireGuard mesh resource. And what it does, I give it a mapping right here. Oops. I give it a mapping here from hostname to the IP address endpoint. You can do this, automatically, but in this case, I want to specify it manually. And in this case, I'm doing a mesh. So each host is going to have a WireGuard link to the other two, right? So each one can directly go through to the other two. And if you've done WireGuard, so it's done a deploy. Let's see over here. I forget if this is working. So yeah, so it's set up, if you look on the machine here, in the etcd WireGuard folder, this is test 1. You can see that it has generated this private key for test 1. It generates a private key on test 1, and from the private key, you get the public key. And the public key gets transported to the other two machines. And you can see that the other two keys right here came from the other two machines. So what actually happens is each machine generates its private key, then the public key. It pushes only the public keys into etcd. Each other machine is watching for those public keys. MGMT ensures they come from the right person, pulls them down, adds them to WireGuard, and you're off and running. Make sense? And so the key thing is, like, who's using HashiCorp Vault or whatever? Not to be mean, but like, you don't need to store keys. Like, there are some rare instances, usually around bad software, where you want this, but for most of the time, just generate the key on the machine and have it go. So you can see right here, what I'm going to do is I'm going to just kill this demo. I forget if I restarted these. This is the second machine. You can see the pub key for 1. And so let's actually have some fun here. Let's watch, again, in a little loop. Let's cat, let's say, which machine do you want to mess up? Pick a machine, 1, 2, or 3. Sorry? 3. We're going to mess up 3. So we're going to cat test3.pub, and then echo, just have some space, and run WireGuard. Okay, and I'm going to run this in a loop right here. And so what you can see, let's just see if this is working. Okay, so on the third machine here, you can see that this is the test3 public key. Okay, see this x2 over here and this x2 down here, that big long key. So let's say I want to rekey things just because I got scared or whatever. So all I have to do is remove the test3 key. I'm going to press enter on 3. MGMT is going to notice that the key disappeared. It's going to regenerate a new private key. It's going to then instantly, as fast as possible, sub-millisecond or sub-100 millisecond, notice that the public key is out of date. It's going to regenerate a new public key. It's going to push it up to etcd, and then host 1 and 2 are going to notice that key has changed. It's going to pull it down and restart WireGuard, and we should be back and running. Does that sound cool? How long is that going to take? 5 minutes, 10 minutes? Who wants to guess? 100 milliseconds? Let's give it a try. So you ready? 1, 2, 3, boom. And it changed. See that? Is that fast? Can I get some applause? Thank you. I've been thinking about this kind of use case for years because this DSL just builds these systems. These are 2, 3 systems out of thousands. And what I'm most excited about, genuinely, is seeing the use cases that you all come up with, right? I have personal opinions about how infrastructure should be built, but I'm not dogmatic about how you build your infrastructure. I mean, hopefully you're not like my bank or my healthcare provider or something, but it's really about giving you the tool that allows you in a day to build a really complex distributed system for exactly your needs. And for most of you, you won't even have to touch MCL. We have modules called the meta modules that group a bunch of things together. So you have a small business suite module that sets up, workstations, file server, WireGuard, glues it all together. So you don't need to be an MCL expert. And obviously I'm, to sell you services doing that because very poor. But right? Battery change. Swap. So yeah, so the kind of WireGuard thing. See some more demos, or are you fed up? I don't think they want demos. There you go. This is not F1 style battery swapping. Come on. All right, no, thank you, Han. So yeah, so that's the kind of thing you can build. And you'll see another one of these fancy demos tomorrow. Where are my slides? Oh, there they are. So I've showed you some firmware attributes. WireGuard, I'm going to show you some stuff so we can actually use MGMT to build like clusters of hosts. Think VMware alternative, but built in pure MCL. So if you have a customer or if you have a shop that wants like 100 hosts and you want to just cluster automatically them together and have virtual machines and build them and move them around and not pay VMware prices, I'm the guy you want to talk to. Proxmox, this is like old style GUI management. Think getting all the fancy fun stuff with the UI that you want and being able to do fancy rolling releases and migrations and stuff, you'll feel very powerful. Fun little thing. So what about monitoring? Do we care about monitoring? So I'm going to, with permission, log into a customer machine. The customer has approved this. So what I've done is I have a customer that has a fleet of some server stuff, mostly workstations, laptops, and routers. They all run Linux because, you know, I'm not really doing Windows stuff so much. We run Fedora, and every 6 months there's a new release of Fedora. And so the policy of this company is basically to run one of the latest 2 releases, usually N-1, but there's some exceptions. And we want to keep track of this, right? We let the users kind of be the boss of their own machines. We don't, you know, we want to give them some privacy in their space, but we do need to track if they're being updated. And so MGMT runs on all of these machines. It connects over SSH, so it's very secure to the home server. It doesn't have to open up any scary ports. And I'll show you the example right here. This is a snippet of the code that is in the MGMT code base for the customer. Oops. We just have this small class. We have a KV resource. We give a unique key to it. We have a value, which is this. This is just trimming the space. os.read file is reading a file on each user's machine. Does anyone know what this file contains? Yeah? You've seen this before? Yep. It'll say like, you know, whatever. And so this is the only snippet of code we have to include in the code base. And what happens is whenever the OS release changes, MGMT notices the delta, so it's not constantly recomputing. It notices that change and then pushes that new value up into etcd. And just right here, I don't have a GUI for this because I don't really need it. I'm kind of a CLI guy. But I'm just querying the etcd database with this prefix phone home. And you can see here, I won't scroll up forever, but you get the idea. So each host name, you know, there's a whole list of them. You have the string, you see the host name, router 1, router 13, workstation 12. There should be a laptop here somewhere. Yeah, you can see Lappy 8 over here. And each of them says what version they're on. So 42, 43, and so on. And so we check this manually at the moment, but you could have a script that is even an MGMT that notices, hey, something's out of date, send an email, or something's out of date, notify the user, or something's out of date, shut down their machine, whatever you want. Make sense? Not flashy, but very useful. And like I didn't have to spend like, I don't know, a year setting up Grafana and Prometheus and all these things, which I also still want to use, but not for most common things. Yeah, any questions about that? All right, thank you, customer. You want to see some more demos, or have you had enough? Huh? Okay. More boring demos. So I have some code here called type error. Oops. Can anyone see what's wrong with this code? What? This is not Go. You mean Golang? This is MCL. Good try, though. Is Felix here? By any chance? A contributor named Felix got me started and wrote some initial code for this because I'd been kind of lazy, and I polished it up, and it's pretty good now. So we do something called type unification. So this particular resource called print has a parameter called message, which requires a string. And our language is type safe because we do not want a type error or some sort of type coercion to like blow up your logic and delete a data center. Make sense? So we don't allow you to add a string to an integer. You have to, do an str to int or something like that if you want to, or printf. So let's run this example. It's going to be the most fun example ever. I just have this debug flag. Okay, so I'm going to run this here, and instantly, unification, type error, string is not int, gives you the file name and the line number and all that jazz. And look at the little arrows. Is that cool? So that's cool, right? There is a catch. Not every place in the entire compiler has these errors. There's a few places which are not annotated because we have to plumb it through. So there are a few rare places. It's kind of annoying. It's not perfect, but you can help improve these, or Claude code or whatever nonsense. If you think it's any good, don't send me patches that are garbage. If you want to write them and it works and you've tested it, sure. But 99% or 80% of the time, let's say, you just get the error and and this is super fast. So like it's I don't know, we could time it, but I don't know how many seconds that is. It's not a lot. So the type unification once upon a time was kind of slow. It was like second level. Now it's really sub millisecond or sub 10 millisecond type unification times. So yeah. More demos, or have you had enough? What else do I have? Oh yeah. Okay. Do I have a volunteer in the audience? Ah, yeah, you, sir. Hi. Would you like to lend me your phone?
Absolutely.
Is it on?
Yeah, it should be.
Okay. So it turns out the conference Wi-Fi has some nonsense. I don't see your thing. Oh, I see it. There it is. Oh. So I'm going to actually log in. I don't know if this is going to work because it's on a friend's server. So what we're going to do is we're going to go over somewhere. Where is it? Too many windows. Did I close it? Oh, here it is. Great. So is that up? Yes. Thank you, Joe. So what I'm going to do here, I'm going to actually just open up a WireGuard tunnel to a friend's computer. Let's see if this actually works. Do that thing you did last time. My friend's on some questionable internet. Long story short, if you look on the right here, does anyone recognize this?
Yeah.
What is it? Yeah, it's the BMC on Supermicro machine, and we're trying to ping it. It sometimes doesn't wake up because it's on normal internet it's fine. But what do you think, Joe?
I'm not sure.
We'll see what happens. Let's take this down again. Bring it up. Okay. Let's see. How about now? Come closer. I think it's a latency issue. Basically, we have a resource to talk to and manage the BMCs. It doesn't work with every piece of hardware in the world, but it's pretty good. And if you obviously have hardware that you have a lot of and you want it supported, that's something we can do for you. And so what we do is we have, show you how it looks.
You try it now.
Yep. Oh, okay. Oh, it's up. It's working. Great. Yeah, so here we go. It's pinging. Thanks there. So yeah, we can connect here, log into this BMC. Perfect. Now I got to remember which example it is. What here we have, you can see that the host down here, if you can see that, it's powered off. And I think it's this one. Let's check. Joel is a friend of mine who wrote this library for talking to BMCs in Golang. And so what we do here, we have this, we have one for managing the firmware, one for managing the power state of the machine. And so we just put the connection parameters here. The password is admin, so please don't mess with his server. Just kidding, it's over WireGuard. And so I've said I want the power state to be on. Okay? So basically push the power button on the machine. So let's run this over here. Run Mgmt, and so it's now talking to the BMC, or it should be in a second. This internet, again, a little bit sketchy. We're going to watch over here. We'll watch this red power button here. So it got the state, it was off. It set the state to on, and you can see this went green here. not super exciting. The BMC software is kind of clunky, to be honest. Most BMC controllers don't even have good event systems. So unfortunately, for most of them, we have to actually poll, which is, you can see it's doing it. And for this demo, I'm just polling every 10 seconds. But what we actually can do now is we have a provisioning tool to basically install the base OS that is written in pure MCL. So you can actually take a fleet of machines, you barcode scan the MAC addresses, or just tell Mgmt to take anything. It'll discover those machines, it'll boop, boop, power them on, install Linux, install Mgmt, and you come back after internet speed, and you've got a full data center of VMware hosts, or anything like that. So really, like, greenfield, 100%, and if you want to refresh, you can see that the machine should be powering on. Again, kind of slow. You can see it's currently on, and these machines are kind of slow. The hardware boots up. But yeah, so that turns on and off the machines. There we go, starting to boot up. Hardware, BMC hardware is just garbage. It's just horrendous. We need to have open source solutions for these things because it is just so many hacks, and it doesn't have to be. So I can't fix all the problems, but I can do the best with Mgmt. So if you have hardware, this is one way to do it. I'm going to kill that. And another thing we can do, obviously I'm going to turn this off to be a nice citizen to my friend. So we just run this again and just pull the plug on that. While that's going, yeah, basically mostly. So it notices it's on, it's setting the state to off, and in a moment when this slow web UI realizes what's going on, it will, see, it went to red, and this will slowly say that it's shut down. Make sense? Yep. Kill that, and look, it shuts down in a second, so very cool. One other demo, which I don't think I'm actually, well, I can run it if you want, but basically we have a similar thing for firmware. So if you want to do a firmware update, imagine you want to even do this through your fleet. Remember how I showed you rolling through the whole thing? The thing we did was an exec resource, but you can just literally change 3 lines and have that thing be a rolling BMC firmware update. So you take down a machine, do the firmware update, does it succeed? Yes, put it back into the set and go through automatically, and now you have a rolling BMC firmware updater. So same sort of thing. This code actually does a really smart thing. It'll block the BMC resource from like turning off your power when you're doing a firmware update. So all the smart plumbing stuff, we did that for you. Very nice. So yeah, and so you put a binary. You put the hash of the binary if you want to be sure that you get the right binary. Do you want to run this or no? It's surprisingly boring for a demo, but you get the rough idea. Does that work? Yeah, like today's demo is updating BMC firmware. Okay, so yeah, so that's that. Let's go back to the talk. What did I want to show you? Showed you those demos. Showed you those demos. I have some great demos. Oh, and another silly dumb thing, but we have also JSON parsing. Oops. So these are all examples. So if you want to look, you can see that we can pull in JSON pretty easily. So if you want to see so we don't have good syntax highlighting. It's kind of like a dumb thing. If you can contribute syntax highlighting that is better, then do this. So we have JSON decode functions in the language, part of our standard library. So you can actually put a JSON value, a JSON file with different parameters into Mgmt and have your own custom web UI or tool that saves that JSON file, right? That just writes it out somewhere. Mgmt will notice that you change that JSON data, and then all those values will just stream through. So you could build a custom web UI around a whole Mgmt like workflow, and your boss will be like, how long did this take you to build it? And you'll be like, 6 months, but you really did it in like a day, and then went on vacation for 5 months and, big salary, right? So just saying, don't do this, don't do crimes, but yeah, if you want to see some examples, silly kind of thing, and then even here, you can actually, we have this flexible version, so if there's there's missing fields, it'll kind of handle this gracefully. So kind of the most boring demo, but you can try all these things out. They're all in Git master. So yeah, so fun JSON. I think that's enough for today. Just a few updates. So we have version 1.0. We're actually 1.02. I'm kind of conservative with version numbering. It kind of pisses me off that Android and all these like big companies, oh, version 72, like it's just a game. So don't trust the version numbers. Trust that it's pretty safe. We have a continuous release repository. So if you want to run the main branch of all the latest updates, this is what I'm actually running on basically almost all the customer stuff I do, or all the customer stuff I do, because all the changes in Git should not break things. So we just run and it just works great. We're making more and more MCL code. Some of it is public. We have products that you can just use as a consumer. So setting up routers, virtual machine hosts, workstations, all these sorts of fancy things. You just like deploy them and off you go. And I showed you some BMC stuff. Future work, there's always stuff to do. We need more docs. I've got to do some hiring for engineering people. I don't have huge budgets for this stuff. So if you're really good and you want to learn a lot and you're super cheap, you should definitely reach out to me. Also, if you are a company and you want to kind of sponsor my small company, we're basically putting near 100% of the money into engineering to help things grow even faster. So I think I'm a good company to support. More prepackaged tools. I think it's pretty fast. Excuse me. We're I think faster than basically all the tools, but there are some corner cases, like if you have like 10,000 hosts or something we could improve on, and I want to like kill it, right? Like rocket ships. So and working on products based on MGMT as well. So let's just recap. I love the recapping jokes. Sorry, it's in my slides. I don't like making slides. We do have an MGMT config channel on Matrix. We have this MGMT config website that you saw. My personal blog, the GitHub page if you're interested. If you want to see the demo stuff that we're going to show tomorrow, there's a YouTube video if you want to see it before or watch this after. The company, m9rx.com, is my company that's sponsoring this travel and all this work on MGMT. So if you want to give us some money, we'd certainly appreciate that. We're looking for partners to kind of develop relationships, get conversations going about the problems that you are struggling with. And I'd love to hear about your hard problems, because I might be able to whip up a solution in a week or a day or something like that and show you how you can deal with that annoying piece of your infrastructure that you wish was better. So I'd love to hear those use cases. Again, I think most of you are going to come up with the solutions that I haven't thought about yet. But yeah, I'm Purple Idea on Matrix and Mastodon and GitHub and Gmail and m9rx.com and so on. So don't be shy, send me a mail. Also, we do consulting and training and stuff like that. So if you want to have me come to your cool part of the world, I would love to do a business trip. So yeah, for fun, tomorrow, Andrew is going to give a great demo and talk as well about MGMT stuff. So definitely come for that. On Wednesday, there's workshops all day. There's a morning session and an afternoon session. You can come for the whole thing. It's going to be relatively freeform, but I have VMs set up for you to experiment. So you just have to bring a laptop with SSH. You do have to register. It's free. You can even try and register on site, but you have to just basically give me an email address and a public SSH key so I can give you access to machine. So that's fair, right? Not going to spam you. I'm not going to send you marketing crap or anything like that. If you are a seasoned Golang programmer and you want to get involved in the internals, then on Thursday and Friday this week, I have a private engineering meetup. Just some smart Golang people. We're going to be hacking on MGMT. We only have space for about 5 people total, so we have 1 or 2 spots left. So if you are interested, I can't guarantee you a spot, but you can certainly send me an email and I can try and squeeze you in for Thursday and Friday. What else? Thank you so much for listening. I'm happy to answer questions, and I also have some stickers if you want. We have the classic MGMT stickers for free, and if you want to donate $20, I'll give you a special Patreon edition MGMT sticker while supplies last. Thank you again. Any questions? Do we have time? Do we have another talk here? think we're, yeah. So if you want to come up and ask your questions, I think I'll let the next speaker get going. Is that you? Yeah, absolutely. Let me just untangle myself.
I can start already? Okay.
The reflection time was 7 minutes ago.
Okay. So welcome everybody. I'm going to talk about communities and how communities can evolve to some kind of business. And the problem is more not if it's possible, how to do it, but more if it's possible and what kind of aspects does a community have to take care about. I have to speak louder? Okay, I try to do so. So my name is Martin. I'm collaborating.
Also use another mic.
Another mic, that one.
Yes, all together.
Got it. Better? Perfect. I hear it, yes. So my name is Martin. I'm collaborating with the Vox Populi community, for example. And this is also the part where the origin of this talk comes from, because the Vox Populi community did some major changes. Well, they were forced to do so. And this is now some out of the outcomes, what we have talked about and what we have tried to do. Maybe everybody knows about this picture. As usual, open source is the essential part in IT. Everybody knows that there is maybe some little thing that converts YAML to JSON. It's maintained by a single person since 25 years. And it's only one person. Once in a while you get a new release, but it's the foundation of everything you're building on top. And on top you have your huge stack of things that just rely on some very small functioning properly. So, as I mentioned, it's the essential part. We see it everywhere. Even in commercial enterprise-grade platforms, there is somewhere open source underneath. And to be honest, most of the stuff that we nowadays would be impossible to do at all if it wouldn't be based on open source. There is a reason why this is for. This is something I'm coming on to later for. So the nice thing is open source is community-based, so people talk about, people agree on standards, and then they fulfill these standards. And once in a while, they might change the standards, but at least it's versioned, and you can rely that the old version is working, and it's not just breaking, like unversioned APIs, for example. The nice thing that I find very interesting is the way how communities collaborate. You usually see people from different locations, different languages, collaborating together. Sometimes it needs a little bit more explanation on what is meant when you say foo, so everybody agrees on, okay, now we have a decent understanding. There is no big boss, so it's almost based democratically. So you say we elect someone, and once in a while, usually every year, there's a re-election on who will be the leader of this project. Sometimes it's biannual, so every second year, but sometimes people do this every year. As I mentioned, it's the core of open source that there is no one saying this is the way to go, this is the path to go, and there is no venture capitalist that says I have put money on you and now I want results and I'm defining what I want to have now. It's the community that makes the decision. So when you see something new rising up, you usually see that there is some company behind. So some people maybe, they found a small company by saying, okay, we need some funding. We put together our resources so that we can work on this specific open source topic. The nice thing is this picture, I learned afterwards, small letters underneath, this was for distributed from Perforce back in 24, so 2 years old, and you can see 2 years are almost eons when it comes to what people or companies or organizations are saying and how they are acting. So especially in the past decades, I'm now having a longer look ago, many things have changed how we do things. And on every change that is coming, people come up with new ideas. So there is the idea of changing something, and then people say, okay, this is a nice way to do it, but we need to automate the stuff, for example, or we need to improve it in a way. So there's even more open source coming even to existing tooling. Sometimes it might happen that the company gets interest. So interesting for example, venture capitalists. So the venture capitalist now enters this company and saying, hey, you're doing great stuff. Here's tons of money, and please ensure within 10 years we get at least double or 3 times of that what we invest in you back from you. So this is the point where this small little open source based company now becomes a business. And that's always a dangerous part for the open source part of that company. As you can already see, where this will lead through. Within the past few years, we had changes. So now having a smaller view on the time scale. Let's consider OpenTofu. Let's consider Redis, going from open source to closed source, moving back to open source. And some companies just do one step, moving from open source to closed source. So why are these companies doing that now? Well, the business of the company, which is now a company and no longer just an open source community, have to fulfill the venture capitalist requirements. Venture capital get money, the people that lend you the money or give you the money. They have demands, they have expectations, and for sure they are not just donating money to you, they are investing money in the company, and they want to have a return of invest. When you just do open source, the company might start struggling fulfilling these requests of venture capitalists, and then managers come with the idea, well, let's stop open source because we are such a cool company and we have such a cool project and everybody is willing to pay for us. Might work, might not work. What definitely might happen if you have a vivid community that has an interest in the product that you're doing into this open source project, then a thing might happen that the community says, okay, we're forking. It's still open source, so the license allows us to do this and continue the work on an open source basis. Something we've seen in several projects, Vault and OpenBau, for example. But open source doesn't mean that everything doesn't cost anything. So even an open source community must somehow spend money for certain things. A couple of hours ago, Tim mentioned that the Vox Populi roundabout consumes 4,000 euros per month for CI runners on GitHub. Ooh, how does a community cover now all these costs? So there are costs for open source communities. And it's not only about the runners, there's even more that you have to pay for. So runners are the most first approach that you say, okay, I want to test something, I want to build something, I want to automate the build process. The next thing is maybe you want to ask someone, well, can we have a review of what we have done so far? Maybe you want to ask a professional company, hey, can you do a security review? And of course they might say, well, we can make you a cheaper price because it's open source, but maybe still pay us a little bit. You want to make it possible for members of your community to attend the conference. So we have plenty of people working at companies, but these companies don't have an interest in sending the people, for example, over here to Ghent to configuration management camp. But the community says it's an important member of the community. We want that person to be here. So that's the point where the community maybe have a look into covering costs because the day job won't pay for it. Other things, a bounty program. The curl project, CURL project, recently announced a bounty program. Okay, it was cancelled, but not due to missing money, but due to too much AI nonsense that came into this bounty program. But at least you want to provide someone with some money if it says, hey, you found a bug, that's awesome. So I would like to say thank you and thank you financially wise. Or, like James said, have some nice stickers. So have something that the community can identify with. So there are costs, it's not really, maybe not high costs, but at least the communities somehow need to look forward on how to collect money to make it possible for the community to run and continue the development. So the question is there a way how a community can become more a business? The first thing is you must consider how much money is it that you need. Unluckily, I have no timestamp for the 2024 goal. This is from ntp.org. And I have no way understanding why they have increased from 18,000 euros as a demand to US dollars to $1 or $2 million. That's not the thing. It's more about how much money are communities able to collect via donations, for example. So open source is not free beer. And even if we afterwards go over to the social event, there is beer free of charge because someone else has already paid for it. So open source needs proper funding. Otherwise, open source projects will just get discontinued. I still remember a couple of years, many years ago, where the author of GNU-PG was shouting at the community saying, hey, I can't make a living, I can't afford food, I can't buy new clothes, I'm just doing GNU-PG and nobody pays me for that work because it's an open source project. Luckily, he received some crowdfunding afterwards, but hopefully that's not something he has to repeat every year again. So, which options do community have when it comes to the financial aspects of a business? So why do you want open source community and business at all? So what makes you believe that this is a good approach, that the community should become a business? The first thing, the members of the community are the real subject matter expert. They know about the thing. They know about the code. They have developed the code. They know about the pipelining. They know about the log structures. So even when they see the log flies flowing by, they might already recognize there's an error and there's an error, because just from visualization, there's a different pattern visible. So you don't have to read every line of the logs, which makes it easier for the people to identify issues. It's developed in public. It's usually, so hopefully everybody does that in public CI runs. And what we see sometimes is that the community says, wow, there's a nice open source tool. Let's integrate this into our thing and just build something around, switching colors from yellow to green, and then say this is now an enterprise product, dear customer, please pay for it. Yes, there are companies that understand that the basis is open source and they contribute back. Unluckily, that's the lowest number I've ever seen. So not many companies provide back to the community. So why, again, the question now, should the community act like a business and try to get their value? What approaches do we have, and why should it be possible for a community to do this at all? So the first thing I mentioned it, the community members, they know how the things are working. They develop the code, they write the documentation, they know about the structure of the log files, they know about the configuration options that are available. I still remember while being at a customer, also as a full-time employee, we had some issues with a Java-based application, a standard application, and we were checking with some performance issues. And it took the company around about 6 months to ensure to buy someone from the community. Of course, that person was highly expensive, but we had the first four person, and all these persons, we said within 1 hour, no, you can't support us, because what you are saying and knowing is what we already know and what we have already tried. And that person showed up and was asking, okay, why do you leave the commands inside? Why don't you configure these and these options? And we were asking, whoa, they are not documented. You have to read the code. Then you know that there is a flag for performance issues. So the open source developers are the real expert of that tool, hopefully. You know the code, you know how to analyze the stuff, you know how to run it in a proper debug mode, and you will find issues easily. So the next thing is, even when you now say there's something not working at a specific installation, for an open source developer, it's quite easy to say, I'm preparing you a patch, I'm giving you a new release, I'm adding that new feature, please wait 24 hours for the build process to finish, then download the tarball, and then you have the solution at hand. So also a benefit for the user side, and even if that's a company. So maybe some people are old enough to know Pet Shop Boys. They once brought a song called Opportunities, and we can do a slight variant of that and saying, you get the code, see, you get the code, not you got the code, you get the code, you got the brains, so please make lots of money. So let's start doing business as a community. And then there's the big thing, but, that is happening. It's not that easy to start a business. Usually you find something like this. You have to build a business plan, you must make your finance, you have to create a brand. Okay, we got the brand already because we are a community and the tooling is already in use. But you must do something like a legal structure and many, many more things. Opening a bank account, for sure. Nobody would like to throw money on you in real money. They would like to transfer money to you. So a business needs, now again, some repetition, business plan, bank accounts, a lawyer. at least access to a lawyer in case that there are issues. Is it possible to do that with that license? Can we integrate that tool over there? And you need your customers. Okay, good. We have everything at place. We have an idea, we have a plan, we have a bank account. I know a lawyer, so he might be helpful for us. And we already have customers, it's our user base. So good, now let's invoice our customers and ask them for money. So open source now enters the stage. Many years ago, an open source developer stood up on a stage wearing a suit and a tie. And usually he was never wearing a suit and a tie, only at this conference. And he said, open source is serious business. And when you do serious business, you're talking about serious money. And when you do want a serious money, you have to wear a tie. Otherwise, the opposing party wouldn't accept you as being a business partner. So you access your first potential customer. Ask them, hey, this is the thing we're doing. We have a support plan. We have everything ready. We even have some features that might paid customer get upfront prior we make them public again. So what is the customer asking for? Well, first there's the finance department. It asks you, do you have a VAT ID? Oh, we need to get that. Okay, wouldn't be that much of a problem. We move over to the finance department, to finance government organization and try to get a VAT ID. Legal is asking somehow for document. Oh, wait, legal? We want to do business with the customer. We want to sell a support plan. So what is legal now has something to do with our business that we want to do. Well, legal is asking for an extract from a commercial register. What? Yeah, you have to be a company. So you have to be either a non-profit or a profit company, but you must somehow be registered at a local government organization. They might even ask you for even more, saying, we have specific laws here in our country. For example, equal pay. You must confirm that you're paying the same salary, whether it is a human being or a non-human being. You must pay a certain amount. You may not go below a certain amount. And you as a company must ensure this. This is the legal part. Oh my God. Okay, legal documents. I know now why I need the lawyer. That's not all. We have companies where we then go on and security is coming up and says, okay, yes, you want to work with us, you want to integrate your tool into our infrastructure. You see, we are very security concerned, and therefore we need to know who's working for you, who's coming to us doing the job on-premise. They ask something for where were the people born, where have they lived the past 10 years? Why is this interesting? We need to get a record and an understanding, and we might even go to some government organization and ask them, does this person have a criminal record, for example? Does one engage with unfriendly state? And now again the next problem, depending on the country you have the customer, you might have a different set what this government identifies as being unfriendly states. As usual, put people together, and sometimes a few people don't like each other. And the same is what we have with governments, unluckily. They ask you for signing an NDA. So please don't tell anybody that we are using your product. Don't tell anything about the infrastructure. Don't tell anything about what we are doing. As you see, all this is very difficult. It means you cannot just be an open source community and start a business. You must become a business. That's what was the point that we were looking for. Because we like the freedom that we are a community, but we still want somehow to get money for our things so that we are able to support our community, to support the further development. Business, again, must follow local rules, and now it depends on in which country are you registering your business, and every country has some different rule sets. Everything you want to pay, you want to get money, be assured there will be one government organization that will be directly at your door, maybe not directly, but at least after 12 months, they are asking you, you had income. When you have income, you have to pay taxes for that. So which country do you register now? Where do you pay your taxes? So usually businesses must be registered at a government, and it can either be the business, so the government needs a legal entity, so someone they can sue is in case that you do something wrong. And this can either be a human being or an already registered company. which has then again maybe a human being being responsible for that company. So it doesn't sound that simple anymore compared to, okay, we just approach a customer and ask for money. So open source and business is quite difficult. The first thing you might want to reconsider, what kind of business would you like to do if you still want to do that step? There are several ways. You can either be a non-profit organization. That helps you with the tax part, because usually non-profit organizations are exempt from taxes. And again, different between the US and some European countries. What is a non-profit organization, and are you exempt from taxes? Or you would directly become a standard commercial organization. A decision you must make. So are there other ways to get money from people? So especially from companies, because you say, well, I don't like my community now to pay for something. I want the big company that uses my product, that make big money from this little piece of software that we are producing. I want them to say, can't you provide a share to us because you're using that tool? So there's the possibility of doing donations. There are plenty of ways, I'm coming to that later, or you do invoices. Invoices is the stuff that we have already talked about, which is very hard to do. On the other hand, if you ask at the company, go to the finance department, hey, please, can you donate 5,000 euros to us? They will ask you, okay, what is it that I get in return? Honor. Well, honor is not something that we have on our list of can't we buy something from you, not just honor? Well, not difficult. Well, maybe we can even give you an invoice for that. Okay, I get an invoice, that's nice. But I need to get something back from you. And there are even companies, even if they are willing to give you the money, they will ask you, I can't do it via your way you mentioned it, because then I'm automatically registered as being a sponsor for your product. But I don't like to appear on that page. So I would be willing to pay you, but please make it a hidden thing. So it shouldn't be obvious that we are founding now an open source project. See many different problems. Again, the next thing is when you even have the possibility of collecting that money. How do you pass this money on now to members of the community? The members of the community might live in different countries. Different countries have different regulations when it comes to transferring money into different countries, to different people. And of course, it's again taxes. You're putting money onto someone else. And the first company, first organization that is there saying, thank you, taxes, please, 25, 30, 40, 50%. So the person you're paying now has to pay taxes on what you are paying. And you still have the problem of what kind of legal organization is it that I am as this one producing the invoice? What kind of legal state am I? Also important. What about a community member that has a full-time job at a company? That company does not sponsor the product. And maybe he's doing that in his spare time and he doesn't even use the open source product within the company. Some companies have contracts where you say, if you do some freelance work, you must ask for upfront approval, that you are allowed to do so. And then, of course, I know managers that say, what does this has to do with your work job? So why do you, with your day-to-day work job? So why are you doing this at all? And now I can't tolerate that you now spend 1 day per week for some kind of, what is it that they are doing? I forgot about that. But no, please, you got a contract with us, and if you want to do something different, you're free to leave. Paying people in different geographic regions. The nice thing I mentioned with communities, multicultural, multi-language, means you have people in France, you have people in Sweden, you have people in Brazil, you have people maybe in India, maybe there's a developer in Russia. So how do you pass now money on from a European country into some other countries? Well, you just need an IBAN and you can send the money. Please note that the Federal Reserve insists that you announce payments. You can do that afterwards, up to 1 month afterwards. But they want to know when you spend a larger amount of money. And the larger amount of money somewhere depends on which state are you in. It might be 10,000 euros, it might be 20,000 euros. And then you have to announce this because they want to prevent that you're just black marketing money to someone else. It's not easy. If you want to send invoices, you must be somehow a business, non-profit or profit business. You must be registered somewhere inside a country. The customers, as I mentioned, don't like donations. They said, okay, if you would offer some kind of support level or maybe support hours that we are able to deliver, then I can put something in my book afterwards saying, okay, this is what I have spent the money for. The tech team now has 4 days per week, per month, per year for, in case of issues, they have someone to contact. Who is that person? And even if you decide to become a commercial business or even a non-commercial business, rest assured, it's work, it's time and effort. It's the founding process, it's the registration process, and afterwards you run that company. And every year you have to do the annual financial statements, you have to ensure on tax, you have to look forward on how this everything is working. It's a full day job. Who owns the code? The community or the company that you just have founded? So usually a community would prefer to keep the license, to keep the naming rights, to keep all the rights and not pass them on to some organization that has been founded. So the Greek question is, this all sounds far too complicated. It's overhead, it's management overhead. You need someone dedicated to only doing this without paying him for that work or her for that work. It's not nice. So the idea is, what we came up with is that we say we want to work with business partners as a community. Reliable, trustable business partners. So we want to build a community, and the community itself wants to partnership with businesses that then can spend money for the community. Why is this? Well, in most communities you have people working for a company anyway. So they do coding for the open source community, whether it is documentation, whether it is code, whether it's just opening issues, it doesn't matter, but they are contributing. But they work for a company, and the company is happy that they have people working in that project, because then they know, in case that something is not working, we know who to get into this project, because that is a person that is engaged with that community. So why not approach these companies and ask them, okay, you already have employees within our community, and maybe ask just these members of your community if that company they are working for would not like to become a partner, so that you can collaborate with different partners. Now, the first thing the community does is says, okay, great, we are international, so we need partners worldwide, everywhere. So we just do an announcement on our blog site and saying we are looking for partners. I did Mastodon posting, we are looking for partners worldwide. We have open regions, North America, South Africa, APAC region, and we need partners. And then some companies might just announce themselves as being, yes, I'm here, I can help you. But what are these companies that are mentioning now that they are willing to support you? Are these people that you can trust? Well, to be honest, when it comes to companies and trust, that's always a little bit difficult, because they usually want to take money but less spend money, and you don't know whether they are real, the people. Usually you want people being involved in the community to be a trusted partner. So you must check, is that company that is applying already engaged in the community, maybe via an employee. What happens if the employee leaves and chooses a new job? Then you have your community member working for another company, but that company is still registered as being a partner, but not having the knowledge anymore. Check for sponsoring. So is this company that is applying already sponsoring you? So do they have a permanent repetitive payment once a month, and even if it's a small amount of money? So check if they already do something for you, so that you can more be trustful with them. We even thought about making an agreement between the community and the partners by specifying, we want you may become a partner, for sure, but we want you to pay a certain amount of money or work time to us. Contribute work time or contribute money to the community. Either one is acceptable. Then you must create a web page where you can just list your partners so that partners can be found by other companies that might have found an issue with something, or they need an extension, or they need a new release or something like that. So they need consultancy on your product. So you need to make it available that you have partners to people that are looking, or companies that are looking for potential business partners that help you with your open source project. Why should companies do this? Well, there must be some benefits for companies. You're now talking to a sales or finance department. And the finance department needs to say something, okay, if I provide money to you, I need something in return. What is it that we can get as return? Well, the first thing is, of course, visibility. You're announcing that you have a certain knowledge on a certain topic and that everybody is able to ask you for support. So putting that on the prominent website of the project so that people can find you. This also is a potential source for new customers, for sure. So this is now the view from the business partners. That you might say, okay, if someone is looking for the support for this product and they're looking for commercial support, then they are sure they don't have to go for the community. The community has a list of business partners and you can choose from that list of business partners. This is not a new idea. Plenty of organizations do this already. Had you ever had a look at the Debian Org Consultants webpage? 398 consultants, 53 countries. This information is 2 weeks old. I don't know whether this number has changed already. Maybe you have heard about a product called Kubernetes. And even there you will find certified Kubernetes service providers. And there you already see it's a certified. So it must be someone that proves the knowledge about the product that you are doing. Even at smaller scale, for Vox Populi, we already have 7 companies supporting Vox Populi, so the Puppet open source community edition in European and US. And even if you want to maintain your own infrastructure and boot something up, hardware, physical hardware, maintaining virtual machines, you will find that the Foreman project also has business partners, at the moment only in European Union. Don't ask me why, maybe it's not needed in the US. So open source community needs somehow sponsoring. And for the sponsoring itself, there are already existing solutions. You don't have to build up something by yourself. You just must make a decision. Whom is it that I'm trusting? Whom is it that I want to have in between the organization that is willing to pay money and our open source project? Of course, you can go for the Linux Foundation. Linux Foundation is a little bit difficult because if you want to really be a project that is integrated into the Linux Foundation, you must pass the rights on the code and on the license and on the name towards the Linux Foundation. Then you will be a fully supported project by the Linux Foundation. One of the reasons why the Vox Populi community decided to not go for the Linux Foundation. The oldest one I've ever heard about is SPI, Software in the Public Interest. It's an organization, non-profit organization. They collect money from individuals and companies. You just specify which project on the list on the website is it that you want support, and they pass this money on to the dedicated project. The same does Open Collective, just another institution where you can also spend money, and you just say which project are you spending the money for. If you don't mention the project, they will just share it evenly amongst any project they are supporting. Or you can go for GitHub sponsoring. The only thing you receive is you get a sponsor badge on your account. And GitHub takes a percentage, I suppose 4% of that fee is something they keep for handling the payments. That's the reason why the Vox Populi community says, yes, we're doing both Open Collective and GitHub sponsoring, But the preferable way for the community is, of course, the open collective sponsoring. Which one to choose? Talk with your community. Talk inside the community, have a discussion, check what is possible, check who is the bank, where is the bank account, in which nation is it, at which bank, are there some banks that any of these listed are collaborating with, is it possible to just put any IBAN inside or must be registered in a specific country. Just check with the listed providers that distribute money that is done as donations. So, a short summary. In general, it is possible for communities to collect money. Maybe less than they need. You have a certain demand for money and then you just must look, okay, how do I get now that money? Make that donation prominent on your webpage. So like Wikipedia, they always have the banner on top, we have collected that one, please do some donations. Whenever a company donates money to the community, it must be absolutely clear that the person or the company that gives the money has no right to tell the community what to spend this money for. The community must be free and choose where do we spend this money for. We will get money, but without any further implications, without limitations. That's a very important point. I've seen this a couple of times where the companies were saying, yes, but we want it for that specific thing. And the community just said, no, we won't accept that. Okay, if you're asking for a specific feature to be implemented and you're paying for that feature, yes, okay, maybe that's the thing. But just announcing that we must buy now the cloud resources at your location, that's something that doesn't sound fair because it just means that you do some counter calculation. We don't have to pay for your cloud resources, but you spend it because you gave us the money, but we are forced to spend this money even on your own product. That's not sponsoring. Again, a business may not be allowed to take control on a community. The community must remain independent from any kind of business. And the community must, of course, hold all the rights. So the naming rights, the license rights, the right to disapprove some PRs, everything, this must be done by the community and must remain inside the community. What is it that an open source community spends money for? Tim brought me on several nice ideas on what is it that you can do. For example, is covering travel expenses. You need someone from abroad at a conference because you say, this person is important, this person can talk about the stuff we're doing in a far more better way than everybody else, but this person is living somewhere else. It has he or she has a day-to-day job, and the company the person is working for says, no, we don't cover travel costs. And the person itself says, well, I had a look, but flights, hotel, I'm traveling 18 hours from where I live to that place where the conference is. This is expensive. And how many days do you need me there? 2 days, 3 days, 4 days? Oh my God, okay. This is going to become expensive. And that's the reason why communities say, okay, if you want to come to the conference, then we can ensure that we can cover your travel costs. Bounty program, not only for security fixes, but also for new features. We need to support a more modern operating system. Okay, it's time and effort into building that inside. So community agrees what is the value of that, and then they put it on their website and saying, hey, whoever is willing to take this is the bounty program. And we put numbers onto each issue or feature that we are having. So it's also a motivation for maybe freelance people that collaborate already with that community or that have a specific knowledge, that they are willing to contribute to this project, because it's not just fun, which is also important, but at least it makes you, well, everybody has to pay something, so you get your money for, you get value for the open source work you're doing. What is it that an open source community should not pay for? It's also very important. We see communities that pay for certain stuff where we always wonder, why are you doing it? Oh, we haven't asked. What is it that they haven't asked? GitHub, actions, runners, sponsoring. Just put a question. Ask them, we are an open source project. We need a little bit more than these 2 runners. Maybe we have something where we need a specific architecture. Can't we have a small runner for that specific architecture in a specific region maybe? And then it's up to GitHub to either say, oh, yes, you can have it, or if they say, no, you can't have it. But usually you should not pay for something that you develop in open source, in public. The next thing I see is Docker Hub. People are complaining about Docker Hub by saying, oh, rate limiting, and yeah, I have to check when to pull the container, and I try it every morning at 2 o'clock, and then the rate limit is already fulfilled for the day, and I don't get the container downloaded, it's all open source. Why doesn't the community register at Docker Hub for being a sponsored and approved open source solution? Because for approved open source solutions, you first get the badge on your container, and you don't have any rate limits anymore. You just need to know that you have to extend this and renew this thing every 12 months. I suppose Docker is a little bit afraid of projects that got discontinued and they still have the no rate limit on them, or the project is discontinued and bought by a company is closed source now, and they still deliver the containers for free for that company now. So you just need to be aware, renew that every 12 months. I know organizations that just use the GitHub container registry because they say this is something I can just use for free. But on the other hand, I know companies that saying, yeah, GitHub container registry is nice, but it's more simple for us pulling from Docker Hub because that is an approved source. I don't know to whom to trust more. How about the trusted partners? What is it that you can do? First, try to identify your partners and be sure that the partners are on you as a community, on your side as a community, so that you can together maybe show up as, like, especially towards business perspective, as one big company, even if that might be partners in different geographic regions. If you need to do some things like educational stuff, well, ask the partners to please contribute. Either use sharing training material so that every partner uses the same material, and every partner is asked to collaborate on the training material, on documentation, whatever is needed. The open source communities should receive sponsoring from their partners. Should. Personally, I would say an open source community must insist in sponsoring from their partners, because the partners are doing business, they want to earn money, and sorry, pass that money that you make with that open source project, please, back to the community. Okay, keep a certain fee because you have put efforts into things, but at least the remaining money should be sent back to the community. The financial aspects should be made clear and public, maybe even in a public wiki, on a public markdown file inside your repository, so that they say, these are the rules that have to be followed by partners and the community. Make both sides. What are the tasks that the community must do, and what are the tasks that the partners must do? Make this public. An additional idea on how communities and partners might be able to collaborate. Maybe these are weird ideas. As usual, my ideas are often weird. The first thing is someone shows up and says, hey, I've seen it and we want to become your partner. And maybe that even if that company has members of your community, ask them now, because it's another person. The company gets registered, so it's a legal person. So ask that legal person, yes, we can add you. Please do a donation. Make it a fixed price. Saying, okay, you get registered on the web page, but you must spend a donation first prior we get you added to that web page. Well, usually you have small companies in the beginning because they are using your tool, they are interested in what you are doing. And in a later period, big companies learn, oh, wow, that's super cool what they are doing. So we're jumping on that running train and we can make more money. So why not increase this donation fee over time, or even make it depending on the size and the revenue of the company that would like to become a partner? So that you say the early adopters will have a benefit by paying lower prices to get registered, compared to some huge company, multi-billion-dollar company that now shows up at you and saying, oh, we want to become your partner. So why not increase prices for them? And an open source community should always insist in their partners in proper support. So the community should have a possibility to say, when the partner does not follow the rules, we will remove the partner and the partner will not receive the donation back. That must be absolutely clear. So the big thing is, please support your community. And this is not only referring to open source projects, this is also to local communities, local business communities. Please try to be supportive with an open mind on open source so that we can build a brighter future. Thank you. Any questions? None. Who of you is working in an open source project and is looking for getting money, getting sponsorship?
Peter has a question.
Peter, I haven't seen this. That's the light over there.
I saw a few links in your slides. Are those links to some maybe like a summary of what you told now, or are those more pictures, the attributions?
I have difficulties hearing and understanding. And the first one is already severe and the second one is more bad.
The URLs in the presentation, are those attributions or are they...
Okay, I was looking for pictures. So first I made it just bullet points and then I learned, oh, this is so boring. I must have changed this. And I was searching for pictures and the URLs underneath is the source where I found the picture. So it's not the source of the licensing, it's more the source of where I found the picture. Okay, I will upload that to the call for paper, to the pre-talks, so there you can definitely find it.
Thank you very much.
Thank you.
That concludes our day here, so if you could all exit the premises, you can go and have a drink across the street.